as usual, gonna wait a second for Twitch to catch up. And as usual, it's when I see stream elements being ready that I know that I'm live. There we go. Perfect. Hello, everyone. Welcome back to the stream. So, we are nearing the end of the refactor. Almost everything has been ported for the analysis phase. The last thing we need to do is plug everything together, basically. There's a few things at the top level that we need to finish. And then it's going to be the long journey of making everything compile now that we've refactored everything. I want to start this evening, however, by fixing mistakes I've made yesterday. I was careless yesterday, so let's start with that, and then let's move on to finishing the refactor. Specifically, the main thing I want to address from what we've done yesterday. Oh, and a side note, I still haven't uploaded to YouTube. I haven't had time. I'll do that as soon as possible. Hello. I'm very behind on YouTube. Sorry about that. And I haven't clipped the things from yesterday. I'll do that as soon as possible. But yeah, I want to fix a few things from yesterday in the first place, because when I was writing this, as I was talking at the same time, I made a bunch of mistakes in this, and I want to start by fixing them. The first thing is, in this, the monad, the M here cannot just be for the maybe A, it has to contain everything, otherwise we would be letting some data escape the underlying monadic context. That's just not possible. So we need this to be here rather than here. That's a big thing. Another thing is this deriving clause is not actually correct. Here, my intention is to say, well, this thing has a shape that's perfectly compatible with a monad, and therefore, let's ask the compiler to write the instance for me so I don't have to do it myself. That doesn't work because this type, there is no known instance for it. It's doable, of course, but there's no known instance for it. What I could do is instead do deriving all of this via another type. And the idea of this is if there's a type that has the exact same representation, so this can be translated seamlessly from one to the other in terms of like runtime representation, then the compiler knows that it can implement the instance by just casting from one to the other because they are representationally equivalent again. So I could say, well, this is exactly like that other monad, therefore I can use the same instance. But if we're gonna do that, I would rather, as a result, just not bother writing it out and instead translating this into an existing monad. And the equivalent thing would be a maybe t of a state t of the state being the diagnosis state, the underlying monad being m, and the value being a. And if I do this, then now I can do the deriving functor applicative monad trans, and I think I'll put a monad IO there as well, without having to do anything. Okay, I think this, however, remains more or less the same. Since the function is no longer visible, it's now in the maybe t kind of thing, I'm going to rename this action instead to be more consistent with how things are usually named. And here, everything will be in the underlying monad. I can just do a do block rather than a let in that I find a bit less elegant. And so, oh yeah, this was because this was written before I had the underlying M on that. Yeah, I was very careless yesterday. So let's start by fixing this. So first, we will do, we have the action here, which is a maybe t of a state t of a diagnosis state of the thing. So we are gonna do, take the action, and it depends on whether we want to write it left to right or right to left. I suppose that in this case, I like writing left to right for this. So the result of this thing in the M monad underneath is going to be, I take the action and I run the maybe t that's on top. I unstack the maybe t that's on top, so I get a maybe value of the thing, and I run the state t to get to like remove the state thing to get the underlying value. To run the state, I will need to give it the starting state, which we have said is this thing, Why the flip is because the type of state t is, well, state t is defined like this. State t is a wrapper around basically this kind of function. Run state t takes for the previous state, returns the result and the new state for some kind of state, some kind of value. So the type of run state as a result is given a value of type state t, return the thing inside, which is takes the state, returns the value and the new state, which is basically the same thing as this, because the function arrow is associative, is right associative. And as a result, a flip run state will be takes the state and then the state t and then returns the thing. So here, by doing a flip run state, I am getting this function and I give it the original state, and therefore it becomes a function from state t to the result, which is what the state t is that we get after we do the run maybe t. Just to be very clear, I'm gonna make this the starting state. I'm gonna give it a name, and I'm gonna say where the starting state is this. I'm gonna remove that stuff. That was just an explanation and that doesn't need to remain in the code. And what else is there here? So the result of this will be, since I've done a run state, I will get the actual inner state of my state monad, which is going to be the diagnosis state, and the value, which will be a maybe result. So I'll get, in the other order that we used to have, maybe a result if the operation succeeded, and the diagnosis state. Which I called, oh yeah, I'm unpacking it here. I'm going to do the same thing. I'm going to just unpack it here. Diagnosis state. So that's the result of this thing. And what I want to do is the same thing I had before, which is this. I can remove this now. Which is, if there was any error at any point, even if this thing succeeded in the end, I want the whole computation to fail. We never want to return successfully in the case of an error. And otherwise, we can just return the value, whatever it is. This will always be correct if this is false, but you know. And I could probably rewrite this, but I think this is clean enough. Okay, so that's one big thing that we have changed. Now, another thing is, as a result of it being in state t now, some of the functions here will no longer work. So we're going to have to rewrite this as well. The whole point of this is to define the monad diagnosis, which is a type class, so a constraint that can exist, be applied to any monad, which is to say, a monad has diagnosis capabilities if it can do a report warning, a report error, a try that takes a thing that might have failed and gives me a maybe value, which contains nothing if this computation has failed, and ensure that given a maybe value, it gives me a computation, like makes it fail if the value is nothing, otherwise continue the computation with that value. So what I want to do is I want to make an instance of this for my diagnosis monad, which is the root of where this capability is implemented, and then explain to the compiler, okay, if we're stacking monads together, and the one at the base is capable of doing all of this diagnosis stuff, then stuff on top of it is also capable of doing diagnosis stuff by just delegating to the one below, basically. Now, however, this has all changed, so we're gonna write this a bit differently, because now all of this I can just use the fact that I have something underneath that happens to be a monad. So I will just be able to do this. I mean, I already was able to do this technically, but it's just more readable that way. Which is going to be, okay, in the case of a warning, what do? We only change something in the state, which is we add a diagnostic at the end. This warning here, a diagnostic, is going to be put in the state by modifying the thing called DS all diagnostics, and we modify it by using this operator to put it at the end of the sequence. And this function returns pure of unit, because this report warning must return something because it doesn't short circuit the execution. And when we want to return basically what C++ calls void, we return just a unit, which is a type that has only one possible value and carries basically no information. For report error, we're going to do something a bit different. Here, we are going to change two things in the state. We're going to modify the state in two different ways. We are going to do the same thing of adding the error that was given to us at the end of the diagnostics. And this any error, I think it will be set to true. Because it starts at false. Because this is, was there any error? So if report error was ever used, regardless of when, or if we do a try afterwards, this is set to true. And here is where we are gonna need to basically fail. This function returns A for any A, so it's compatible within any context because it does not return. I want to check quickly with maybe T what's the best way to do so. I know that M0 will work. I wonder if there's a better way to do that. Like to say this computation has failed. I don't know if maybe T is an instance of monad fail actually. It is an instance of monad fail, so maybe I can just do a fail. Although fail technically requires a yeah, okay, that's exactly that. It ignores a string. So I could just give it a string that feels a bit... But yeah, I think M0 makes more sense as something that just maybe T return nothing. So I think, yeah, I'm just going to use M0. Here, M0, this computation has failed. Now, with this, when we do the try, what are we going to want to do here? We want to look at the computation and check, has it failed, basically. So here, I have this action here. I don't think MayBT has any recovery capabilities by default. I don't think there's a catch in it or anything like this. It has a lift catch, but that's different. I think the easiest way in this case is just to run maybe T of the action. So we unpack the maybe on top. We get a maybe value in the underlying monad. And to then we have a maybe value inside the underlying monad. We just lift it back up. So just a lift of run maybe of the action. And we put that back into the diagnosis T monad. And ensure will be, we have a maybe value, we need to decide if this thing succeeds or not. And I think hoist maybe is what we want in this case. Yep, I think hoist maybe is exactly what we want. But since we are in a wrapper, I'm gonna just have to do a, I can write it even point 3. This is diagnosis T of hoist maybe. Okay. Now, another thing that wasn't working yesterday because I looked too quickly at the documentation is this implementation of try. There's a few things that are broken here. First, I'm going to have to do some magic. I'm going to put a pragma here, overlappable. Let me explain this one first. There must always only be exactly one instance when the compiler tries to find an instance of a class for a type. So if I have a monad and it's looking for like, is there an instance of monad diagnosis for that thing? It must find only exactly one match. The problem is, here I'm saying, well, of course, diagnosis T is an has an instance of monad diagnosis. But here I'm saying, a monad M, whatever it is, has an implementation of monad diagnosis. Actually, this is what this should read. this thing, this shape, has an implementation of monad diagnosis, and it does that before looking at the constraints. So, in the case of diagnosis C, it will find two overlapping instances, two instances that theoretically match this type. So, how can it choose? There's been several mechanisms introduced in the language to fix that problem, and one of them is the pragmas here to basically say, like, is there a default one that is more important than the other? Which one overlaps more? And this one is overlappable, meaning it's the compiler has to choose between a normal one and an overlappable one, it will pick the normal one. Now, the other thing is there is something that is very complicated, and I don't know how much I want to go into details about it, which is this implementation of ensure, because all of the others are fairly straightforward. For instance, consider report warning. Report warning, a type of it is something that takes a diagnostic and returns in that monad, whatever it happens to be, which is this, it returns a value of type unit. Okay, how do we implement this? We are in the context where we have a monad T on top of another monad M, and monad M has the diagnosis ability. So we just want to say, okay, we're on top of something that has a diagnosis capability. How does this thing on top have the diagnosis capability as well? Well, if I can do, since I am in the context where like the thing underneath has a report warning because it has the capability, I can do a report warning of it, which gives me a M of this. And since it's a monad trans control, it's a monad trans, it has the lift ability, which allows me to take something on the thing below and put it in the thing above. I just lift the result and I get this. So lifting a result, trivial. In the same way, report error is we report error in the thing underneath and we lift back up. Ensure is the same. We take a maybe that gives us a value in the underlying monad, we lift the result. But try is where it gets complicated, because the type of try, in this case, will be we have something in our current monad on top, which is of this shape, and we want a result which is the maybe A. But the problem here is that the only try we have access to that we can call, that we know how to do, is the one that takes an MA and returns an M maybe A. So if we want to use the try that exists underneath us, well, we first have to convert that translated thing on top. We need to convert it back in something below. So we need to unstack the monad before we can run the thing and then stack back. The problem is, if we do this, we lose all the context. Because doing a run state, doing a run something, we lose the context of what we had. So if we're trying to do this for a state monad, for instance, a way to do this, if this wasn't there and I was trying instead to say, I'm in the state monad on top of diagnosis, I could do something like this. Previous state get run state of the previous state of the action with the previous state. So I unstack my monad. Then on the result, I do a try, which gives me a value. And then I can lift that back up into my current monad. And then I put the state back. Something like this, where like, okay, I had to unstack things, I had to unwrap things to be able to go below to do the thing. Now I can put them back. That is a way to do this, but I will have to do this logic for every single instance. I can't write a generic instance for anything that is on top of the thing of the diagnosis monad, unless I use monad trans control, which is something that goes beyond monad trans to provide me with some functions that basically provide this save restore mechanism kind of thing for any monad for which it is implemented, which means I can rewrite this thing as something along those lines. So what run MA does is to unpack this run is given to me by this function that is part of the monad trans control. it returns inside the lower monad all of the state I need alongside the result of the thing. So I will get from here everything I need to be able to restore the state after I lift things back up. So I do the run, I get a value in the underlying monad. I can do try like I would like to do because I'm back one step below, and this lift with will bring things back up afterwards. However, what is missing is restoring the state. That's the thing that's missing from yesterday, and I can do that with a bind into, okay, the thing I have lifted back up contains a state to be restored, and I'm gonna just write it immediately because I know what to do, but since it contains a maybe value because things might have failed, I need to do a traverse of a restore t of pure. The only tricky thing here is this traverse, because the thing we're gonna get is a maybe value, because, you know, we have a maybe t underneath. What that means is if the underlying action fails, we don't have state to restore. And what that means is, in case of an error, in our diagnosis monad, everything, all the state of the things that are above is lost. And I want to take a quick moment to illustrate this concept. And I'm going to do it in GHCI directly, I think. Import control monad state and accept. I want to showcase this. So I'm going to use those two monads. So state t. I don't know if I do this, will it show me? Does it show me? It shows me too much information at this point. Yeah, okay, that's good enough. The constructor state t of the state monad is just something that takes this underneath. State is I have a previous state and I return in the underlying monad, whatever that is, the result of the computation and the new state. And accept t of, let's say, string for now. Isn't that oh, because of course that's the constructor. I will need to say at string. There we go. In the case where the error is a string, is something that wraps some value in the underlying monad. It's either a string or an a. So if the thing is, depending on in which order I stack them, the result is not the same. For instance, let's imagine I have a function foo that does, let's say it does, in some kind of monad that has access to both state and accept, so it's capable of manipulating state that is being chained and is able to return an error and short circuit. Let's imagine I have such a function that does put 5, so assuming that the state is an int, we are going to put 5 in that state, followed by throw error, boo, which assumes that, again, we are in a monad that can do that. So the type of foo will be, we are in some kind of monad M that happens to have a monad state S, where S is a number. I could make it actually more explicit by saying this is an int. So I am in a monad M that happens to carry some int state, and I am in a case in a monad that is able to short circuit with errors, and the errors are of type string. And the return value of this is anything, because this function will short circuit because of the use of throw error. Okay, so now if I try to get this value out of the monad, I need to unstack the different monads. So I can do this by, well, running it as a state monad, running it as accept t. If I run it as, let's say accept t first. So I take this foo action and I first run accept t, which will therefore translate it into something like we have seen. Where was it? Here, into a thing underneath either string or a. So if I do that, the type of, oh, I don't have import data function. This will be some kind of monad, we don't know which one yet, and the value will be in that monad either a string or b. And if we, can I make something that will show there? Because it doesn't know. Can I do this and say that the type of this is a state int? Well, no, that's not correct. That's not correct because, as we have seen, it will be of type thing either string b. So this will be an either string, and I'm going to say int here. And why doesn't it have show? Oh, because state doesn't have an instance of show. That's annoying. Okay, well, you see the logic. And now, after I have this state int either thing, I can do a flip run state t, and the starting state will be, it doesn't matter, let's say 0. And if I do that, I get like the result of this foo thing that again is defined like this is left because we did not get a success. The computation failed with an error. The error is boo, and the state contains 5. However, look at what happens if I am in the stack of monad in which the order is different when state is on top of except. I get left boo. I don't get the state in the result. I don't get the 5 because of how the things get resolved. The state of everything above the except is lost. If we want to write it down again, so if when I have except on top, so except when I have except t of state t, well, oops, of string on top of a state t of int on top of io of let's say character, just to have something different, and I run the first step, which is the run except t, I get a state t. This is not Haskell code, but just like I'm typing it here. I get a state t int io of the either string or character, and when I run the run state t, I get in io, the thing underneath, the result, the either string character, and the state, which was an int. If I run it the other way around, so if I have a state t on with an int on top of an except t of a string on top of io and the values of type character, so I have reversed my stack. I first remove the state t, so I get a except t of string on top of io of my result, which is a tuple of the result, which is a type character, and an int, which is my state, and then I do the run except, and what I get is something in io, which, since the thing I just do the run except, is either the string, the error case, or the tuple character int. So the order in which I stack my monads will have an impact of in which, like, what happens to the type system when I resolve them. And in the case where, like, I do this kind of like make short circuiting and recovery in except, everything above it is lost, which is not necessarily a bad thing. It can be what I want, but it's something to be aware of, which explains again why foo and run except and flip run states keeps the state, because the state was below the except, but this one, however, the other way around, I have it somewhere. This one loses a state. So, all that to say that I have to be careful, since my assumption in all of the validation code, for instance, has been, well, I am in some kind of validate stuff on top of a monad that happens to have monad diagnosis. That means that whenever I do a short circuiting by doing a try and it fails, the state that was changed within the thing that failed is lost. So if I do, for instance, if I look at this validate here, I think I do a try. There we go. Here I do result is try of let's look at this definition and call a function. If this fails at any point and short circuits and is caught by the try, the state after this will be the same as it was here. None of the changes that have been made in the validate state will be persisted because it is on top of the except. Luckily, I am okay with this. If I were not, I would have to reverse my stack so that the except stuff or the diagnosis stuff were on top, basically. But I am fine with the state failing because the state is mostly stuff I keep for the result. So in case of a failure, I don't need to keep the modified state. But if I end up having some weird state things, this could be the issue. With all of that said, this is why here we have this is where we have this thing where actually I probably need to do this, where I use run to lower into the underlying monad to get the state I need. I do my try in the underlying thing. If it failed, I don't get a result that contains the actual state to be restored, and therefore when I get there, the traverse only applies when I have state to restore. And with this, I think we have fixed my mistakes from yesterday, my carelessness from yesterday, and at the same time, we've made the code a tiny bit more readable by switching to an explicit stack of monads within this, and therefore being able to just use a do block here for the things that we're trying to do. Okay, now with that out of the way, we can move on to doing the top level stuff. So the end of our long refactoring journey, and then try to compile all of this. The first thing I want to do is the resolution thing. Here is the resolve function that we're going to fix. It's wrong, which is basically the first phase of the analysis, which is, again, I have a name that appears in a thing, like I have a return x plus 3. What is x in this scope? I translate a path, x, into a role. This x is a function argument. It is a let variable. It is a constant. It is a type, which would be wrong, but what does this thing mean in this scope? And then we have the validation phase that looks at x, return x plus 3, and like, well, given that it appears on the left-hand side of a plus, I'm expecting an int. Whoops, x is a type, wrong. You get the idea. So now we need to put everything together. And this resolve that is written here is not the one I want to keep, because that's doing run resolve for one definition, basically. And instead, I want to run resolve on an entire module. I want to take all of the module and resolve, which means treating all of the imports and creating the top level scope, and then running resolution for every definition. So we're going to change this. It's not going to take the base name anymore. I'm going to keep this one out here for a second as I clean this. But resolve will be instead taking a module name and an entire module, and everything else will be done in a subfunction, and this will return. Let's look quickly at the interface thing. This will return a I think it's not going to return a definition cache or any of those things. It's going to return something for which we don't have an alias. It's going to return this thing. A hash map from the base name, which is the name under which it is declared, that doesn't have all the type information necessarily, with the location, and the resolved version of the definition. That's what we're going to want to write. So here we're going to have our module that we're going to just inspect, and we're going to start by doing the top level analysis. Are the names okay? Construct the scope, which is both looking at the dependencies from other modules and looking at the definitions in that module and creating the scope, and then running this thing on every definition. Before that, let's have a look at what a module is. A module is a list of imports and a list of definitions. And I'm going to change a thing here, which is going to break the parser down the line. But I think for the imports, I want the location as well. I want to know on what line they are. I want to be able to say, oh, on line 5, the import here is wrong, rather than saying there's an import wrong somewhere in this file without saying where, basically. So I'm going to make that change, and we're going to fix that later. But that's what a module is. So here I'll have the imports and the definitions. I'm going to need also something else. I'm going to need to know about the dependencies. The compiler, the goal is ultimately to write like a incremental compilation compiler, so I can compile some modules individually, keep that cache, in subsequent runs, not recompile them if the source hasn't changed. Like, we want to do something a bit smart there, but I will need to keep for every module that I have compiled 2 things: the object file that contains like the actual raw bytecode for every function that we can just like link against, basically, and I will need to keep the interface file that contains all of the information about the types, about the definition of functions, of generic functions, and so on. So that's what the interface type is about. It's trying to keep like, okay, for a module, what do we need to keep? I'm not sure actually the module name should be in there. Probably not. I think it shouldn't be in there. Got to think of it. But yeah, it will be for each thing exported by this module. Okay, what's the name, what's the role, so I can create the scope for things that import it. The definitions that have been validated while the process has been completed. The functions, which are the ones that are just resolved, so that's going to be the generic functions for instantiations, and the symbols, the actual like binary that we'll actually try. And I think, in fact, this one, there's going to be more to it, but it's going to be the gist of it. So I think what we will want is to have some kind, either we will want to be in some kind of monad state for this, or I will let the caller decide how to give me this. I will need to have access to a hash map from module name to interface. Like, okay, the dependencies of this module, the things we have already compiled, what were their interfaces? What were the things they have exported? What was the result of trying to compile them? I will need that. I will only need one thing out of this. I will need the exported stuff, the map from identifier to role. But since I will have this underneath at some point, it's easier to just give the entire thing rather than forcing the caller to create a new hash map that like filters this. Okay, so that should be everything I need. Dependencies, module name, and the module. What I'm going to need, if I go look at scope, is going to be things of that nature. Here I have create imported scope that, given the interfaces of the modules and a list of imports, will generate a scope, which is going to be a top level scope of the name of things that are in scope at the top level and what roles they map to. That's a function that already existed before, pre-refactored, that we've taken basically unchanged from how it was before. There is a few things we're going to need to change. Again, we are in a monad diagnostic, whatever it ends up being. But here we've made the change of the with location. And we're going to use this for reporting errors. Because here, so this is going to be, instead of being 4 imports, and this is going to be instead a import with location. And I can do here, this equals located of the import with location. And then here I am going through, okay. And this error here will be we try to import something that doesn't exist. That is going to be a report error now in our new approach. And it's going to take a diagnostic. And a diagnostic, as we have seen earlier, is maybe a declaration, in which case there isn't because we are at the top level of the module, a location, which is why I've added location for the import, and a message. So here, no declaration. The location is the location of the, and actually I'm gonna, so that's what we let here. And I'm gonna do import location is gonna be the location of the import with location. So that I can just create, and I'm going to introduce a small helper function, which is going to be make diagnostic, which is going to be create a diagnostic with nothing as the declaration, and the import location as the location. It's still missing an argument. It's still missing the message. And now here, I can do a report error of make diagnostic of this. Here, this is going to be straightforward. And here we have another case of this needs to be reported as. So this is going to be a report error of make diagnostic of that. There we go. And I think that's all for this function. Perfect. So that's going to give me the top level scope. So we can already call this function, which is from here. So first order of business, we create the foreign scope, remote scope. I've been using remote rather than foreign. Let's be consistent. The remote scope by doing create remote scope. Is it not create remote scope? It is create imported scope. That makes sense. In which case, I'm going to just call this imported scope instead. Create imported scope, which takes the dependencies to have a look at their definitions and see which ones we need to bring into scope, and will require as well the mod imports that we have taken from the module. After this, we have the first part of the scope. The second part of the scope will be parse local declarations, which is going to give me a bunch of things, which we'll see afterwards. Parse local declarations, which takes the module name and the declarations of the definitions, actually. Declarations, definitions. A declaration contains the definition, I suppose. And this will give me a bunch of things. This will give me what is exported by this module, which will be part of the final interface. And this will give me a hash map from base name to the definitions. And an additional top level scope for the things that have been exported by this module. So this will be exported. This will be, the second will be definitions. And the third will be local scope. And in fact, this function is going to return two things and not just the resolve definition. It's going to give me as well, how do I indent this in a way that's readable? It's going to give me the hash map of base name to role, which is what is exported, and the hash map from base name to resolve definition, which is the resolve definitions. Okay? So with this, we need to merge the two scopes together, this one and this one, which is going to be a kind of union of hash maps, because those are just hash maps of like, given that name, it points to that. But there is some subtleties because a key might appear more than once, and it's fine. At this point, it's not an error per se that the key appears more than once. It's just that if at some point the code makes reference to that key, it will be an error because it will be ambiguous. But it's not an error at this point. Which things, I think it's just going to be a map union using a concatenation for the values. But let's have a look quickly at the top level code that hasn't changed yet in, what's the file? Analysis. Foreign scope was create foreign scope, and top level scope was let's combine the maps of built-in scope, local scope, and foreign scope. Yeah, that sounds good. What is combine maps? It is indeed just a union with concatenation. Perfect. I think I like this thing. I'm gonna keep it the same way. Let's keep this, and then I'm going to just get combine maps here is map m union with concatenation for the non-empty list of definitions within each value. But I will need the built-in scope, and built-in scope comes from, okay. And built-ins come from batteries built-in. Okay. Which I'm gonna add to the imports. It was already there. Perfect. So now we have our top level scope that contains all of the built-in definitions, all the definitions that have been resolved from import statements, all the definitions that are local to the file. So we do the same thing here that Haskell does. I don't know if Rust does this actually, where the order of declarations in a file doesn't matter. A function foo can make reference to a function bar declared after. We just create the hash map of all the names, and then we use that to resolve things. Okay, so that's gonna be, hello, how are you? So now we have this, we have the local scope, and we can probably do the thing of running the resolution monad for every definition, because run resolve will take the module name. Actually, do I need the module name? Maybe I don't. I don't think errors use the module name, so maybe I can just simplify this a bit. Do I have anything that uses module name? I don't. I don't think it's ever used. And if I look at resolve info, it's only used in this. And if I look at resolution scope, oh, sorry, I still haven't uploaded on YouTube. I'm sorry about that. I just didn't have time today. The stream from yesterday should be in the past broadcasts on Twitch, on my channel. Twitch keeps them for 2 weeks, which is why that's not super long. That's why I export them on YouTube. But the stream from yesterday will be on Twitch as a past recording for 2 weeks. If you give me 1 sec, I can find the link. Yesterday, yep, the 17th. 5 hours? No. Was it really 5 hours? I guess maybe it was. Despite the crash, it seems that like it actually just kept the it merged them. Oh, it should be this one unless I'm mistaken. There we go. So yeah, I think the module name is never used. The only thing that's used in the resolve info is the declaration name. And even that, I'm not entirely sure. Do I even use that at all? Do I have a ask or a view at any point? I mean, I think, just because, yeah, I need access to the declaration name just to be able to write, just to be able to, just to be able to report errors. So probably, I keep the reader on top of the state if the only thing I need in the reader is just the declaration name. That feels unnecessary. Yeah, it doesn't hurt. I can just do that. I don't need the module name here. So it just takes the declaration name, top level scope, the location, and the action. And this is just the declaration name. Exactly. As soon as I take the time to actually put everything on YouTube, it will be on YouTube as well. I'm sorry, I just haven't had the time. It is the downside of streaming, of spending more evenings streaming, is I have fewer evenings where I can do other things, including updating the YouTube channel. But I really want to push for this, because this state of refactor where we are not making any progress on the project itself and I can't compile anything is fun but a bit frustrating. So the sooner I finish this refactor, the more I can go back to normal, as it were. Here, what else do I need to do? So yeah, I'll just need the run resolve for each declaration. That's fine. So I can go back here, and now I have the list of stuff that is exported. That is this thing that we're gonna return at the end. I have the local scope that has been used to create. Actually, I've called this imported scope. I probably want to do the order the other way around. As in, if there are multiple definitions for, like, I call something a function foo and it shows up in all three of them, in the built-in, in the imports, and locally, I think I want them to be displayed in first the candidate built-in, then the imported stuff, then the local stuff. So since this combines the maps by appending the different possibilities, I think I want them combined in this order: imported scope, then local scope. And now I have the definitions, and the definitions is a hash map from the base name to the raw definition that we just passed. And what we're going to want to do is apply a resolve definition, which is this thing, on each of them. And the only thing is, this has to be monad diagnosis, of course. We will want to do that and run resolve the result to get back into our monad M. And this is just going to be, since we want to create a hash map of the results, we can do a traversal of the hash map. This is going to be therefore a resolved definition, resolved definitions. And we are going to use our true and tested try nested, because I will want to try to resolve all of them, and if any of them fails, yeah, there is, when I do my Advent of Code streams, I try to keep the Haskell I use as approachable as possible. This is not the most approachable project I've ever made in terms of stuff, but you know, a project of that size has requires a bit more stuff. But yeah, we're going to use our true and try tested, try nested, with the AD being, if any of the definitions fail to resolve, I want to catch that error, still keep the errors, but catch them and move on to the next one and try to do as much as possible to collect as many errors as possible. So this is going to be, and I'm going to put it on a first line here, I'm going to iterate, I'm going to traverse the list of definitions. And for each of them, I'm therefore going to get a tuple of the declaration base name and the corresponding definition. Or, yeah, declaration base name definition, I think, is correct. And what we're going to do for each of them is I'm going to run resolve t. So I'm going to have a stacked monad on top of the current one just being whatever this m is, I'm going to have a resolve t on top of it. So I'm going to run resolve to remove it and get back to m. And to run resolve, we need the declaration name, the top level scope, and the declaration, the location, and then the action. So the declaration name is the declaration base name. I'm being more explicit here, but that's fine. Then it was the scope, which is the top level scope that we have created. Then it was the location, and this is definition with location. So this is the location of the definition with location. And the actually, do I need to do that? Yeah, kinda. I could actually deconstruct this. It's going to be easier if I go to location. With location is the location and then the object. So this is a with location, definition location, and definition itself. So here, the definition location, and the action that we run in this resolve t thing is resolve definition of the definition, which is this thing. And this whole thing is going to be a try nested, so that if it fails, we do a try, we catch it, we move on to the next definition, and so on. And at the end here, we only get a result if all of them succeeded. And at the end of this, we can return what this function returns, which is a tuple of what is exported from this module and what are the resolved definitions. Okay, so that's our top level resolve done. Now, we are going to need to write the last remaining top level thing that's missing at this point, which is the validation phase top level stuff. And this, I'm going to change that again. This is going to be validate definition, I think. Because I will want the validate top level function to be something that takes the entire module, processes the entire module, and then returns. So we have some kind of monad diagnosis underneath us, and we have, do I even need the module name for this? I might not even need the module name for this, I think. I think the validation monad doesn't. It has the module name, but do we ever use it? Nah, I don't think we do. I don't think, since the module name for errors is mostly in the location, which is already included, I think we don't need the module name. Okay. So we will need, however, a lot more things in the reader. We're going to need the definition cache, the function cache, the symbol cache, and the resolved definitions that are coming from the previous phase. So we're going to need all of that to be able to know how to handle the validation phase. We're going to need a definition cache, a function cache. Actually, I'm just going to do that. So that's all the stuff we need to know about the context that surrounds us. The definitions that have already been resolved and validated in our dependencies, the cache of all generic functions in case we need to instantiate them, the symbols that have been generated so that if we have to instantiate something, we can look at the cache and maybe copy that instead, and the resolve definitions from the previous phase, the name resolution, that is part of this analysis. If we have all of this, we can return an interface out of this. So we have the definition cache, the function cache, the symbol cache, and the local definitions. And at the end of all of this, when all is said and done, we will create an interface. And an interface is this. So I'm just going to copy it. Okay. I suppose... Can I create the interface if I don't know what's exported? Or can I return a partial interface? Because here, this part of the process doesn't care about what's actually exported. It's the caller that will actually complete that. So perhaps instead of doing this, I will be returning not the full interface, but the relevant part. And the relevant part will be the new local definition cache, the result of this particular module, this module's function cache, and this module's symbol cache. Okay, so this goes away, and we will figure out what to return at the end. It will be something of the shape of like, we will see. But it will be a tuple of 3 elements like this. So what do we do in this case? Well, I think it's going to be somewhat straightforward for once at the top level at least, because this is going to be a run validate t that takes the validate info and an action, which gives me the validate state from which we can extract all the stuff. So this will be... First, we're going to create the validate info, which is this thing. So let's do that. Which, as you can see, is basically the arguments to this. It is the definition cache, to the point that it's even almost tempting to have this being given as is by the parent, but I don't want the parent to know about the implementation details, so I'm not going to do that. But it is basically just that. The arguments that were given to me, this function for this particular phase, we bundle them into a record. And that's the local definitions. And with this, we can do a run validate t of the validate info and some action in the thing. This will give us the validate state, which contains all of the stuff that we want, and a value. And there's going to be a maybe of that. No, we'll do an ensure there again, I think. So we'll have some kind of ensure at some point in this thing, which means the errors will be thrown if something failed, if compiling this module failed, which means the result of this will be a tuple of a validate state and whatever this the result ends up being, depending on what we return at the end of this computation. And the validate state will contain a few very interesting things. It will contain the accumulated definition cache and function cache, which are the definitions and functions, which is what we need for this. It's going to be the VS definitions and the VS functions, which is 2/3 of what this function is meant to return. And the last bit will be the symbols, which will be taken from this. This will have to be the symbols. Oh, wait, no, this is correct. One sec. When I do this, do I put the definition at the end? Result here, and when just result, definitions. Okay, so here it doesn't matter what this function returns, really, because the definitions will contain the result anyway. Okay. So here at the end of this will be the symbols, and therefore this it will be that. So we need to decide what we do here, and at the end this needs to be something like pure symbols at the end of the processing in our validate monad. So the first thing we're going to do in our validate monad is going to be to traverse all of the definitions, which are our local definitions, basically. And for each of them, I will do rather, I'm not going to do, it will be a traverse with key, so I'm going to be explicit. For each of the local definitions, I'm going to get a tuple because this is a hash. Oh, I haven't made this error in the other file as well. Let me just quickly check. Definitions. Where is definitions coming from? Is that a hash map? I think it might be if I look at scope. Yeah, that's a hash map. Okay. Maybe I don't want to make that a hash map because I will need to iterate on the keys and value anyway. And if I want to iterate on the keys and value, I suppose I could do a traverse keys value. Yeah, I will need to do, I can't, if I do a for like this, I will be iterating only on the values and I want the base name. So I think I need to have a look at hash map strict. There we go, that's the one. I will want, there is no for with key, but there is a traverse with key, so I can just do a flip traverse with key if I want. Okay. So instead of doing this, I can do a flip traverse with key of the definitions, and that gives me not a tuple, but the declaration name and the location as a function. And I can, with this, do something that returns, so that try nested. Okay, so that should be fine. I'm almost tempted to introduce for with key. Let's do that actually. I have somewhere in common data hash map strict extra. I have cat maybes. Let's do a for with key. And for with key is going flip traverse with key. And being a flip of traverse with key, it's going to be that, but with the hash map first and the function second. There we go. So now if in here I import hash map strict extra, perfect, I can therefore use for with key of the definitions. And let's see if now this fits on one line or if it's still a tiny bit too big. Let's keep it like this. Okay. Okay, and now that this is fixed, I can go back here, because here I'm going to have a similar problem where I will want to traverse with key. So this is going to be a void of for with key. Well, yeah, it's going to be void, I suppose. I don't care about the result at all. And I will, for all local definitions, and I will get the declaration name and the resolved declaration here, where the name have been resolved, but we haven't done the validation yet. And for each of them, what I will do is validate the definition using this declaration name as the base name and using the resolved declaration as the declaration. I ignore the result. That's fine because it will be collected in the state that will be obtained here with the run validate. I will want, however, to do again a try nested of this so that if it fails, we still try to validate all of the definitions. And here, as a result, I'm probably just going to do a void of ensure nested again, so that if any of them failed, we don't go any further than this. Now that we are done, I can do... So after this, we've done all of the definitions. We've been through all of them. We've checked that they're all valid. We have compiled a full list of types. We can then go on to instantiating functions and creating symbols, which is done with instantiate all symbols. This is going to require a monad diagnosis again. Instantiate all symbols, which is going to be the thing of like, we look at the requests, and while the list of requests is not empty, we update the state. And then we go through the process of doing a try on each of them to try to like process the request, which is this thing. And we do a try, right? Yes, okay. Yeah, we do a try right there. Okay, perfect. And then that instantiates everything. And instantiate all symbols will create all of them. And what are the symbols? That's the result of this, basically. Perfect. So that I just do that. And that gives me all of the symbols as a result, which is then, well, symbols, symbol cache. Well, symbol cache is already, so result, symbols, it's fine. And that's the thing we've written here. And that should be all for this top level function. So in fact, yeah, the only thing that this module needs to export is, and I'm going to do the same thing that I've done for other places, like the resolution, which is, okay, the API is only that function, and that's the only thing that the module exports. That's the case here. We only export instantiate all symbols. Everything else is implementation details. Instantiate all symbols. That's the only thing that this module exports. Everything else is, again, details. And for validation, we're going to do the same thing. That's the API. The only thing exported is validate, and this is the implementation underneath. Okay. There is another thing. There is a bunch of things in the analysis. There is a place, and this place is in validation context, where I try retrieve definition. Where are you? Attempt to validate. And attempt to validate attempt to validate T. That's a too eager replacement. Attempt to validate calls... it needs to have access to validate definition. And the fact it needs to have access to validate definition means here validate definition must be part of the API. But it will also be a cycle, so I'm going to need to create a boot file to fix the problem of circular imports. So validation.hs will have a boot file that will contain the bare minimum required for this to work. And the boot file is basically a subset of the main file that's only used to define what should be accessible, what should be in scope for for the reverse for the cycle of dependencies to work, basically. And it's just those two functions without their implementation will be enough. Of course, I can't have those imports here. There we go. That should be fine. Okay, with that done, with that done, we have only one last thing to do. It's to go back to the analysis. And the analysis is something that will take the definition cache, the symbol cache, the function cache that are coming from all of the dependencies and all of the exported stuff. Do I do this like this? Or do I keep? Nah, I will keep instead the thing I have. I have an interface per module, the definition cache, symbol cache, function cache. I have them in this order, I think, in validation now. Yes, except this will probably be at some point be taken from like some kind of surrounding context, but that's basically what is required. We are in some kind of monad diagnosis, whatever it ends up being, and we take this, the module name, the module, and we return an interface in that monad M that will catch all of the errors. And here, all of this goes away, basically. So this is gonna be remote. I want to stick to remote rather than foreign, since that's the choice I've made in the refactor. All exports, I suppose, and the module name. And with that, with all of those arguments, we can do first. Hello, how are you? Module name, and of course the module itself. Info, let's say. So first, we can do a not validate. We're gonna start with the other one, resolution. We resolve the thing. So we perform resolve on the dependencies, which is exports. So that's the thing, the exports from the dependencies that we need to use, and the module name. In fact, wait, do we need the module name there? Why do we need it for parse local declarations? Do we actually use it in parse local declarations? We do for declaration top level bindings. Aha, we do indeed to create the base names. So yes, we do need it. So we do the resolve. Where is it? Resolution there. The dependencies, the module name, and the module info. That gives us both module exports, which is what this module exports, and the resolved definitions. Then module. Now we are done with the resolving phase. We can do the validation phase that we have just finished putting together. So this will be validate with the remote definitions. I guess I can rename this as like the cached version, like I've been doing. So definition cache, symbol cache, function cache, and fix the order. There we go. And I guess exports is the only one that breaks this thing. Module exports? Nah. Dependencies. So dependencies here. And then we validate with the definition cache, the function cache, the symbol cache. and the local definitions, which are the resolved definitions that we just made. And that gives us the the local definitions, the local functions, and the local symbols. And with that, we can create the result of this phase. Here, we will also have the simplification phase at some point, I think. But the simplification phase, it is at this point broken. And there will also be some questions of, is it optional? And if it is optional, I don't want to bundle it as part of this stuff. I would much rather have the color control whether it's done or not. We'll have to think about it. At the moment, yeah, I think I would rather let the color decide how to apply the simplification phase once we have fixed it. So this will be purely creating an interface, which is again this thing. I'm just gonna copy and paste it. And the exported stuff is the module exports. Oh yeah, I've used module rather than local. It's the same. Module definitions, module functions, module symbols. And the definitions will be the definitions. That makes sense. The functions will be the functions. And the symbols will be the symbols. And with that, we should be done with the refactor at long, long last. Well, done with writing the code. Now, let's make it compile. And that's gonna take, I think, the rest of the evening. A new stop bind. Yes, this needs to be exported. With location, this is indeed incorrect. Wait, why do I have an EQ instance on expression? I don't think I want to have that. I don't think I have EQ anywhere. Yeah, I don't think I have EQ anywhere. I think I don't want that at all. Just gonna remove it. It's the easiest way of fixing it is to remove it. Aha. But that's because, do I want path info to have... Do I want path info to have an equality? I don't think so. I think that's wrong. I think that's a remnant of a lost time. I don't think we want that. Okay. Of course, I do have EQ in a few places. Oh, hello everyone. I think I don't actually want the EQ instances. I don't think I now post refactor have any hash map that requires this. I'm gonna comment out all of those instances, and we will see if I end up needing them. Yeah, welcome. I am at the point where we're trying to compile weeks of work, so this is gonna be fun. I'm gonna need template Haskell in scope. I have template Haskell in scope. It just, I'm trying to create a lens for something that's not in this file. Import is not in this file, so that can go away. I think all of this, however, is. I can keep all of those. Import type, not in this file either. Which makes me wonder if I should actually do the same lenses in the file that has them, past here. Or if I actually never use the lenses for module and import. It doesn't hurt to have them. So let's go back to common and let's copy this. It looks weird at this level of zoom, but that's fine. And I'll keep make lenses of the module and of the import. And I will remove, keep only the prism for the import type. Okay, which is the things defined in this module. Perfect. What else? Typed expression no longer exists, so yes, you go away. Control monad trans control for diagnostic is part of a package that is not part of my dependencies, so let's add that. I might consider removing this warning, we'll see. So I need, it is monad control. That's the wrong character. There we go. Which means I need to compile this dependency now, so it's going to take even more time. Except it was already compiled, so that's fine. Those are all the plated for expression that I think we want to keep. Plated is nice. The only thing is, a lot of this has changed. Because I think oh, that's a problem. I'm gonna need within back because the expression type is a type family. The idea of this is, again, I have like different AST phases. An AST can be passed, resolved, or validated, and I have a bunch of type families that decide how some things are represented in the AST based on in which phase we are, basically. And one of those is what type is an expression depending on the phase. And two of those, parsed and resolve, use the same AST, this one. So some of the stuff in it is also parameterized by the expression type. But so if I want to write a plated instance, I need to make an assumption about how I access the actual self-similar expression within the expression type of P. And how do I do that? I was using a thing called within in the old code. Let's have a look at the old code. But I haven't kept the old code for this. It was... That's the old code here that I have kept. There we go. Where's within? It was a thing. So maybe I could make it as part of the... Rather than using within in general, I can perhaps put in this thing that says like, okay, how do I represent something? I could make a lens or whatever it was. Yeah, within was a lens. From like the expression type to the actual expression underneath. That's kind of ugly though. I think I don't want to worry about this for now, although the instance of plated would be nice. I think since there is no use for it directly yet, except for the simplification phase that I don't care about for the sake of this evening, I'm just gonna comment this out because I want to make progress on the big refactor. So this particular feature goes away for now. Qualified import is not required. We love those errors because those are warning as errors at the end of when the rest of the file compiles. That's great. That's one more file that's fixed. That's because this comes from... I could just probably import everything, actually, from this. Yeah, I'm just going to do that. There we go. Base name comes from name. Aha, and here I have... But why do I have EQ for role? I think this is like this explains why I had those EQ instances and OR instances in the AST. I don't think I actually want that. I don't think I ever want to use a role as some kind of key in a hash map or anything like this. So I'm just going to remove that for now. And we will see if it breaks something. If it breaks something, we will fix it. Empty, not used. Okay, pretty printer not used here either. What do we have next? Orphan instance. That makes sense, I suppose. I want to. The reason I have the instance in here is because, okay, in the case of the resolved AST phase, what is the type of something that is resolved? Well, it comes from role. Hello again. It is a role. In the expression type is something with a location that uses the common expression kind of thing. So all of those things, the instances, I guess where those instances are doesn't really matter. So I could do something where I go back to common, I keep the class to say, well, the class is needed to express all of the things, but the AST phase is not required as part of this, and it is only required here. And so here, the top level is this, and it is the instances. So common passed as passed, resolved as resolved, validated as validated. And I'm going to move this away. Oh no, I just haven't had the time to do any of the exporting or anything. I'm sorry about the delay on this. Oh, the timestamp is fine. I'll just find it when I go through the video editor, and I'll have the comments to guide me. It's just I haven't had the time to go through all of the backlog of video to upload and to clip and everything. Sorry about that. It's the downside of I was saying earlier. The downside of streaming more often is I have fewer evenings where I can do the non-stream work. Perfect, thank you. I think I'm gonna clip only the first part until I talk about the AI stuff, because when I started implementing diagnosis, I made a lot of mistakes that I spent a non-insignificant part of this stream fixing. So I think I'll keep only the first part for the clip. This is from resolved, and I'm gonna move in here. And last but not least, validated. Just this one. I'm gonna remove this, take this, and put it at the AST. I'm gonna put it here. There we go. So now there is no longer any orphan instances. All of the instances are here alongside the type declaration. The only thing is, this is going to be common path. This is going to be a resolved role. And this is going to be a validated, oops. No, void is not validated, but this is going to be a validated expression. And those two things are going to be the validated versions. So here again, you can see this logic of like I have some kind of AST phase, and I'm using this to decide like to branch my AST. In the case of the parsed version of the AST, what's the body type of a path? That's like a path. In the case of a resolved version of the AST, it's a role. And in the case of the In the case of the validated version of the ST, it's void because at this stage, we will no longer have any unresolved path. Well, or even any resolved path. We just won't have paths anymore. Okay. With that out of the way, let's go back to here and let's try to compile. No instance for show on a bunch of things. Path, body type being one of them. Yes, that's correct. Where do you come from, actually? Ah, you come from those things. Okay. So I think I'm going to need to do the same thing that I've done in common here, where I'm going to need to do something like this. If in the case of resolved, the show constraints are matched, then we should be able to do show of role. I keep this in the buffer because I might need this again. Perhaps you wanted undecidable instances. We love those. Undecidable instances is not as bad as the name suggests. It's just basically that the instance resolution mechanism of GHC wants to avoid never terminating for good reasons. So what it does is, if I go here, basically it needs this to always be like to always shrink at every iteration of like, oh, we replace this by something else. It needs to be smaller. It needs to always be a smaller set of constraints so that we can guarantee that as long as we replace, we will terminate at some point. If we know what we're doing, we can make things that expand and then reduce and be more complicated and involve type family and stuff, and disable the check of it must always be reduced. But this opens, like this basically removes the check from the compiler, which means we could end up in an infinite recursion of things if we have some broken type family in there. So we're saying to the compiler, trust me, this will terminate. And I hope I'm correct. Unused, that's great. We like unused things. Those require template Haskell. Today, yeah, I'm at the point where again I think we're done with everything with the refactor, and now this is just let's compile this and let's spend a few hours just closing all of the fixing all of the compiler errors. There's a bunch of things I'm just gonna comment out when they're out of scope for this refactor. I want to get to a point where we can try to compile things and try to go back to doing the analysis of some test files, because really that will get us to a point where we're like, okay, now we can go back to making progress on the project. Definition is not in scope. That's true. Because indeed, I probably want to do this actually. So that's going to be a definition. However, this is going to be a definition passed. I will probably need actually to import the AST itself here to have access to the past thing, I think. Make lenses and all of those. Those require template Haskell, which is not in scope. I just added it for... no, wrong one. It's fine. Okay. Base name, that comes from name. I'm going to do the same thing here. This is just this. And I also need the top level AST in scope. And I need name in scope. There we go. Aha, the module graph contains a cycle. Module validated imports the AST, and the AST imports the validated. Aha, yeah, of course. That makes sense. I guess I have two options here. I have two options. The first is I don't put those instances in here. I put them in the corresponding module. So this goes in validated, this goes in resolved, this goes in passed. The downside being, of course, that they become orphan instances. They are instances that are of a type and a type class, neither of which is in the module, which is fine in this case, but still slightly inelegant. Or I create a boot file that just exports this. I think I want to avoid boot files as much as I can. So instead, we are gonna go back to what we had, where this is defined in common. Here. Oh yeah, anyway, it needed to be here anyway. So yeah, the orphan approach is annoyingly the correct one. And now we can go back to past. Oh, interesting. And copy that back here. And I will just need to figure out a way to disable the warning for and I wonder if I can do it for just one instance, because making a GHC flag for this module saying like don't warn me for orphan instances is not that complicated. However, can I disable orphan warning for one instance? That I don't know. Pragma for suppressing orphan instance warning per instance. 15 years ago. Okay. That means I can probably... I don't think there is a no warn pragma. Let's see, GHC documentation. If I look at the pragmas, the language is one I use quite a lot. Option GHC would be for a file. Warning deprecated. Oh, minimal would be nice for some things I've done. Inline, no inline, that's for optimizations. We are not at this phase yet. Oh, there we go. Opaque. There is no warn. Okay. Let's see if I look for the documentation for orphan. What do I get? Okay, yeah, so there is no way to deactivate it for one individual instance. That is a tiny bit annoying, which means we are going to have to use for those three things, and I don't like doing that, but oh well. We are going to have to use the option GHC pragma. Which is this one for a no warn. Oh, the warning lets you attach an arbitrary warning to a particular function, class, or type. I don't know if it lets me do that for... No, I don't seem to be able to do that for an instance. Oh, and those are not the same thing as the actual warnings. Okay, no, yeah, I have to use the option GHC. Let's do that. So here I will have to add options GHC. Is that correct with an S? Yeah. And this is going to be a W no orphans. If I check again that this is the correct name, W no orphans. Okay. Because this is a orphan instance. We're going to need that in resolved and invalidated as well, because we are going to be copying from past. I'm going to copy this to have the shape into resolved and into validated. And then from common, I'm going to copy this one into, not common, from AST that doesn't need to exist anymore. I am going to copy this into resolved as instead of this. And I'm going to copy this one into validated instead of this, and this no longer requires importing the AST, and I think past no longer requires importing the AST either. Okay. Let's try to compare that. Resolved role. Because I am now in resolved, so I don't need to do that. And in validated, I'm going to have the same thing, where I don't need to do validated. I am currently in this file. Not in scope with location. I just need to put location back in the list of imports. Okay. Path? Wait, path isn't a thing of common. Ah, it's part of name. Interesting. I guess that makes sense. Kind not used, non-empty not used. Pretty printer unused. Okay. This file doesn't need to exist anymore. I think I'm just gonna scrap it altogether. I remove the AST top level file. Just check it, that's the correct one. Yeah, that's that one. It just doesn't make sense anymore. So AST, you go away. Ambiguous expression invalidated, I suppose. Yeah, I need to be able to say, no, those are the local ones. What is the syntax in Haskell for this? I guess I could... Do I even need common in this, actually? I mean, I probably do. But I just probably need AST representation and AST phase. So let's not import the things that will conflict. Is this the syntax then? Seems to be. But here I do use things from common. That's annoying. So maybe then, okay, I just need to do this thing where qualified as common. So I have those things in scope without the qualification, and everything else is imported qualified. Struct type info. That has changed now. Okay, aha, we are trying to compile the type tree thing for the first time. This is gonna be fun. What's wrong here? So why does it require a second argument that's different? Let's go back to the HKT thing. Yeah, it's supposed to be a type. Ah, yeah, of course. No, I see. N no longer exists, I think. Yeah, N no longer exists. That's the thing. Type alias info. Why does type alias info? Because it's been copied from something else, it doesn't actually require a type parameter. That's fine. Function type info. This is in an expression after we're done validating. So I have this function type info that tells me, which is, where is it? This thing. It tells me all of the stuff to know about a particular function call, the name and the type of the arguments and everything, and the return type of the function call. We are in a context where everything here is concrete. So this is the concrete version of this. So it takes the concrete functor as a type argument. I think that's the name we gave those things. Yeah, and that's the same thing here. Okay. Deriving show. Show doesn't work for this. That's annoying. Probably because I'm gonna need the same thing. I'm gonna need a same shape as this, a deriving instance show for the struct type info f, which will require some constraint on something, I think. If it doesn't, that's great. Okay, that's the same thing. Okay, that's fine. Struct info of f. Is it going to be one where I'm going to need... I'm surprised actually that this one actually works. That's surprising. gonna be the same thing here. I'm just gonna copy and paste this thing. So the problem of here is I'm trying to use the compiler-derived version of show being the equivalent of like Rust debug, basically. Give me a debug representation of this thing. And the problem is I have a type parameter here that's a functor that wraps values within this type, and as a result, the compiler is like, I can't guarantee that it's going to be a show for all of this, so I have to use a slightly different syntax for the compiler to be happy, which will probably require putting a constraint of like, okay, this thing can be show when some constraint is actually met. Function arg type. And the reason why I have this functor type parameter thing is I am doing this thing where my type representation in the concrete, like in the validated code, is a tree, which can be either one of the leaves or a struct or a function type or something like this that like has recursively some of the things, because a struct contains a bunch of fields which will contain those things. And the type parameters of the struct will also be the types themselves and so on. But I want to be able to say sometimes like, oh, I have a type where either I have a type or a name of a type parameter in the scope, or maybe I have maybe a type because I want to represent missing information in patterns, for instance. So I use a different functor to wrap my individual types in the recursive tree. Either identity, nothing happens, maybe the type could be missing, or either identifier, we have either a type, or an identifier, which is the name of a type parameter. But we reuse the same tree of type across all three. Why can't you make... Yeah, I don't know why I've tried to make this an applicative and a monad. That makes no sense. Okay, just int name. So I need to have the int name, boolean name, and so on in scope, and those come from Barry's, I think, built in. Yep. Okay. Can't find... Oh. Oh, fun. We are compiling the parser. That will be parser.y. There we go, which doesn't have... It only requires the parsed version of the AST and probably the common one as well. And oh, I might as well do this. This is where I'm going to need to fix, since now the imports will be a with location. That's something we've changed earlier today. That means I am going to need to here do a with location $1 of the $2. Yeah, I think that's correct. As well do that. Ah, that's annoying. There's a good reason for to have definition in the... There's a good reason for that to be there. I guess I could... What do I need from past, actually? I only need module and import. I'm just gonna put those imports explicitly. Oops. Oops. So that's, there we go. That way I should have everything I need in scope. Oh. Qualified. What's that? Ah, yes. I will need a third thing from past. I don't remember if this is valid syntax. We'll see. I will need the import type. Path name. Okay. That's in prepend path info, which is in here. Prepend path info. Yes, path name is the old lens name. It's path body something now. Path body type. No, that's something else. It is path base. There we go. Next. Import path. Oh god, that means... Okay, it's gonna just be easier to do. Instead, come back all the way here. It's gonna be easier to do hiding definition. And whatever else we end up exporting as re-exports for convenience in the analysis code. Okay, the parser seems to be compiling, which takes ages as usual, but that's fine. AST is no longer used here. This is going to be passed. And common, and I don't think I'm going to have a problem there. I might not need both. This requires template Haskell. I don't enable template Haskell by default in all modules just because it adds a non-insignificant amount of compilation time if I have it enabled for all the files. So I just enable it manually for the files where I actually use it. Import this. Wait. I thought I had just... Oh, that's a different file. Okay, base name. This is in diagnosis. I'm gonna do the thing where I'm gonna be not subtle, and I'm just gonna do that. Oh, I probably don't need most of this, but it's easier. Yes, exactly. AST is doesn't exist anymore. This, why do I import the AST here? Do I need the AST? Oh, because I am using path info. So I might need the common here at the very least. Well, I mean, not negative is not as well the same as positive. If human language were Boolean, yes, but the language tends to have human languages tend to have slightly more subtlety than just hard Boolean logic. A role comes from resolved. Typed expression doesn't exist, so I think I'm just going to remove those things altogether. Path name isn't something that exists anymore. This is called path body. That change alone, human language hard. Yep, for sure. Except path body is not in scope. Is that not path body? Oh, base, not body. That one change, while better, will just result in so many compilation errors. It's fine. Ha, so all of those names are wrong. Oh, also, none of those are deemed. I think none of this is used anymore. So I think I'm... Let me just have a quick look at resolution and resolving a type. So I'll have to create the scope from the built-in role, which is what we do in scope. No, not in scope, which we do here. And the built-in scope is for all the built-ins. So that's those. That's the role. Okay. So I just need to change what the role for all of those things is. And I think the int type and so on, all of those go away, I think. And now I just need to go back to resolved, look at what a role is. Yeah, in theory, my stream times are Tuesdays, Thursdays. I've had a bit more time the last few weeks, so I've been doing a bit more. But so maybe I'll do one more tomorrow evening. But if I don't do tomorrow, then Thursday. Yeah. Thank you for tuning in. Thank you for the raid. So here, what I'm saying is basically this path, this unique built-in path name, basically, will point to this particular role when resolved. And now this is... maybe those are actually base name. Base name. Which I'm just gonna do. That. I'm gonna remove this, and I'm gonna, instead of doing this thing here, I'm gonna do instead pure. So that's the base name. And now the role for all of those will be built-in type. And with the base name, so for all of those, it's going to be the name. Okay. Oh, of course, there's a reason I was using the old syntax is this doesn't work. That's a function call, which cannot be in a pattern. This needs to be a proper just constructors of how this value was made. And as a result, I'm just gonna do it as pure. This is instead this thing followed by that. And we can go back to this for elegance. There we go. Okay. Non-bidirectional synonym. Why is it not bidirectional? What's wrong with it? Oh, because base name is incomplete. Base name takes two things. This has changed. A base name is a module name and an identifier. Ah, that's a lot better. Wait, the module name is non-empty. Which makes sense, I guess. Which makes sense. Except for built-in types, I would like to for them to be in not a module, I suppose, or a fake module. The problem being, if I ever end up, if there's ever someone that creates a module name that's, I guess I could use a symbol that cannot be in a module name. Like, what would be the symbol for like built-in stuff? Dollar, I suppose, is often used for that. So this would be a base name where or no, I'm gonna do something a bit different. I'm gonna do so I have okay. That's my pattern. And I'm gonna replace that with first the module name, which is gonna be the same for all of them, which is gonna be pure. Can't be pure, so it's gonna be it's going to be built in like this, a non-empty list of module names that contains a character that cannot be used by a user, and the identifier will be that. There we go. Okay. Import is redundant. We like those errors. Those are warnings as errors, which suggest that we are done with the file. Okay. Map maybe get type name. Get type name is not in scope because it's called type name now. This is very function. It's a recursive call. Report an internal compiler error requires having access to internal ICE, I think it is. Yeah, I suppose now that those are base names, I need to make them names. How do I make them names? I think I'm just gonna instead be very explicit. That's a base name. Or no. I think I don't need the alias for this. So let me just quickly check something in name. It's called the name. It's gonna name base. So this is gonna be the name base of those names. And those are not gonna be base name. They are gonna be actual names. But the name is made of a base name and a list of name for the type parameters, and those do not have type parameters. So they are actual unique symbol name for linking purposes, which they won't need because they are types, will be name with the base name and empty list. Oops. God damn it. times the charm. Ah, I see what's happening. I'm using the wrong... It's this spelling here. No, is it not that? What is wrong here? Why is it... The preview is happy with me? Interesting. The preview is happy, but the Emacs is then unhappy with me. So I'm just going to do that instead and replace with the \1. Huh. Oh, I have, I think, a character that's wrong in the thing that I typed wrong. I have an invisible wrong character in the thing. So let's retype it from scratch. I want to replace this by name, all of that, and an empty list, and now that works. Yeah, I had an invisible character hidden somewhere. Okay. No, of course, those are still called base name, which is wrong. We can remove that. Aha, enum type, that's a base name. So I need to create a name out of this. That's very easy because I don't think I have... I had a pattern for this. Oh, I have it. I still have it. That's a concrete name out of the base name. And in fact, if I still have this concrete name thing, I can use it here. So I could... Because it's a... it's fine. Actually, I'm not sure I want to keep this concrete name. I think adding this thing to remove one argument makes stuff less clear. I'm going to remove it, and I'm going to instead be very clear that no, this is a name with the base name and no arguments, which is the same thing, but that avoids introducing a pattern that's not required. Okay, now. Oh yeah, I think this map maybe is incorrect. I think this map maybe is incorrect because I think I only want to create the name if all of the things give me a name. If any of the things don't give me a name, it makes no sense. So this is instead a lot more... This is much more of a traverse kind of situation. Okay. Ah, yes. On nothing like requires the surrounding context to be some kind of monad, which isn't the case here. So here, this is a lot more... This is not this. This would be a from maybe um, error message, I guess, of type name of team, where the error message, well, raise error is going to be this. Okay. Next, no instance. Okay, so this is the problem. I've put the deriving instance, but now I need an instance of this. And since I'm gonna need it in a bunch of places, I might not need it in a bunch of places. We'll see. So basically here, this is saying for this thing to be able to have a show instance, it means that this thing has a show instance, which is not true necessarily for all values of f. So I need to put in the constraint that this has a show instance. And if that's true, then the other type can. It's going to be the same thing here. There we go. Oh, of course, show here. And this is going to be an undecidable instance again, as dreaded. Oh. Can I just make a deriving show on this one? So here, since I have the f parameter, I'm going to need the same song and dance of this. But things that don't have type parameters, I should be able to just deriving show, right? So I should be able to do a deriving show here. I don't remember if I've usually put the deriving on the same line or on the line below. I think I've not been consistent there. I'd say line below. We'll see if I encounter. This will need a deriving show as well. Oh, wait, it's right there. This requires. There we go. Oh, and I can probably remove that. Okay, and this requires again the same thing. Oh, wait, I didn't fix this? Huh. Oh, no, I fixed it, but then things changed. So, here I have a plated version of the expression, which is fine, but we recently made a change for this. There is no longer a function call expression. We have two different kinds, a function name, function call expression, and a variable call expression. So I'm just going to copy this to have them visible. Are all the constructors there? No, some are missing. Some are missing. Oh, but the other ones are leaves that don't have any problem. Yeah, okay. So this is going to be. I can ignore the name. It doesn't have anything that is. Well, I can't ignore it, but I don't really care about. Function type info. Is that something that will contain expressions? No, it will not. So that's just the type. And those are the expressions. And so the plated of this will be applying the constructor and the thing that don't need to be traversed inside a traverse 2 of f on the fields within, which are the arguments. Okay. Fields non-empty. It's called fs in the scope. Not just traversable typed. Interesting. I suppose it's true. I forgot to do that. Where is typed again? It's in this file, I'm sure. There it is. Yeah, that's definitely traversable. Does it requires foldable? Okay. Does traversable requires applicative? No, I don't think so. It doesn't require applicative. Okay, non-empty not used in this context. Pretty printer not used in this context. Context okay. What else? Location not used in this context. Okay. Okay, we get to here now. This requires template Haskell in scope to generate the lenses, so we need to add a pragma for it. Oh, I did not import data hash map strict extra qualified as M. In scope, there we go. Resolved function info. So function info is something that I'm going to need exported in validated. I already have a function info in validated and in resolved for symmetry. Oh, it is there. Oh, no module name resolved is imported. That's why. AST is not used. Ah, this is the simplification phase, which will be done. I think this is correct. This will be. I think this is more or less correct, except this will not be on the definitions. Because I don't think we need to simplify the types. This will be on the symbols. This will be on the validated version of the code of the functions, where we will want to perform some basic simplifications. So this will be on the interface symbols. Oops. Which is a hash map from name to function info. So we don't need to do a traverse. This is just a traverse. And we will apply simplify. And something that is simplifiable is something that takes a simplify and like a version of and returns the new version of itself. Do I fix simplification now? I guess I could. There's a lot of things we can do quickly there. This will operate on the validated version of the AST. So this is going to be a definition. I will need stuff from common, I suppose, but I will probably want hiding definition, I think. I think in the case, do I want to keep this simplification for the things? I think the only case of simplification that we have is for statements and expressions. So I think there's no need to call simplify on anything but function definition. Well, except this is not on definition, actually. Since I'm doing this on symbol, this will always be on function info. So maybe I don't even need to hide definition, since it's not going to be used. This is going to be on function info, which is no longer function info resolved. Okay, let's do this quickly, even if I comment out the meat of it, just to have something that looks somewhat okay. I will need to have a look at my validated shape, which will be a function info. There we go. So how do we simplify a function info? The function type remains unchanged, unless no, I think simplification is purely about simplifying the code. I think types, we don't care about doing any simplification, so the types remains unchanged. The only thing we will do is instead simplify the fun body. Why do I do... Because a block is a list. This is a list of with location. I suppose I can just do an fmap2 then, and I don't need to do any with location stuff in here, which I don't think I was doing in the first place anyway. Function type no longer needed. Function arg type no longer needed. Statement, however, this is going to be a statement validated, and those I'm going to do the same thing, I suppose. And since this is a function, I can just, that returns the same type, I can do other... I think for this, it's better to have it explicit. Validated. I can probably do a resolved into validated in this file. There we go. I think everything else is going to be the same, except which ones do I have a type for? Let info and for info, I think. Yeah, those I have my own version, so I can just do for info here and let info here, or validated let info, validated for info. Okay. I kind of want, I think, to... Maybe I will want to instead never import common, make common an implementation detail, and have every module give me a bunch of... Yeah, I think I will want that. So let's do that. Where instead, the fact that there is a thing named common parameterized by the thing is an implementation detail, more or less. But the problem is to have access to the constructors, I will need common. That's annoying. Yeah, okay, I can't do that. Okay, and where this is going to be, yeah, an expression is going to be the one that's going to be completely different. I am going to need to do this for a validated expression. Simplify is going to be for now unimplemented. And I'm going to, for now, comment out all of this, which is no longer how stuff is implemented. Biggest occurrence for function info. This is the validated one. And this is where I'm going to have to say, okay, this is the constructor. So that's the common. So this is where I'm going to need which makes it very explicit which things are coming from where, which is a bit annoying. Although, could I do the thing where every AST file re-exports the thing it needs? So here, for instance, let's say function info in the case of a thing validated is not the common one. That's the only function info. That's the one from validated. And that means that in validated, maybe I don't do any re-exports, which I don't have here actually. And I do a thing where this exports, but I would need to list, the things explicitly, I think. Because I do it for my prelude here, where I re-export a bunch of things. But this might be better. I think I want to do that. It's going to be very verbose. It's going to take a long time, but I think it will be better. So I will want to basically have an explicit list of exports. That's gonna be a nightmare. Don't know if I need the type tree to be exported. I might. For now, let's export everything. Yeah, for now, let's export everything. It's gonna be annoying to do, but it's work we only have to do once. I actually need to export the constructors as well. Bear with me while I do this very repetitive work, which we will have to do 2 more times in all likelihood. Okay. This is not the most exciting part of this. Oh, did I do the conversion? I don't think I did the conversion to L-value expression. That's missing. Oh, there we go. That's the full list. I don't think I did the conversion to L-value expression. If I go back to expression, validate function expression, that's this one. For an assignment, Yeah, I think I really want to try like reduce those validated stuff and everything. Um, or at least never have common, always have the resolved or the validated, like have the prefix always be correct. For assignment, I do validate assignment expression. There we go. And I do a validate L value expression, and I think validate L value expression doesn't exist. Hmm, that's not correct. It should give me at least once. It should give me this match. Why doesn't it match this line? Hmm. Is this file not in Git? It should be. Hmm. So why doesn't... Oh, because I'm not at the root. That's why. Yeah, it doesn't exist. It's called here, but it doesn't exist. So I am going to need to do a validate L value expression, which is going to be another function at the top of this file that looks like this gigantic mess. But it's going to be a lot simpler because 90% of it will be wrong. So this will be validate L value expression, validate L value expression, which returns a L value expression. And for now, I am going to... Do I implement it? Could. I could. Path expression is valid. Are all path expressions valid for... No, constants are not. So I'm going to need something else here. So this is going to be unimplemented path for now. Cast not allowed on the left hand side. Field access expression, yes, but unimplemented for now. Because I don't know. Because I'm going to need to do the recursion with this function, so we'll do that later. Function call expression is not going to be allowed on a left hand side. Index expression, array expression, and index will be, that's fine. Validate struct expression, yes, that will be allowed. But we will need to do a third version that takes care of the recursion. Literals will never be allowed. I guess a string literal could? Nah, it makes no sense. It makes no sense. Boolean negation is not valid. I guess I could just do a catch all for all the ones that make no sense. So this makes no sense in this context, makes no sense in this context, makes no sense in this context. There we go. This will exist at some... No, this won't exist at some point either. Reference, Boolean negation, int negation, addition, all of those, none of those exist on the left-hand side. No assignment exists on the left-hand side. So an L value has to be path, field, array, index, or struct. If we look at the definition in validated, variable, reference argument, those are path, field access, index. Oh no, yeah, array makes no sense. Yeah. And struct expression doesn't make sense either, actually. We can't have... Yeah, no, it doesn't make sense. So it's a path expression, field access, or index. Everything else... incorrect expression. It's going to be a fatal of... Do I have an error for this? If yes, can I reuse it, or do I need to change? L value, no. Assignment. R value assignment. There we go. That's an R value assignment of an incorrect expression. There we go. So we still need to implement those that are not being implemented, but at least now it should compile because it won't be missing. Defined but not used. Ah, come on. Do I have to include the lenses in this? Ah, this is annoying. So the reason I'm including all of the things is because I want to be able to re-export the things from common that are required for this AST, but are not defined here. So the things from common that we need, the subset needs to be re-exported from here. So actually, let me put some... I'll do that later. Those two actually belong in the type category. I'm gonna move them accordingly. They're labeled helper functions, but no, I think they belong in type. So I'm gonna copy this, remove this. At the end of types, which ends here, I'm gonna put them. And then this becomes definitions, and it starts here. I'm actually gonna put this in capitalized because the haddock documentation will be generated from this. So here I'm gonna need as well re-exports, and that's gonna be the module C. And I'm gonna need at the end the lenses. So let's copy this. And put them all here. And keep lines define but not used. Okay. And then replace all of this by defined. Actually, I'm gonna copy. What is this character? Okay, so now I can just replace all of this by that, which are all the lenses. Perfect. And the last thing I need is I'm going to need to import common. And there is going to be... So here I'm going to import the same thing even for my prelude. I guess here this is where actually I can just do modulo common. And I can do one thing here where I re-export everything explicitly that I need. I need the AST phase. I need the AST representation. And whatever else I end up needing will be in that list. I will need the if info. I will need... Can I export a constructor but not its type? I don't think I can. I guess pattern synonyms, yeah, but that's... Oh, I can just explicitly import the pattern. That's interesting. So here I could say I don't want to import the if info type because I will want to re-export it. So maybe I will want to do something like qualified as common and the as C version will be this. And here I can do pattern if info, pattern else info, pattern... what else will I need? Let's use those for now, and let's add... Okay, and I'll have a re-export section where I'm going to say that a validated if info is a common if info validated, and an else info in this module is a common if else info validated, and so on. Which means that at the end, when I get to a place like the simplification, I don't need to import common at all. I can just import validated, and this will have function info as a type, and this will have the function info constructor imported from common. And now I will have statement imported from common. So statement, the type exported by this module will be a common statement validated, but the constructors will be the one from statement, which means they will be those ones. This is going to be very verbose in terms of like import shenanigans, but I think it's worth it in terms of simplicity, where like I import a thing of the AST and I have all of the types and the constructors in scope. We're having to juggle with several different import files for the AST. I think that's the best option, even though it means being very, very verbose like I'm doing here. Okay, so simplification, statement, and those constructors will be in scope from just the import of AST validated. If info is going to be the same. else info, likewise. Oh, else info. That's not. It's not a prism. I need else if and else block. Also, I need to check that this actually works, because otherwise I'm doing a lot of work for nothing. For info, that's already done. While info, I'm going to need to add. Let info is going to be there already. So I'm going to need while info. While info, and here I'm going to need as well info, which is common while info validated. Path info is definitely going to be coming from, wait, path info no longer exists at this stage. I don't have to do that. And then this is expression, and expression is directly from the thing. Okay, that should be it for this file. Let's try to see if this works. It's missing the comma. As yeah, C is fine. Is this not allowed, or do I need to enable pattern synonyms in this? Seems to be working. I just need to include now. First, I'm gonna. There we go. So I just need to include those 4 types in the list of explicit exports. Oh god, that's horribly aligned. Thank you, Stylish Haskell. That's ugly. That's enough to make me reconsider. That's very very ugly. Ooh, I don't like this. C cosplay. Yeah, I suppose. So here I need to add the types to the export. I wish there was a way to say, like, I want to export this thing and everything else. Maybe there is a way. Let me check that actually quickly. There is a simple solution. Just export the module from the module. Okay, there we go. So that means I don't need to do all of that. That's great. Means all of the work was for nothing. I can do export module validated, or this, suppose. So all the content of this, and the module common re. So how do I name it? How do I name it? And let's say that it's gonna be AST common. It's gonna be a better name for this. And this is gonna be as AST common. Oh god. That's horrifying. Let's have a look at how it looks like zoomed out a bit. Yeah, zoomed out a bit, it's still like within 90 characters, so it's not the worst. It's just not very elegant. I am tempted to break a thing I've done, and I have like all of my imports are sorted by group, and I have grouped them by different things. I have the prelude first, my custom prelude first, then third-party dependencies, then internal stuff, And I might do a then re-export because that way I have the ugly thing isolated. What time is it? It's late. Okay. Um, those are things within if info that are not in scope. Why aren't they in scope? Oh god, do I need to... It's not gonna work, right? No, that doesn't work. Does that mean I need to also list... Does that mean I also need to list... At this point, it might be easier to instead do a hiding and to hide the thing I want to hide. And here I can hide just the types, but not the... but that's not gonna work, is it? If I hide if info, it's gonna hide the whole type. And I need to hide expression and for info and let info and function type alias info. This idea is becoming worse and worse the more I try to make it happen. Maybe I just give up on that and accept that like things that use a part of the AST will need to import common to access the constructors. Yeah, no, this is a little worse. Yeah, okay. No, I think I don't want to do that. This is becoming way too ugly. I think I'm giving up on this idea. This is getting way, way too ugly. So that means I am not re-exporting common, so I can just remove all of this. It's a shame. I think it could have worked, but yeah, nope. Let's not do that. So instead, stuff from common is going to be imported qualified. And I will still keep the re-exports. I will keep the types here, which is going to be nice. Hello, how are you? So keeping, I think, the type aliases is still going to be a net good, but that just means I'm going to use common explicitly everywhere where needed. Okay, so that means, for instance, okay, there's a few things I can import without any like AST representation and AST phase. I guess this is more like how do I design this API more than it is about fixing the bugs at this point. If statement. So here, this is in the simplification phase again. And here, as a result, if I do that, I am going to need to do... I think I will want to have common as common, I suppose. And then it becomes, okay, things that are from... But... This is annoying. This is annoying. Wait, this isn't gonna be ambiguous, is it? That's a constructor. So there would be another solution in terms of there would be another solution in terms of API design, which is to do something that goes against the Haskell conventions, which is that in common, the types have a suffix or a prefix or something like this that indicates that they are shared, common, but their constructors do not. So, for instance, I could do. There is an extension to a language called Linear Haskell that I'm not familiar with at all. But that is an extension to a language that exists. It's not part of the core language. For instance, imagine that I do this thing where statement, to pick one of them, is actually labeled common statement or shared statement. But I think common, it makes sense. And then in validated, I export statement as being a statement in the context of being validated is a common statement validated. There is no longer any conflict, and the constructor for statement will be the constructors from common. And maybe that's the solution. Because that way I can import always common and the thing. All the types live in the main module I have imported. Yeah, I think this might be the solution because this avoids the conflict. The conflicts are all gonna be the type names, I think, mostly. No, it's not gonna be always just the type names because for if info and everything, I'll redefine things. No, okay. I'm giving up on trying to do that. I'm trying to have something that like each AST file has purely its full thing exported without needing to import stuff from common. That's never gonna work without being absolutely horrible. Which means there's just a few places where like, yeah, nope, I'm gonna have to be explicit, like, hey, this thing is actually from common. It's fine, I think, to just accept some verbosity there. Because having explicit like things like this will wait, why do I have more? Because it's already there. So simplification function info, that's not the one from common. That's still okay. Give me 1 sec. I'm gonna try to see if I can find another way out of this. There is another way out of this. Maybe the common thing approach works if then I do a I do import only the things I need from common out of the things I re-export. This is spending a lot of time on this, but at the same time, if it makes the rest of the code a lot more readable, like, yeah, no, this is the type statement from validated, this is a type statement for resolved, and they have each a constructor that is also coming from that import, and I never have to import common from other things, and it's purely an implementation detail of it. I happen to share some types across different AST representations. That would be a lot better. That would be a lot better. So that would allow me to do something like this, where there is a function info type with a function info constructor coming from just validated, and I don't need to import common. And statement, whatever it is, has only. I think this is what I want to achieve, but as we've seen, that's complicated. But maybe the approach where, no, okay, I am going to export this and module common re-export. And I'll have import this thing qualified as common re-exports. And I'm going to list a bunch of things to include that are required, like maybe such thing like the if info, common if info. And to make sure that there's no conflict there, I will need to go to common and change all of those types to be common. Sure, let's rewrite the entire AST in the middle of making everything compile. That's fine. I think enominfo is the exception, since enominfo never changes. I'm just gonna... And in fact, I can probably do this and just doing a hiding, actually. Hiding the things that are conflicting with stuff that is in scope here, which in the case of this will be for info and let info and a few others like this, like type alias info, for instance. Well, except those will be common for info, common let info, and common type alias info. And we get back the horribly ugly syntax. This becomes common const info, where it becomes non... where it becomes... Oops, excuse me. I'm not sure enough about this. I don't know enough how the Rust borrow checker works to be able to answer that question. I'm not sure that's entirely true, because you can have multiple constant borrows at the same time. So I'm not sure that it is true, but I'm not sure enough to give you a categorical answer. Okay, so the thing I'm doing here that's not idiomatic is having a record whose constructor is not the same name as the type, but that's because I'm doing all of this re-export nonsense. Okay. Yeah, that's the common statement. True, I suppose. But well, borrows... I suppose you could, yeah, in that logic, if you're only talking about pointers, then yes, you could probably make the case that... But again, I'm not certain enough, so I'm not gonna like say a categorical yes or no. Well, do I want block to be common? Or is just block always... For things that are always used, I can maybe just like I'm not making a library that's going to be used by people extending it. There's a bunch of things that are going to be the same across a bunch of different types. Maybe I can drop the common for things that are not changed across. Struct info is changed, but I think const info is never changed. Yeah, I don't think I create other const info, so maybe I can drop that. Well, no, I can't do that since I want to have the alias. So no, I need to have that. Common function type, common. Common statement. What do I do for block? Yeah, I can do probably a common block that is a common statement. If info, which is a common expression type. Well, no, that's okay, but that's a common block. That's a common else info. This change, I think it's good, but it's gonna be pretty verbose and unpleasant to put in place. Okay, and this is a common expression. That's the common path info. I hope I don't change my mind on this because that's a lot of time spent on this. Okay, so now all of those have a type name which is common. And there's a bunch of places where I'm gonna need to fix this. This is common. So is this. So is this. Expression type. Okay, expression type is the family, it stays the same. Function type. That's a common function type now. Common function type. Okay. Maybe common info. There we go, and now we're getting close to the end. Okay. Okay. With that done, with this monstrosity done, here I can hide the things that have constructors that share a name with stuff defined here. So I've listed for info, let info, type alias, but that's also struct info and probably function archetype. So function info, well, common function info, and function archetype, something like that. Which is still absolutely horrible in terms of indentation. But now here I can then say explicitly all the things that I need, which means, for instance, I've already done if else. A for info is already changed. Path info is not required as part of this. What else do I need? Statement that's already done. We'll see. We'll see what's missing. That's gonna break everything. It's great. Come on. Oh yeah, for info type is not, and let info type are not local things. They are type families in the tree. Okay, common compiles, I think. Nope. Hello, how are you? This is the end of a big refactor, and I'm doing some ugly type alias shenanigans for better usability of some shared code. And it is ugly, but hopefully after I'm done with this one-time ugly thing, I'll have a lot cleaner interface for this. Those are common now. Common path info. Are we finally done with common? Nope. The problem of doing trees that grow with an AST with different phases of the AST might be familiar to you. Okay. Enum info is not common. It's the only exception to the rule. You're not the first person to mention lean this week only, I think. Well, over last week. I need to look into lean, I think, at some point. Okay, so we have moved on common compiles. So now we are moving on to resolved, which is one of the phases of the AST. And now we can do the same thing that we do for validated, which is this thing where we re-export stuff from common that we need, the subset that we need. And we will hide the things that have constructors with similar names as the stuff we're defining here. And in the case of resolved, that's none of them. So this becomes a lot easier. This just becomes common re-exports. There we go. And the only thing is we are going to need the re-exports, the type aliases. We're going to need a bunch of them. I copy the ones that are here, but we're going to need more. Because definition, we're using the one from common. I'm tempted. Well, I'm gonna be streaming the Advent of Code this year as usual, but I'm tempted when I go on vacation at the end of the year and I'm not streaming anymore. I'm tempted to go back for like day 1, day 5, something, and try to see if I could do it in Lean or something like this. Off stream, I often use the Advent of Code to try new languages. I had done some stuff in Pony 1 year. That was pretty fun. Yeah, I rarely finish the Advent of Code, partly because since I try to stream all of it, by the end of the year, when it's like the 20th or something, I'm usually away on vacation. I don't have my stream set up, and it becomes too complicated often to like for it to be fun to stream, basically. There's no common in scope, but this is just gonna be expression. What do you mean halved? Is there something different this year about the Advent of Code? Huh, fascinating. Huh, okay. I haven't yet. I need to because I contribute some money every year since like the streams have been a big thing. I haven't done so yet. I need to do it. 12 days is interesting. That means it might be possible for me to stream all of them. We'll see. And like every year, I'll also try to see if I can do some days in brainfuck because that's fun. Okay, so here expression. None of this is required as common anymore because now I'm always so function archetype. Yeah, I should probably I can just do common at this point. This is common. And as a result, since I'll have the aliases, I can do just that. Because now I can also say that the path info in this context is a common path info resolved. So that's the idea. Now every step of the AST exposes its own set of types that are just like either custom or a type alias to the one in the shared stuff with the proper type parameter. But the constructors of those have the same name as this, so that they can be used seamlessly by the rest of the code. Well, it depends. It depends on how they decide to scale the difficulty. Since a lot of people use the Advent of Code as a way to train, to train and like learn new languages, I would assume that it's just the first days are going to be very easy, but they're going to scale a lot faster. I'm expecting day one to be basically like sum of ints in a list, basically, and day 12 to be the equivalent of day 25 in previous years. But I could be wrong. We'll see. Expression. So I need an expression here. An expression in the context of a resolved AST is a common expression parameterized by a resolved type. A function archetype is going to be a common function archetype resolved. This is going to be a lot easier for resolved than parsed at the price of a lot of type aliases and some weirdly named constructors in common. I'll have something that works a lot better for this. For info and let info. Yep, that's correct. And those are just going to be the regular for and let that are coming from common. But at least now with this infrastructure in place, if I ever want to change one part of the AST for any of the phases, none of the rest of the code has to change, which is nice. So now for past, okay, we are done with validated. That's nice. We've resolved. So now let's do the same thing for past, where we are gonna want to do this nonsense. And common is re-exported as common itself. And now everything common dot is removed. And I'm just gonna need the same thing here, the resolved here, the re-export. I'm just gonna need all of those, which in fact I'm gonna sort. There we go. Okay. And now that means this is just with location expression. That's just with location definition. Aha, what is this? I have expression in scope here. Oh, but it's below the lenses. It needs to be above the lenses. Otherwise, I have a declaration order problem. There we go. And that's the same thing here. I don't need the past argument anymore. Okay. And now we... The good thing is this is going to make things simpler at the price of a long change. Now I don't need to do AST past, AST common. I only do AST past because past re-exports everything it needs from common. And now that means that I think every single place where I do past here can just be removed. This is just a definition. Okay, and I can even go one step further and try to see, do I have places where I have an open parenthesis and a group without any, that's just A, Z, star, and a closing, oh, I don't seem to have any, interesting. Oh, I do have a bunch, okay. I probably don't do it on only type names, so I probably wanted to do it on this then. So that's not one of them, but definition here, yep, there we go. Okay. But yeah, now you see the point. Here, this thing talks about expressions and statements and everything, and it just uses whatever those types are coming from the past version of the AST, regardless of what stuff comes from common. That's the thing I was trying to do. The ugly thing I'm doing is stuff that comes from common has like is named common something, but has constructors that don't have the common. So the if info of past that doesn't have a argument there, its constructor is if info as well. So for the rest of the code, it's like it doesn't matter. The rest of the code can't tell if the constructor is from the file or re-exported from common in terms of naming convention. And this is an expression parsed. common is no longer required in this. This branch is basically rewriting the entirety of the project. Okay, so okay, so I'm gonna need to hide more things here because I have a function type now. So the common function type needs to be hidden. Okay. And enum info is no longer needs to be parameterized by this. Whereas, yeah, I think I can just do a common dot replace with nothing. Oops. That's just a block. And I'm just gonna do the same thing of re-export type block is a common block validated. Okay, which I think I'm gonna also add to the other past. And oops. Oops. And resolved. Just gonna up. Wait, it's easy. It goes fast. Okay. Go back to validated. Let's try. Let's see all uses of block here. Oh, I'm in the wrong file. I want to be back to validated. Okay, this needs to go away. Okay. Expected kind AST phase, but block has kind. Because block is a common block validated, okay. And there's nothing else named block in scope, it's this one. Huh. Oh wait, is it because... What do you mean? It's just a matter of I fixed the thing after... Yeah, okay. Hmm. Yeah, I need to hide expression as well. God, this file, this list of hiding is absolutely horrible. Conflicting exports for struct value. Interesting. So that's the whole point. I want to hide things that have been redefined in this file. So struct info goes away as well. Definition goes away as well. I think I'm just gonna create common here as well as common. Oh, I thought type alias def. Oh, it's common definition. There you go. Struct params. Where are you coming from? struct info. Didn't I remove that already? Because I am hiding common struct info, so the constructor should not be in scope. So therefore this module should not be imported. I'm surprised. I see the common late info here. Like, this should be hiding the things I don't need, and therefore the re-export. Maybe it's just a matter of name? It's weird. Like, if I name this C and here C, let's see. Nope, it does give me conflicts. Oh, it's the lenses. It's the lenses. Struct params is not the constructor, it is the it's not the field, it is the lens. Oh, that means I'm gonna have to hide the lenses as well. Ooh, that's unpleasant. At this point, I don't know if it would be faster to import the things I need or to hide the things I don't. I don't know. Because I redefine definition, I redefine type alias info, struct info, function info, and all of those. Maybe defining what I need to import is actually a smaller list of things. If I go this route, instead, what do I need? If else statement while block. That's all. Okay, I'm gonna keep this one out in case it proves to be smaller than the other one. But let's try to just import the required stuff. So common if info, common else info, common block, common statement, and of course I will need AST representation and AST phase. It's not getting a lot smaller. Yeah, I don't know if it's easier to include what I need or to remove what I don't. It's ugly in both cases. Okay. So now we are having real errors that make sense. Okay, so maybe it is better that way. I'm gonna need to include the lenses as well, but maybe it's better to include the bare minute, the things I actually need. So let's keep this version. So if I go back to this simplification phase, what it's saying now is now that I've changed on which state of the AST this operates, and I go back to validated to have a look, this will now need to traverse a for info, this one that has 4 arguments, and at times this was written for the old for info that had only 3. So the variable name doesn't change, the for variable type doesn't change. But however, I need to simplify the range expression, and I need to traverse to fmap simplify on the for body. Okay. So that's a normal expected error. Normal expected error, you know what I mean. Let info is missing some stuff as well for the same reason. And it's because now this only has like two fields. So this is an fmap simplify on the let expression, on the let value. Oops. Okay. Unimplemented is not in scope, interestingly. That means I am missing internal, and I think it's ice for the internal compiler errors. Ah, yes. Typed is not simplifiable, but the expression is, so I just need to fmap further. And this is probably an fmap2 for the same reason. Yep. That's an fmap2, I'm certain. Although I suppose I could just do... it would not... I don't know how many errors there was in total, since it would just not go through some of the files. I haven't kept track of how many I've been correcting. I guess I could simplify this by saying that if a type TA is simplifiable, then with location of A is simplifiable by doing simplify equals fmap simplify. And I can do the same thing for typed. And that means I can remove a lot of the... Like this becomes fmap, this becomes like I can remove a lot of this complexity. Just gonna remove all of them and see which ones break. Like if I remove all of the f mapping, what is going to be missing? And I can probably make instances for that as well, because it's probably going to be list, I think. Let's see. With location not in scope, that's a representation. Let's put it back here. Location. No instance for maybe. I'm almost tempted to do functor f simplifiable f of a, where that's going to handle list, typed, location, all of those. A range expression. Ooh, that's interesting. Okay, this one I want. So I will want to re-implement this simplification phase on the range expression. I will want to re-implement it on the L value expression as well, probably. Although L value expression, there's probably not going to be much to do. Okay. No need for built-ins here, no need for location here anymore. The simplification phase should now compile. And we are now at the lowering phase that I haven't touched in a month and a half, and that I used to operate on something that is resolved, and now will be operating on something that is validated. So this is now going to be validated. That's the input to this, and I'm gonna still keep it as AST. So this is an AST function info as the argument here. And most of this is gonna have to be rewritten because the whole point of this refactor, the entire reason why I'm doing like this, like weeks of work, is because I didn't like the shape of the lowering into AR, despite the fact that it took less than a week to write it. And the reason why is, again, the representation of the AST, since I'm using the trees that grow thing, I was using this common thing that like forks some stuff like the path type for the different phases, but the expression one was shared across different phases. So I had parsed and resolved, and resolved was both name resolving and like type checking and everything, and it had the same shape. And the problem is, this conveys extremely little information about the type checking we have performed. For instance, this expression type, which is used, the common one is used for the parsed version and the resolved version, not the validated version anymore. The left-hand side of an assignment is an expression, because when I parse something, yeah, I have an equal sign and the left-hand side is some kind of expression, right? I could at the parser level already make it like, okay, duplicate the logic of L value expressions and only allow L value expressions on the left hand side of an equal statement and everything. But it is a lot easier to say like, no, okay, on the left hand side of an equal is just an L value, and I check if that thing is valid when I do the checking. So now what I do instead, the problem with this is when I was doing the lowering, when I process an expression, I would have a bunch of things such as like, oh, where would that be if I were to look at an assign? Half of my code was a bunch of report internal compiler error, everywhere, like 3 report internal compiler errors in this function, because I had to handle the fact that like, oh, I would find something that makes no sense in this context, despite the fact that I have already checked this. For instance, I'm trying to translate a type, like, oh, I know that this thing points to a type, this path info points to a type, but with the representation after this phase, I still have something that could be a type parameter or a placeholder or a function argument, and those things are not types. So I would have to throw internal compiler errors to say, well, the checks that we've done are not being reflected in the types that we emit. So now all of this will just go completely away, because now the output of the analysis phase will have those much more specific type, where the expression, an assignment, has an L value expression that cannot be wrong. That can be wrong. By construction, cannot be any arbitrary expression. I will no longer have this weird path info role stuff. I will have an actual, type that points to the actual proper type and with the names and everything, which means most of this stuff I will be able to rewrite to remove all of the internal compiler errors. This will like shrink the size of this file, like divided by 2, I think. But for now, I absolutely don't want to. I want to compile the rest of the code first. So I think for now, I am gonna do this undefined, not even unimplemented. I could do unimplemented. Let's be a tiny bit cleaner and comment all of this out, because that's the phase after the one I'm currently rewriting. That makes sense. As a result, a bunch of things are not required. Why was I calling instantiation in lowering? Yeah, I don't want that, I think. Yeah, that's definitely a proof of like I was calling from other stages. Definitely something was wrong there. Okay, and yeah, here as a result, most things are not required. I'm just gonna comment it out. And I will need the IR, and I will need interface for this to compile today, and that's gonna be about it. Okay, unimplemented comes from this. The first thing we will do when everything we've changed works is gonna be doing this again, of course, but news matches, I suppose. Okay, I'm just gonna. There we go. Good enough for now. Next, diagnostic is no longer something that is in analysis. Yes. So I will need. Do I even need? No, I don't. No, I need monad diagnosis. That is in internal. Is it internal diagnosis? Diagnosis, this one is in internal, and in diagnostic, this one is in the old folder, so it is diagnosis. There we go. No thing sequence is imported. Don't I have a sequence in this? I have a sequence in this. Oh, but yeah, okay. The type is in scope from the prelude. Okay, next. Yes. Do I want to... Yeah, I probably just want to, like, do this. Import the type as the name unqualified and then the rest of the module qualified. Definition cache, this comes from interface. Oh, I have the resolve validated stuff. I don't need common anymore in this. I need interface. And here, resolved validated should be enough. Because I do the resolved definition kind of thing to differentiate them. Resolved function info. Yeah, that should be... I don't need common, I think. We'll see if it compiles. Base name, not in scope, that is coming from representation name. With location, not in scope, that's coming from representation location. Identifier on its scope, interesting. Did I finally move identifier out of tokens? Seems like I did. Okay. No instance for function instantiation request. Indeed, I forgot. Deriving show. Okay, I seem to be consistently putting it on the line after, not the same line. So I'll try to harmonize whenever I encounter something that's not the same. I don't need to do a swap. Oh, it's just not in scope. Yeah. I could just return the A and the state the way run state D does, but I really dislike having the value first and the state second. So I think I'm just gonna import data tuple swap in scope. Initial state is a validate state, but it expects do I have... yes, this is not a validate context, this is a validate state. Okay. This is supposed to be a hash set, and here I am giving S, which is set. That's wrong. Wait, do I have sets anywhere? No. No instance for functor M. Yeah, there's definitely... in fact, I will need to add that I need to be in a monad diagnosis for this to work. That is able to accumulate some of the errors. Although it might not be needed as far as this thing is concerned. As far as this thing is concerned, monad is probably enough. Make lenses. It's going to be coming from import control lens. Do I want to import all of it? Yeah, sure. Aha, analysis context. That's something that no longer exists. This is called validation context. Now that we have split the analysis between two phases, resolution, validation. This context is probably wrong. It has name, location, fun type, params, variables. Nope, it looks correct. Perfect. What I would want here is actually more of a finally kind of thing, but I think there's a library that does a finally on monads, and I could remake a finally instance for my monad diagnosis. I'll have a look at how it works. Variation context. It's validate context. Monad diagnosis. Oh, okay, it needs to be in scope anyway, so I'm gonna need to add internal diagnosis. AST doesn't exist. Which one do I need for this? This... do I even need the AST in this scope? I probably don't. This thing just calls other functions. I probably don't need to know about the AST at this point. Analysis, all of those don't exist. I will, however, need to import analysis and resolution. Oh, watch in terms of the to automatically recompile when something changes, you mean? It's not... well, I mean, I could also do the LSP integration thing to have like automatic recompilation. I tend to prefer it not happening without me explicitly saying so, just to avoid having the thing run. Like, I prefer having it run when I ask for it, basically. But I could do something like that. I will need diagnosis. I will need resolution, and I will need validation, which are the two parts of the analysis. Until we split more parts from this. Data ordered set. Oh. What package is that from? Oh, it's dataset ordered. That's why. Go. Fixed. Location in scope that comes from representation. Location. Role. Ah, I do have... ooh, that might be a problem. No, it should be fine, I think. The problem being, this uses stuff defined in the AST, basically. Like, oh, actually, I need to fix this. This is a path info resolved. That no longer makes sense. Yeah, I need to fix this. A lot of this is broken. Okay. But this means I'm gonna need to depend on AST resolved qualified as resolved. I probably don't need to do qualified if I'm being explicit about the things. And I will need validated. And I will need passed, although maybe I won't need passed actually. So path is fine, roll is all fine, except, yeah, there's no conflict there. Type no longer exists. It is called concrete type now, as opposed to partial type or parameterized. God damn it. Or parameterized type, concrete type, concrete type. And this hollow concrete type is partial type. There we go. Path info, I'm talking about the resolved one, but that's probably not gonna be correct for long. It's probably gonna be actually a type here. Like, this is probably gonna be type and type. Actually, let me have a look. Wrong cast. The only places outside of old where this happens are the validation expression, error, wrong cast. That's the type, and that's the type. Okay, so wrong cast is concrete type and concrete type. Enum info no longer has a thing like this. Struct missing field. In not old files, it is only used for base name field name. So this is no longer a path info resolved. This is a base name. Struct duplicated field is also going to be a base name. Unknown field is going to be a base name. And this non-empty path info resolved is going to be a non-empty concrete type. This is, I have found conflicted types for a field. Function ambiguous type. Where does this one come up? In old, aha, it's no longer used. So that means that something is wrong. That means that I probably have in the validation in express, when I do a validate call function, there we go. Here I probably have here I have struct ambiguous type and struct incompatible types, which is incorrect because I am in the context of a function. So this would be error, is it function? Function ambiguous type, function incompatible types. And those are, again, a base name. And here a base name. And the non-empty here is indeed a concrete type. And with this, path info is now a thing of the past for anything after the analysis phase, and good riddance. Function call wrong number of arguments. That is the base name, and that's the expected number, that's the actual number. So that's indeed, again, a base name. Okay. Here, I'm going to replace all expression resolved by a resolved expression. Wait, I'm an idiot. Expression. There we go. By resolved dot expression, which is a type alias that we have been using. And if not Boolean. Oh, I'm not sure I've been using this one. Let's see. Oh yeah, I haven't used this one because I use a helper function that does the type checking for me. So it will just say type error, expected Boolean, got something else. Those things are no longer used. That's fine. And I think that's it for now. Okay, type, that's concrete type. What I've missed. There we go, that's also a concrete type. Sec empty in diagnosis. I need to have sec in scope. I don't. Huh. I guess, yeah, monatrans is a bit different. So I will probably need to instead do standard monatrans. I can't derive monatrans from a new type. Huh, interesting. If I could. It's not gonna be that complicated, I think, because I just need the diagnosis T like this, where and lift is gonna be diagnosis T of lift, I think. Maybe a single lift would be enough, actually. No, it requires a second. Okay. No instance from monad M in run. Yeah, okay. That's the same error I had for the validation. I need this to be a monad underneath. That makes sense. Compose, no in scope. That is data functor compose, I think. Okay, loops is redundant. RWS strict is redundant. Extra is redundant. Oh, that was maps extra. I don't have hash. Oh yeah, I don't have hash maps in this. Yeah, I suppose. Hash set not used. List not used. Set not used. Ordered set not used. Built-in not used. No internal compiler error. That's lovely to see. Which means, oh, validation boot. Let's see what the original validation looks like. Now it compiles. Can I just copy this? Actually, it's probably going to tell me that like a bunch of those are not required. So I should probably go back to the boot file and change something. Like this can be removed for sure. Make lenses, that requires template Haskell. Okay. This will probably require... Wait, what am I doing here? What? Okay, that signature is completely wrong. I think I got sidetracked while I was working on it, and that is just wrong. There we go. Is that because it needs to be eval instead of exact? Exact because I never remember which one is which. Probably. There we go. Couldn't match type role with the list of role. Oh yeah, of course, this isn't a non-empty list of role, it's a non-empty role, of course. Okay. Oh yes, this is always, the base name is always present, but in the, well, for the last few weeks, I have been doing a big refactor in which the project does not compile. Um, when it compiles again, I can go back to writing a bunch of tests. I don't have a lot of tests at the moment for this project, but I do have some stuff in place, and I do have some I have some basic unit tests, like for this thing, for instance, where I have some hard-coded golden tests. I have some basic unit tests. I think I have in a few places some property testing where I express a property and then I let the library I'm using generate use cases for the thing. It's going to be broken actually with this refactor. We're going to have to fix this. I have this in for the parsing stuff, for instance, I have a few things where I have some golden tests, but I also have a property which is not going to be broken, which is like, oh, if I pretty print an AST and then pass it back, it should give me the same AST. So I do that kind of stuff, and I will, of course, at some point, a lot of the code so far, all of the different phases of the code are expressed purely in terms of here's the input to the previous phase, here's the output for the next phase, which means they don't write to disk or anything. The main of the code will actually like do call a thing and then issues write to disk or anything, but each phase is purely in memory, which means I'll be able to start writing tests for, okay, the simplification phase should give me this, and start working on like golden tests, unit tests, property tests for all of them. To be fair, a lot of the tests infrastructure is there, but there are very few tests. Uh, Before the refactor, I had just this big file with a bunch of expressions and things to try to see would parsing them and compiling them actually work. We will get to testing at some point. Here the problem was this gives me an actual declaration name, and in a diagnostic this is a maybe, so I need to just wrap it with a just, like so. Report warning, yes. Oh, I wrote this wrong. Fail is the one that like gives me an A because it does a report error. Warn gives me a unit because that is a report warning. And now we are at the point where we're removing unused imports. We like to see that. Location shadows something else. Yes, location is also the name of a lens, so I cannot use that. I'm gonna use declaration name and declaration location as names. So that's the declaration name, the declaration location. I'm just gonna say message here, because there's no need to be that explicit. Up. Let's do the same thing here. That's the declaration name. That's the declaration location. Declaration name, declaration location, and the message. Maybe I'll do the same thing for validation. Come to think of it. Because I will have the same problem. I wish the it type checks, therefore there are no errors, were true. In the course of this project, this has been proven wrong quite a lot. I even found a bug in in Alex, the Lexa, that had been there for 7 years as part of doing this project. It was fun. It was a very, very peculiar thing of like the state machine that is used within. Oh, I reported it and I submitted the fix. I am now a contributor to Alex because of that one fix. There was a an optimization that was made, I think, 7 years ago or something like this, of the state machine that Alex is used internally to like keep track of the things, where it does some optimization to reduce the number of states, and that optimization had a bug where, and I am 90% certain. Well, no, not 90%. I am, let's say, a 60% certain that the problem was that the person who implemented the thing looked at the Wikipedia pseudocode implementation of the algorithm, which is wrong. I did not submit a correction to Wikipedia for it, but there is a thing in the Wikipedia implementation that's very unclear. And when I understood the algorithm of the state machine optimization and I looked at the version that was implemented, I was like, oh, this thing here is like the state was not maintained properly. So just doing this quick fix fixed a 7 year long bug in Alex. It was difficult to create. It will only show up in very rare cases, but it did show up randomly for me. So it was a fun thing. Let me see. I'll try to see. Having the chat not on the same computer on which I'm typing. Give me a sec. I'll see if I can find it by opening a window here. There we go. And if I go to pull request, go to closed. There we go. That's my pull request. And is there? There we go. Oop. That is the bug. I don't remember it well enough because that was back in April. Oh wow. The issue is long because I kept trying to investigate the thing and I did find I thought I had found the bug and I was wrong. And the last big message on April 3rd is the one where I actually figure out the thing. But yeah, that was a fun exercise. Oh, message is in scope, but I need to go back to validation here. Message. Okay. Oh, there was something else I was thinking I need to fix. Oh, I need to have a look. Okay, I only have one boot file, and that's what I'm aware of. That's good. Because I used to have more boot files because of the bad representation. And now I only have one for things that are like self-recursive. That makes sense. Wait, why is message not? Because I can't type. Validation T here. That is indeed not its name. It's called validate T. I've not sure about like the naming convention of like validate or validation. Like, should it be the verb? Should it be the noun? Maybe validation T makes more sense. I'll think about it. Module context is not a thing that exists anymore. That is the VS context instead. At some point, I want to change the report ICE thing as well, so that instead of using some kind of descriptor, it uses just the top level function name or just no descriptor at all. We will do that at some point. This is internal ICE. The context fun type. Why would that not be a concrete type? Oh, it is not a maybe concrete type because I'll just put unit for things that don't have that information. There we go. Module context. That doesn't exist. This is VS context. Same thing as the other one. This is just the base name because a diagnostic might not have a declaration name, but when it does, then that's where it comes from. And that's the declaration name. That's the declaration location. And that's the message. That's the declaration location. And that's the decla name. Okay. No instance from monad M. Yeah, that makes sense. I need M to be a monad. Oh, and it needs to be a monad diagnosis because I'm using try. Yeah, I really want to try to see if the finally thing works because this is like try the thing and then do a finalization basically. But if there was a proper monad finally kind of type class, that would be better. What is wrong here? Yes, one is the one that returns unit, while error is the one that returns anything that is a. Parse error in pattern. Ooh. Yes, this is not too up. It should be this. Aha, we're compiling the expression validation. This is where it's gonna get a bit ugly, probably. Couldn't find data ordered set because it is data set ordered. I don't think I need it in this though. I don't need to import the AST and I don't need to import common. I only need resolved and validated. There we go. I can remove all mentions of input dot. I can remove all mentions of output. Not if any still. I will probably need to do validated and resolve instead in a bunch of places. When that diagnosis not in scope, it is internal diagnosis. Location not in scope, it is location. And now this is where almost all of this needs to be. This is the resolved version. I could probably have kept the input output thing and used resolved instead and validated to avoid having to do this manually. But oh well. What's the type of this? It takes a resolved expression and returns a const expression. Okay, we're good. Yeah, I should probably have kept the input there rather than do this manually. That's a bit... It's not the most fun kind of work. Okay. And we are going to need to do the same thing twice more. For function expression. In which case I might just want to try to do when I have at the beginning of a line 1, 2, 3, 4 spaces and a uppercase letter, replace that with 1, 2, 3, 4 spaces, resolved dot whatever I matched. There we go. Let's do the same thing for the third and last here, which is okay, so much faster than I just do it manually. Because it is mostly unimplemented. Okay. Oh. Oh, because lens also defines something that looks like the blackbird. Int literal expression, in this case, it's the output, therefore it is the validated. If I find a resolved character literal expression, I output a validated character literal expression. That makes sense. Next, what we have, pass. Oh. RWS has a thing called pass. Interesting. I have too many tabs open. I should clean some of them. What does pass do in this context? Oh, is it something that comes from writer? Okay. M is an action that executes the action M, which returns a value in a function and returns the value applying the function to the output. Okay. Suppose. Here, I don't think I actually need RWS anymore. I'm just going to remove it. That's going to fix the problem, two problems at the same time. Ambiguous expression, yes. Oh, path info resolved, I can just replace by resolved path info. And here, this is a validated expression in output. Those are the roles. They don't have any collision on the constructors. That's fine. This is going to be a resolved by reference and resolved by value. That's going to be a resolved function type info. It's going to be so many of those. Oh, no, yeah, the constructor is just called function type info, I think. Function type, this one is in the output, that's the validated. Type doesn't exist, it is concrete type now. Typed expression, that is an output, that's the validated one. Validated here. Okay. Type no longer exists, this is concrete type. Those are the resolved one. Can't type, I swear. There we go. And this cast expression being created, here will be the validated. It's annoying to have to do this, but the result will be very, very explicit. I am doing a cast on the resolved version of this thing, and I'm outputting in the output the validated version of it. Result with, and there's going to be a validated version of this. Type no longer exists, it is concrete type. Struct info, this is resolved or validated. Since I am doing a field access expression, I am assuming that this will be a validated struct info. This is validated struct info as well. Typed validated expression. Unions with not in scope, that's because it's coming from didn't I add this to oh yeah, I put it in the prelude. I put it in the prelude. Maybe I shouldn't put this in the prelude. Maybe I should move those hash map helpers into... Yeah, I should do that. But I'm not gonna do it now, because I'm already stacking too many things on top of one another. So unions with is just gonna be not in the... for now at least. By value in this case is a resolved one. Function type in this case will be the validated one, I think. Because I'm doing a retrieve. Expression resolved is not a thing. So this is a resolved expression. I'm hiding the trees that grow completely from the rest of the code. That's the validated expression. This is a validated struct expression. That's a resolved expression. Wait, that's wrong here. Oh no, this is for the... No, yes, this is not a const expression. This is an e here because I am using this function for both. Yeah, validated const expression, validated function expression. I'm using both. This function is common across constants and non-constants, and I'm giving the stuff as arguments, and therefore this is not a constant expression. That's an e, whatever e ends up being. Okay. Struct info, this one being a retrieve struct, this is going to be the validated. And e2 list in scope, I'm going to need data list non-empty. Come on. Qualified as an e, as usual. Struct type is going to be the validated struct type. Oh. Wildcards may not be used for constructors with unlabeled fields. I thought struct type had. If I go to validated, struct type. Oh, this is probably because it's not. This is a struct const expression, and those have a struct info? No. It is a struct info, okay. Oh, but struct info, not struct type. That's what it is. So therefore, this is a struct info that indeed has a constructor named struct info, not struct type. So this is a struct info, and it's going to be the validated one. Validated. Wait. That's weird. Why do I need to do a retrieve struct if I already have it from the const expression there? So the const expression contains the actual struct info, not just the struct type info. It does indeed contain the actual struct info, which means here I don't need to do a retrieve struct anymore. That's nice. This will be validate assignment expression. This is going to be a validated expression. And this will return a validated expression. This is called div mode now. Those are going to be validated as well. Oh, that seems to be close to the end of the file. I want to believe. Oh, this one requires a parameter. And what this is for struct expressions, and struct expressions are, it's a function, struct info with a concrete functor. Yeah. AKA the types within this are concrete and not partial or parameterized. When a diagnosis is required here. Oh, it's because I have the wrong arrow here. There we go. Validate const path expression, not in scope. Wait. Oh no, it's because I have named it explicitly const past expression and not const past exp. Okay, that's fine. Validate concrete type. That is a function that exists, but I need to import type here. Is it types plural? It is types plural. Okay, and that is a cycle, I suppose. Yeah, types depends on expression. Why does types depend on expression? That might not be correct. I think I should be able to just remove the import of exp from this. Okay, ordered set is set ordered there again. AST is not something that I need to that exists anymore. Common doesn't need to be imported. And now I can replace yeah, path info resolve with resolve path info. There we go. I can replace type by concrete type. I can replace M by monad diagnosis M. And now a lot of errors will be out of the way. Validate no longer exists. This is validate. So validate M will be replaced by validate TM. Okay. Function pointer no longer exists. Struct type info has a different name now. Struct type info here, struct base name and struct type params. Okay. Function pointer no longer exists. Struct base name. Oh, because yes, of course, I have three different things: validate parameterized type, concrete type, and partial type. Three very similar functions, but with enough differences that it makes sense to have them triplicated, rather than trying to factorize them. Okay, I need internal diagnosis. Ambiguous type alias info. Since this is on the left hand side of the retrieve, this is validated. Pass is also imported in RWS strict, but I don't need RWS strict in this file because I no longer have any oh, this is a validated function type. Next, what do we have? By value. This is in concretize, which is only dealing in validated stuff, not in the original resolved version of it. Function type, that is on type, so it is validated. I'm just gonna recompile. It's gonna be the same thing here. Oops. Struct type info doesn't have this. Yes, we've been over this for the other ones. ambiguous occurrence. I'm tempted to just in this case, I don't think I need, I might just hide function type from resolved. And now I can do validated function type with just function type. So it's the only one that clashes with the other constructors. Wait, didn't I just hide it? I just did. Oh, I want to hide the pattern function type, the constructor. Means I need to enable language pattern synonyms. That should work. There we go. Path name doesn't exist. Path name has been replaced with path base, I want to say. If we go back to common and we go back down to path base, yes, okay. Validate type, parameter type. Oh, I suppose this might have been the one that was wrong, and I need, this was supposed to be validate type, parameter type. Parameter type. Yeah, I think that's what it is. It seems peculiar. Validate built-in type, validate built-in type. That's probably just the base name that I need. Although I suppose, no, I could change. Let's change everything again. Well, not everything, but in role, built-in type can be the name. There's no need to actually just have the base name there, which means that in built-in, this can be just the name. There we go. Validate struct type. Oh, is it because I made the mistake of... Because validate struct type doesn't exist. What I have instead is... Well, it does, but it's not the one I want to use. Where are you? Oh, you're in types. Oh, there it is. I'm thinking of something else. I'm thinking of the validate struct expression. Okay, so what is wrong here? This returns a struct type info, while this expects a concrete type. So this will be, I suppose, a struct type. A struct type info. Okay. So maybe I'm wrong about the validate type parameter type. It doesn't seem to exist. So I have the mappings, the type name, and the parameter name. Okay. Yes, this is expecting to be an identifier, which is used as the key here. I am looking for this combo of base name identifier in the mappings. If I find nothing, then I retrieve type parameter. What is retrieve type parameter? Oh, from the function, of course, from the surrounding context. Okay. Validate concrete type is go MMT. And that's the path info. There we go. So this function must return a concrete type. And I suspect that if it's unhappy with me, it's because it doesn't in all cases. Validate built-in type does give me a concrete type. Oh, am I in the case of... Oh, I'm in the case of concrete type, okay. Oh, is it because... What happens if I type this explicitly? I have a hash map. I can type, I swear. From base name and identifier to a concrete type. And I have a resolved path info, and I return a validate TM of a concrete type. If I type this, does it give me another error, or is it more specific? Aha. So validate type parameter type doesn't give me a concrete type, or at least a type that matches what I expect given... Oh, is it because it doesn't give me... Is it because it can't detect what the type is supposed to be based on the input? No, local mappings should give the information. Validate type parameter type. Yeah, it should give me, if the local mappings contains concrete types, which they do, it should give me a concrete type on the way back. And so, in concrete type name parent name, oh, is it a type node type tree kind of situation? No, that's a type tree indeed. Type, oh, I suppose if it's non-injective, then the argument is not enough to figure out what that thing is supposed to be. Could it be enough to instead say that's a type T here and that's a type T here? However, that's not going to work because of retrieve type parameter that is coming from context. Retrieve type parameter that always gives me a concrete type. So, of course, that cannot work. So if I'm resolving my parameterized type, so I think this function shouldn't exist and should instead be in line in all three cases. So validating a concrete type will be validating type alias something, something, something. I don't need to give it go. I can just give it... No, sorry, this one. I can just give it, yeah, all that. So I'm going to copy it as it is. And for a concrete type, I'm going to copy it here. Remove the type. And it's just that. And in the case of the concrete one, it does the on nothing of looking at... Wait, no, I do an abstract pure. I do... No, it is actually trying to do the smart thing. So maybe I can try instead to be explicit. Like this is validate type parameter type for the concrete functor. Would you be happy with this? You seem to be, interestingly, okay. Retrieve struct params is not in scope. Let's go see context. Retrieve struct params right there. Wait, do I not have context in this? I don't. Okay. I hope this doesn't create a loop. It doesn't. Perfect. That's set ordered, not ordered set. AST is not used. Common is not used. This is expects. This would be as resolved and as validated. And I will replace any instance of bunch of non-space followed by resolved dot the thing, not this one. Okay, so that's fine. But I can do the same for validated. Okay. There doesn't seem to be a lot of uses of the resolve stuff in this. So I might be able to... No, I do have resolved here. Okay. Const exp doesn't exist. It's const expression now. Const def will be... this is... I am returning something that is coming from the... This is the validated version. I'm tempted to, in fact, since there's almost no use of resolved in this, remove all validated dot and just import resolved qualified and make the exception rather than the rule. type no longer exists. This is concrete type. So is this. Struct info will be... this is a struct info of validated, so it's going to be a concrete one, I think. Or can it be any of F? It might be just any of F, I think. No, because it is a definition, and a validated definition is a specific one. Because a validated definition is a struct info parameterized functor. Now, okay. And then scope name. Is it because it's called base name? Enum info is not in scope because I'm forgetting a letter. Definition is not in, it's not a string, so I need to do a show. Likewise here. Aha, this one is a resolved definition as an argument. And that's therefore a resolved function def as an argument. Wait. Where is assert function definition used? It's used in context for retrieve. It is used, what's the... No, isn't... What's the thing to have the line numbers? Is it n? No. It is n. It is used in... Wait. It's not used anywhere. It's not used anywhere because in context, when I retrieve the function definition, I do a lookup in something that doesn't need to be introspected that way. Assert function definition, you go away. Okay. Expect type matches. Oh, that is gonna be a circular import because type matches is defined, I think, in types. But maybe it shouldn't be defined there. Maybe it should be defined in expect, since it's the kind of stuff where... Oh. Types doesn't depend on expect. Interesting. So expect could depend on types? Yeah, I suppose then. That's fine. As long as there's no circular import there, I'm okay with that. Now there is. Okay. So, context depends on expect, which depends on types, which depends on context. Okay. So I'm going to remove this one, and I'm going to move those assertion, type matches, and types all match, and I'm going to put them in expect where they belong. Report doesn't exist. This is now most cases of report, and I guess I can match this will be fatal. Oh, I will need the that diagnosis everywhere. Then I will need to import internal diagnosis here as well. Then, aha, no instance for EQ on a function type info. That is something that is not a complicated common thing. That is purely doing equality on where is it? Identifier function archetype. Oh, but it is doing equality on types. Which is something I've been wanting to avoid. So that means I probably can't do that. Wait, am I looking at the right thing? Yeah, function type info. Yeah, so I think I cannot do that. So I'm gonna have to do functions match f1, f2, and introduce functions match f1, f2. And this is gonna be for, I'm gonna just do it in the main screen. There we go. Function info. Function type info, I think. Because this is for a type. Function type info. This thing. Oh, that's complicated actually. That's complicated. What does it mean for two functions type to match if they have the same structure but different name for the type parameters? That's not easy. That's not easy at all. Okay, that's no longer just fixing small errors in the big mess. This is actually now fixing the code, and this is interesting. Let's do that. It's late. Let's do that. So I have two function type info f1, f2. I will want to check. What I will want to do is basically do a zip, a pairwise check of all the types of the arguments and of the return type, and I want to check that the only difference, if I do a mapping from like type on one hand and type on the other, if it is different, when it is different, it has to always be from type parameter to type parameter, and it has to match the list of type parameters. Okay. We do have things for us in that regard. Just gonna scroll this to just be the bare minimum I need to have in scope to see what I'm doing. There we go. That's the bare minimum I need. Ah, come on. There is somewhere, I don't think it's in expect, I think it's in types, which I cannot access from here. Fuck. That's gonna be a boot file there again. I am going to need, let's go have a look at types. Build type parameter map is what I want. But for build type parameter map, oh wait, are the type concrete in this case? This is a function type which happens to be I think concrete always, right? Well, that depends. That depends. No, this expect is on concrete types. So there's no type parameters. So this should be basically just equal to type matches. I don't have the problem. Okay, that's good. So type info. So for two functions to match, the parameters are no longer relevant because at this stage they are concrete, so there will not be any type parameters anymore. Actually, on that note, function path expression, there we go. Wait, there's a big case missing here. That's completely like there's definitely something missing here. Like this is fatal, not error, not a value, I think. I wanted to check when I have a function path. I think here I must validate that it is concrete. Yeah, I think this is wrong. I think this is wrong. If I encounter a function name as an expression assigned to a variable to create a function pointer, I must assert that this is a concrete function and therefore that all the types are given. In fact, I do that because I validate that the number of type parameters is the same as the number of expected type parameters. And I validate all the types of the argument as concrete types. So it needs to be very explicit. Okay, so I know at this point that it is. Okay, and of course, this is what I do. It's. I only register it for instantiation if it was a generic function in the first place. Okay. I don't know if those need to be kept as they are because now they are misleading. Now those are misleading because that function is now this thing with the validated arguments and the validated return type no longer has any type parameters. I think this is misleading and should be this instead. I think. Maybe it doesn't make a big difference. And for a function call, there we go, right there. I think the same thing should be true. Where the validated return type, it is a reify type. What do we do for reify type? And I think here, since I'm reifying, this should be concrete, and therefore here this should be fun params equal empty list, I think. Except will I still have type parameters in this one? I don't think so. I don't think so. Okay, well, we'll figure out if it is broken. We'll figure it out when it breaks. Okay, so back to expect, back to this. If I want to compare for equality two function types, I can ignore the parameters, I think, because at this point this is concrete. So I can just do the name of the arguments doesn't matter, but the function return type must match the other function return type. And for, yeah, zip with type matches, there is a thing I think that does that. I have a function from A and A to B, and I have a function from C to A, and I have two C values, and I want to apply that's close to on, I suppose. Yeah, it is on. Okay. So this is type matches on second of the fun args. Hugel for the win again. Hugel is fantastic. Okay, so that should be enough for the functions match, which means we're back to compiling things. Except F1, F2, obviously. Fun return type, isn't that? It's fun return, yes. What's this? Aha. Of course, those are not. Haha. So this is not type matches that I need to do. I need to do. I'm just gonna do that. I need to do function args match, because those are not just type, they are function args, and those are special because of the weird reference semantics that I have in this language, which is basically none. So let's do a case. Or I can even write, I think, as a query of a function that expects a tuple. And if I have by reference t1 by reference t2, I can do t1 type matches t2, and if I have by value t1 and by value t2, I can do t1 type matches T2, and if I have anything else, it's false. Okay. There we go. We are at the great time where the errors left in this module are just imports that are unused, which is just warnings as errors. Oh, resolved not used. Huh, it's great. Perfect. Is this... Oh, set ordered, but I probably don't actually need it. I'm just gonna remove it, I think. AST no longer exists. Common no longer needs to be imported. Input is not something I still need. Oh, I don't have it at all in this? Fascinating. I do have a bunch of output, however, so I'm going to replace output by validated. Let's see if I have any input as resolved. I don't seem to have any. No, but I have a few places. Okay. So if I have a place where I have this would be open parenthesis, some kind of word followed by resolved. This can be replaced by resolved dot this. There we go. There's only one? Interesting. Okay, but I must have the same thing with validated. I do. So that's a validated struct info, validated definition, validated definition, and so on. Perfect. Oh, I need also to do, this is no longer monad M, it is monad diagnosis M. And I need to import internal diagnosis as part of this whole thing. There we go. Struct params is ambiguous. I'm tempted to do the thing I was doing before, where resolved is going to be imported qualified, because everything else in this file is actually the validated version. Because I operated this point in the validation monad, so resolved is just lookup local definition lacks an accompanying, because here this is with plural, which is wrong. Okay. Ah, the boot file has the same problem. The boot file will do qualified as resolved here as well. Remove the validated. There we go. Struct info. Oh, is that because... Okay, let's have a look. Validated. What kind of struct info? It is a parameterized functor in a struct definition. Okay. What's wrong with that? Type definition with definition. So traverse definition, retrieve definition gives me a definition. Okay. Oh, why am I doing a traverse then? Indeed. this might not be typed at all. Look at validate again. Yeah, it's not typed. It's just that, and therefore there's no need to traverse. Typed const expression is correct, but there's probably still no need to traverse. Okay. Assert constant is not in scope. Let's look at expect, because it's called assert const, but we can do better and say assert constant. There we go. Um, so something is wrong about this thing. Oh, I suppose. Well, no, I have an ensure here, so this should always give me. Oh, but I do an ensure on. Yeah, I think this is incorrect. I think if I do this, what does it tell me? It tells me that the type here is something that given a base name, given a function, huh? That's peculiar. Because otherwise, if it were not for this base name thing that is weird, indeed, a maybe of the thing. What I don't understand is that this thing should give me something inside the monad. Oh, but it might be under the mistaken apprehension that this is within the monad, which happens to be the reader that takes a base name as an argument. That is a possibility. Because of the base name argument here, that's what it is. And so here, I should be able to do ensure of this. Oh, it's a with location. It's a with location, and I probably want that, I think. Where is retrieve function definition used? It's going to be used in the instantiation code. Oh, it's used in exp? Oh, it's used, of course, to then register the function for instantiation. But instantiation should be taking it does not. Wait. No, I do have. Okay, the function instantiation request defined here in the monad does contain a function info resolved, but it should be a with location resolved function info, which is what I expect here. I expect this definition to be to have like a location. instantiate request here. Yeah, I expect this to have but here I don't. Okay, so I should probably fix this and here say the located thing. Okay, so now I have the location, so I can start the process at the proper location, which means that when I create a function instantiation request, this must contain, it must be the result of retrieve the function definition. So it's fine for the function, the retrieve function definition must contain the location. So this must be a with location, which is what this thing returns. So now that should be fine. Okay, with location not in scope, that's easy to fix. That's just location. There we go. Validate state with validate context. So that's not... Ah, yes, use context params is wrong. This is current params. Wait. No, that should be fine. Oh, it's use current params, I think. Okay. And here is the same problem where this needs to be put into ensure like this. Although there are some more issues here. This needs to be given the base name as an argument because I am not actually... Okay. That's for lookup remote definition, lookup local definition. Are those used often? Lookup remote. Okay, it's used in a few places. So, okay, it's worth keeping then. Okay. Aha. Of course. Yes. This is going to be... I am trying to get the definition of a struct, and I only care about... So this is going to give me a definition, so I need to get... Okay. So this is going to need to be instead where... If the definition is found, it must be... So this is going to be an assert struct, basically. Okay. If I go back to expect, there's this assert struct. There we go. That will give me the struct info. That's what I want to use. So I want to use assert struct of this. And if I do a retrieve input definition, that gives me a resolved definition. In the oh wait, is that correct? Validation monad. VI definitions? No, that's incorrect. The only resolved definitions I have are the local definitions, like this. So retrieve input definition, where is that used? Okay, no, it is supposed to be that. But that has to be the local definition then. Okay. I suppose this is a traverse assert struct because it gives me a maybe. Oh wait, is that why I had a bunch of... Oh, but those give me a non-maybe thing. Okay, yeah, that's why. Wait, what's wrong there? It's here, so those seem to be okay. And if I do a retrieve input definition, yeah, of course I need to give the base name there. Retrieve input definition gives me a definition guaranteed, but I will need to do an assert struct again. But not this time. I can't do an assert struct because struct is on the validated version. So instead, I need to do a assert struct definition, I suppose, to be consistent with how I've named other functions in here. This is a resolved definition, and I get a resolved... What case am I doing this for? For the struct parameters, yeah. So here I want, indeed, a resolved struct info. And this is exactly the same thing, but with resolved here. Struct def const info struct. Let's be better than this. Okay, so here I can do traverse. Well, no, this is going to be always guaranteed. So this is going to be an assert struct definition. And here, yeah, I think this is correct. Resolve definition, no module name resolved is imported. That's perfectly easy to solve. That's resolved, qualified as resolved, as validated is no longer required. There we go. Oops. Qualified as resolved. Oops. Resolve struct info requires 3 more arguments? Oh, because this is the... Resolve struct info. Oh, it's the constructor. I don't have the type. So I am going to need to add a struct info here, which is going to be the common struct info resolved. And I'm just gonna do this. And I'm gonna add it to past as a matter of symmetry, even though it looks like it's not gonna be required. Okay. Aha. Oh, I have to recompile the parser. That's why it's so slow. So it expected a resolved struct info, and instead it got a validated struct info. So something is wrong in my expect. Oh, because of the struct params here, this is gonna be the resolved struct params. There we go. This is gonna be again a pipe into a sum. Pipe into ensure. Okay. So this gives me some kind. This is an on nothing M, not an on nothing. Validate definition. Yeah, I don't know. Sometimes it makes more sense to me to just like, here's the like same as dollar, where like you do function dollar the big thing. Well, I do to the function reverse bind the big thing. I don't know. It makes sense to me. Arguably, the fish and reverse fish are a bit more up to personal preference. Why does validate definition exist? Because that's the one where I need to import validation itself as source and complete the graph. That makes this file horrible. Oh well. And actually, the boot file, I think validate is not required. It's only validate definition that's required. Oh, wait. Can I avoid this boot file? The only place where I need it is here in context. No, I think it's really a top level function. It makes sense for it to be at the top and therefore to have a cyclic import. I'm okay with that boot file. Okay. Monad diagnosis not in scope. That is coming from diagnosis. Not batteries. Internal. Actually, I could do a Haskell mode on this file because Emacs doesn't know how to do Haskell mode automatically on boot files, which I can't blame it. It's not a name that you might expect to be a Haskell file. Actually, I suppose I can just do that in this case. Validated is not required. It is. You joke, but I think everyone who learns Haskell and knows C++ at some point makes a what if I re-implemented monads in C++ using the shift assignment operators. I have absolutely done that years ago, probably 10 years ago at this point. Like, it's ugly, it's bad, it's not something that you should do, but you can do it and that's fun. Like, and using, I mean, like, that it's kind of the obvious thing and it's fun. Validate T is not in scope, and I mean, you should try it out. It's fun. Is it good? No. Is it fun? Yes. I think one of my favorite horrible C++ thing I've ever done. Sadly, it never got accepted. I had a pull request for it. I made a pull request to boost preprocessor, which is a boost library that has a bunch of C and C++ macros, including container types and like container manipulations in macros, in C++ macros. I added a sort function for the container types of C++ of the boost preprocessor that would sort and remove duplicates or just sort a macro container thing. It was absolutely horrible. It was a pure insertion sort in macros. The reason it never got accepted in Boost is because it was making VC++ crash. So it was never accepted, which I was sad about because it was fun. The worst part is I used it in a personal project, a side project that never got so prod or anything ever anywhere, but I used it because I was generating. I had a very complicated inheritance system for a UI thing with diamond inheritance and stuff. And I wanted to automate some of the property stuff. So I would say, well, with macros, this type has this property, and the resolution of where the properties would be going from in the inheritance tree would be generated at compile time from macros. And I would use the sort thing to be able to like sort the inheritance order of things in the macro. It was a mess. It was great. Like I think experimenting with things like this is great as long as you don't try to push them to prod. Okay, and now we are back at the point where we have to just clean all of the imports that are not required, which is going to be actually most of them. Actually, I'm going to recompile because I've lost my train of thought. There we go. Next, built-in goes away, identifier goes away, interface goes away. Okay. And now validate definition. Actual resolve definition? No, that's not correct. Yeah, that gives me a validated definition. This gives me a okay. So why does it say that in this context I'm expecting indeed something that from a resolve definition gives me this, which is the validate T of M of a maybe definition. And actual is a maybe resolved definition. That's not correct. Because that's the one that's imported from the source file. So it's imported from the boot file here. And this clearly, because I'm an idiot, there we go. Okay. Retrieve input definition. I'm expecting this to give me a with location. And it actually gave me the raw definition. So this should be a with location. Okay, retrieve input definition, assert struct definition. Oh, I suppose the assert struct definition will then now expect definition. So here I will need to do the located. I need to remove the location information. There we go. Control monad loops is redundant. So we are at the point where, again, we are cleaning the imports, which is always a good place to be. Yeah, I mean, it is a conversation that keeps happening of like what level of complexity is acceptable in a code base. What's the limit on like magic macro stuff? When is it good? When is it bad? And the bigger the project, generally, although there are exceptions, the bigger the project, the lower the tolerance for magic things. If you have a very large project with hundreds of files and hundreds of people working on it, and half of them rely on a horrible macro system that three people in the entire group understand, not great. If, however, you have a file that has a very clear API that doesn't have magic, but the implementation does something magic at some point, that's more fine because the API is clean. The rest of the code doesn't need to understand the magic to just use the API. But there is an implementation detail that is a bit of magic that you can comment explicitly. I like the GHC style notes of adding like extremely long comments to your code and everything. And like isolated magic behind a clean API that's not magic, fine in my experience. Like if you ever need to, I've been in the code base once. I had to use unsafe interleave IO in Haskell, and I can tell you that this was nested within a clean API with like a lot of comments as to why it was needed and how it worked. And as a result, callers of the API didn't know that under the hood it was doing some unsafe interleave IO. This shadows an existing building. Building. Oof, I'm tired. Binding. Yeah, I know, job security and everything. I'm gonna rename it type base name just to avoid a shadow warning. What else do I have left? Because those are warnings, I think. Report doesn't exist. That is a fatal in this case. Oh, and I haven't fixed this type in this file. This is not. There we go. That's when that diagnosis, which I will need to import. It's already in scope. Perfect. Report no longer exists. This is fatal now. In fact, have I used the warning thing even once? I do have, outside of old, I do have warning and name shadow, but those are the diagnostics. Oh, I do have name validation there that does a warning name shadow and a warning and expected. So okay, so the two warnings do use warn. Perfect. Next, what do we have here? Validate partial type. Oh, is that the same thing where I think that's the same problem where the validate type alias type here is not. Yeah, I think that's the problem I had here as well. think I think it's yeah, I think if I type it explicitly, then the compiler is less confused about what the type of the functor is in places where it's a bit ambiguous. So let's type it explicitly. In this case, this is not a concrete type, that is a partial type. And I am validating into a partial type. I'm just going to preemptively go to the last one, which is here, where I have it set parameterized type, and I'm returning a parameterized type. For some reason, it struggles a bit with the inference there. Okay. Hmm. Oh, of course. This is the problem there. Maybe I had a similar problem above there as well. No, because concrete type doesn't have the on nothing. Okay, that should be fine. Mixing infix functions and dollar. That's a bit of a mistake. Type node partial functor with maybe partial type. Well, this does indeed. Oh, I suppose, yes, the top level here could give me a maybe. This could give me a maybe. Because I could stumble onto a placeholder. Yeah. So I need to take this into account, which is why I have the on nothing M here. And here is the same. This could give me. No, it is. Yeah, it's fine. It gives me a parameterized type that already includes the possibility. Perfect. So validate struct type here has a functor problem or something. So it expects a maybe partial type, and instead it gets a struct info. So if I find a struct, then I can always return just of a struct type, which is constructed with a struct type info. Okay. Validate enum type. That's the same thing where like this needs to be put into a just. This needs to be put into a just as well. And I'm ready to bet that the next one needs to be put into a just as well. Wait. Wait, how is partial type defined again? I think partial type is defined in such a way that, yeah, it cannot be maybe at the root. Aha, that might be the problem. That might be the problem. Because I must have. So this returns a maybe partial type. And so the validate type alias type needs as an argument a go function from t to a resolve path info. Aha, yep. Okay, I see. Because in the case of a concrete type and a parameterized type, the t here matches the t here. In the case of partial type, it doesn't. In the case of partial type, it doesn't. Could I perhaps, since f is the last thing I use in this function, okay, let me think for a second. Because I could generalize this to be on like some applicative of the type, which would return some applicative of the type. And in the case of a partial type, that's maybe, and in the case of the others, it's just identity, and I do a run identity on the thing. Wait, no, I'm wrong. I'm wrong. It does match. It's fine. It all matches. I am fine. I'm wrong. I don't need to change this function. When I validate a partial type, this contains a maybe potentially. So it does match everywhere. There we go. So I still have a problem on this function, but perhaps because the just here is no longer required as a result. And I think that was it. Okay. And here it's going to be something very similar, where the struct type gives me always something, therefore it needs to be wrapped in a right. This is going to be the same thing here, I'm certain. Oh, well, I suppose I don't need to do it here, since validated struct type is here. This is going to be pure, I'll get it, right of a struct type containing a struct type info. I don't know why I've kept validate struct type separate across the three different ones, despite the fact that it's doing exactly the same thing. Oh no, because the argument to validate parameter count is different. Okay, that makes sense. Well, I suppose I could give it as an argument, but... Um, so validate no params returns something in the surrounding monad, which is... Oh, I don't need to do that. I already have... validate no params is just validate params count. And with this, and I don't need to do more. And it's in expect, I think. It's not? Huh, interesting. Is it in types? It might be in types. Yeah, validate params count. There we go. It's here. Oh, and it requires the base name that I don't have as an argument. Okay. So, base name. That's gonna break a bunch of things. That's fine. We are used to breaking a bunch of things. Validate params count. I was doing this for the built-in type. There we go. So that's going to be the name base of the actual name. Did I use the wrong operator again? Because I always confuse this one with this one. In this case, no, I want this one. Okay, that's the correct one. I have some kind of functor here, which happens to be my validate thing, and I just want to override whatever is in it by this value. and override by this value. Oh, it is. Aha. I'm confusing with this operator. There we go. That is what I want. Mm. So here I have again some Go problems. Expected path info, yes, and returns a identifier, and this is a concrete type instead. Interesting. So something that uses the parameters assumes that those must be identifiers rather than being concrete types. That is wrong. Oh, I suppose it's because I probably have a validate params count that use expect the base name now. Let's go look at all the validate params. Since I have changed the arguments, this is going to break a bunch of things. Thankfully, the base name is always in scope, so that's easy. Okay, should fix a bunch of errors. Oh, it's getting very late. It's not called actual params, it's called params. Validate type alias type. Okay. So that's my recursive functions with the mappings. That's the local mappings, the base name, the params. Oh, is no, the validate params count is here. The params have already been resolved, interestingly. So this is indeed calling this callback f here with the union of the new mappings and the local mappings, and the alias value, which is indeed not a resolved path info. That is indeed incorrect. Okay. Because if I get the resolved version, so that's the problem of recursive type aliases. That's what this is. That is what this is. And when I get this value, it is of type. It is this kind of thing. So it's this kind of type alias info. So it contains a parameterized type. Aha. So the problem is that validate type alias type will contain a parameterized type, and I will need to translate that into whatever kind of type I am interested in at the moment. So I will need to reify that parameterized type into my target using my mappings. So I don't need the recursive function there because by definition, the type alias has been resolved. And here, what I need instead is I need to reify with that hash map the parameterized type. And now the go argument is not required here, which is nice. That makes a lot of things simpler. And here as well, the go argument is no longer required. Oh, do I not need to... Do I no longer have go anywhere inside? No, I do traverse them. Okay, yeah. Yeah, no, okay. I was gonna say, can I remove this go function and just make it like the actual function then? But no, I need the mappings. Reify type. F is no longer an argument to this. So the local mappings are indeed a hash map from base name identifier to something. And here I am zipping. So it is a hash map from base name identifier to type. And here I am zipping mapping base name before the IS parameter. So that's also a tuple base name identifier as the key, and I map that with the parameters, which is the types. So that should be the same union. Oh, is it because refi type expects... Aha. It expects a base name. It only expects the identifier here, which I think is wrong. Which I think is wrong. And I think this should be the base name and identifier. I think. So I can do lookup parameter base name identifier, and this is, well, I suppose this is like type parameter, and I just use that tuple. But that means this requires to be base name identifier. I suspect I don't need the base name, but this is going to make debugging a lot easier. So I think I want to keep it. That means invalidated, that this is either with a base name and identifier here. This is going to break a bunch of other things. Yay! Let's fix them. Huh. Here, params is clearly a list of type T, and hashmap is clearly, so those should be the same. So perhaps I should specify to reify type here. I should probably instead do the applicative f thing and say this is a type tree of f, and I'm returning here type tree. I'm getting a type tree of f. This is a type tree of f, because otherwise the thing underneath gets very confused, I think. Okay. Expected a type node concrete functor, and instead, oh, that's because here this is, here now I need to specify, like I was doing in another place, I think. This is the case of identity that can't be determined by the call argument. Oh, and here, if I want to do that, then validate type alias type needs to have the applicative f first, so that the type application goes to the f first. Okay. I think that's the same. Oh, did I do it on the... Wait, no, I did the wrong thing. I did identity. That was completely wrong. That's not correct. Well, I suppose it is, but it is... It is concrete type, so I could use concrete functor instead of using the identity, which it happens to be. Wait, so where did I use at concrete functor then? That's wrong. That's at partial functor there. Partial functor here as well. Maybe I don't need it for type parameter type? Oh, I need it for both. Okay. Okay. So this is for parameterized type, so this is going to require the parameterized functor. And this is probably going to require it as well. So that the type system knows what I'm trying to do here. Okay. So here I get... Oh, reify type is total. So I need to do a pure there. Convenient. Isn't that the same thing? Oh, perhaps I need to reify type and also specify the at f there so that it knows what I'm doing. Not in scope. Oh, and if I'm using it, then I will need to do a for all fm. Okay. Abstract not in scope, that's from HKT, which should be internal HKT. I think this is going to be the same kind of problem where I'm probably going to need to do a for all fm to put those thing in scope, and I will need to do that. This is with f. Oh, and in fact, here I need to do type tree f and type tree f the same way. Okay. And here, likewise, I'm going to need a at concrete functor for it to be happy. It needs to know what the type of f is. Now, what do we have here? I do a lookup of the type name and parameters within the local mappings, and on nothing. Why does it give me a type node? Actually, I should probably call it base name to be consistent with how I've been naming things. So I have a hash map from base name identifier to some type tree of f. I do a lookup of the base name and parameter name in the local mappings, which is this hash map from base name identifier, and I get the type tree of f, but it's a lookup, so I get maybe, and on nothing. So this thing probably has the wrong type then. So retrieve type parameter from the context. Oh, right there gives me a concrete type always. Oh, base name now. It gives me a concrete type. And in the monad. And if it is... So maybe this is wrong then. So what would need to be there? So this is something that given a type node... Why a type node, not a type tree? Oh, that's because concrete type... I see. Because concrete type is the same thing, type node and type tree is the same thing, of course. So if I do an abstract, let's look at HKT. Where's abstract? Okay. Isn't that the same thing as... Yeah, that feels correct. This abstract pure feels correct. So what's wrong with it? Oh, I haven't saved. I should probably sleep. Okay. What if I introduce a local function that to a concrete type where adapt, which to a concrete type will associate the corresponding type tree of f, which is this f here. Adapt is abstract at f pure, so it's actually explicitly type as this, and here I do an f map adapt Will this help the compiler figure out that the types line up or no? Okay, so here it's not happy. Expected concrete type to type tree of f, actual type node identity to type node of f. Aha. Okay. Ah, of course, a concrete type is something that wraps in the functor. So if I'm trying to make into something else, I need to then put it into the functor as well. So is that an H pure? Okay, that looks better. It just doesn't know that the type F is that. So now I think if I do that, there we go. Now build type parameter map. Yes, of course. This is the thing where I need to think. The reason why I have the base name in not types, the reason why I have the base name in the hash maps for type parameters is I am worried of doing replacement where there's two different types. Like I have a type alias that uses T into a struct that uses T, and the mapping gets confused between which T I'm talking about. So if it is differentiated by the base name, it should always be clear. In theory, that's not required. With the fixes I've been doing, it shouldn't be required. I think I'm gonna keep it. I think it's better to have it and be always very explicit about what's happening. That means, however, that indeed in types, I'm gonna have a problem for this because now this is no longer be a map of, this is gonna be a map of base name and identifier to concrete type. And that means that all the places where we do type resolution are gonna be broken now. So if I go back to exp there, and I look for build type parameter map, there we go. Oh, that should actually probably be fine, except that a few lookups in it. If I look at parameters map, validate param, which is going to be part of this. Yeah, here the param name is not going to be correct. This is going to have to be base name and the thing, but the base name is in scope, I believe. We'll see. Okay, let's continue. Expected partial type, actual parameterized type. Interesting. Yeah, I suppose that a incompatible type expects a concrete type. So what does that mean? That means I need to reify this, but I don't know the type parameters. Hmm. So here this is, I have a type that doesn't work, so I will need to do some kind of like force reification of the parameterized type, which will be something like this. But without the lookup parameter. Force refi type is not going to take the hash map at all. And in the case of a parameter, is just going to put void, I think. And everything else remains the same. Except every time I call refi type in this, I need to call force refi type instead. Remove the mappings. And here, likewise, it's a force refi. And there's nowhere I need to adapt the mappings, and this is a force refi types, and there's no mappings. Which means they need to be removed from this too. Okay, next. Force refi type. Okay. Struct fields is not in scope. So that means struct type, that's struct type info, which is coming from validated. Ah. Oh. I think that's fine. I think that's fine. That just means I need the struct fields when I'm doing this. That's fine. I only do it when the types have already been resolved. So that means when I'm doing this, here I need the struct info that will be obtained by, and if I look at struct info everywhere else, oh, not in there, interesting, in expression for sure, by doing a retrieve struct with the base name. So I need to do the same thing here, but I need the base name that I have access to with the struct base name of the struct type. There we go. And that gives me the struct fields that I require here. That's the validated one. And struct fields is not correct. Oh, it's struct values now, I think. It is. Expected. Oh, because it is struct values is already in scope. I don't need to do that. Aha. Couldn't match non-empty with list. I have somewhere in this a list for struct. Oh, or is it a zip with... Wait, the struct fields, the struct type. That's incorrect. There is no such thing as a struct fields. Something is wrong here. Something is very wrong. What am I trying to do? Concat of a zip with M, yes. With Go, that makes sense. The struct values will be what I want. They will be the non-empty identifier. Yeah, so it's going to be the parameterized type. But that means on the right here, I need... Why do I do this fmap of void type? That makes no sense. What am I doing here? Oh, yes, of course, this is the case where I have a void type. Aha. So I think I will need this in this case here. And I can probably do that first. Get... Oops. Get the struct info here, use it for the struct fields and compare. Yep, and I will need to get... Aha. But the problem is I will get the struct fields... Okay, this might be a point where I'm gonna stop. Because this is getting complicated. I'm gonna fix the end of this. This is the struct info 1. This is the struct info 2 that contains the fields of the given struct. However, here, in this case, this is a parameterized type. What I'm trying to... So I'm going to need to reify it based on the type parameters that are there. Okay. And I will, yeah, and I will also need to translate. Yeah, okay. Here is where to do all the things. I really need to continue doing this. There is, and even here actually, this is where, and I actually I'll think about it ahead of time. This is where I might be able to realize whether I need the base name in the lookups for type parameters or not. I think I don't. I think I don't. Because in this case, I can always replace all of the type. I can map the type parameters to a new type parameter by refying, but replacing with the parameter types of the caller, basically. Yeah, I think I'll be able to do just the identifier thing, but this is getting complicated, and I am getting tired because I've been at this for holy shit 7 hours. I should take a break. and refi struct fields to refi both struct fields. And I think, yeah, I think I'll check, but I think this means I can get rid of the base name tuple thing in the parameterized type because I will never find a type that hasn't been reified properly. Therefore, there will never be a case where it's ambiguous what type parameter I'm talking about. Therefore, the base name should not be necessary and I can simplify a lot of code. But at the price of here, when I build the type parameter map, I need to do the reification there. This is because I've introduced indirection in struct types to allow for mutually recursive structs if they have types that can be of size 0, basically. Okay, we're getting pretty close to being done with the refactor. I was hoping to be able to run it this evening. Sadly, we won't. But that's fine. See if there's any other error I want to address. That's all in this function. Yep, that's all in this function. As we have, that's all in this function as well. Aha. Validate type pattern. There we go. Let's see. What? What? That's completely wrong. That's completely wrong. Okay, fascinating. Wait, is it? Wait, is it? Wait! I might not need to retrieve the struct there. Because here I'm doing purely... Oh no, I need to do the fields. I need to do the build type parameter map. No, I don't need to retrieve the struct. I don't need to retrieve the struct. I am only interested in comparing the type parameters on each side, so I don't need to retrieve the struct. So I might not need to reify things because I don't need to reify the struct. Okay, so maybe there's a way out there. And I think here the problem is the parameters, right? Okay, it's not too bad. What is missing is here I need to zip with m validate type pattern the struct. What's in it again? Where are you? There we go. The struct type parameters of struct type 1 and which I guess I could do like this, validate type pattern on struct type params of struct type 1 and struct type 2. So the pattern match if the name of the base of the struct is the same. Like this is a footed bar, this is a footed bar, and the type parameters match. Okay, this is fine. This is easy. And I think here, I don't need the retrieve struct. I think I was wrong about this. because I only need to compare the type parameters. The type of the fields I don't need to compare. So I need to look at the type parameters on each side. Which is just here, struct type parameters, struct type parameters, which I can rewrite as being of go on wait, do I need the second thing? I don't need the second thing. It's just struct type parameters of struct type 1 and struct type 2. So if on the left hand side I have a foo of bar and baz, on the right hand side I have a foo of bar and int, then I will point that baz and int are not compatible. Yeah, I think this is fine. I don't need the fields. I think this is correct. Therefore, I can fix this too. I don't need the retrieve struct. If it's a void type, so there's going to be, yeah, zip with go on. Wait, what would struct type params have? Yeah, it's just, so this is just this. Struct type params of the struct type. And I need to zip with, actually I don't need to zip with, I can traverse an uncurry of go of mapping something void type to the struct type params. So I have the type parameters of my struct. Since I have found a void type, but I still need to generate, I still need to generate mappings correctly. I create a fake list of pairs, which is for each type on the left hand side. I associate void type on the right hand side. I uncurry go and traverse that, and I concat. Okay, there we go. Expected typed node concrete functor, actual parameters type. So something is wrong somewhere. In the first argument of go, okay? So this is an expected, so that's the parameterized type. And so when I do a case of it, I get a left identifier. So yeah, it's correct. So something is wrong in there somewhere. Let's see the other errors. There's something here that seems to expect Oh, of course, it's because of the go on here. That's wrong. That's wrong. That can work. It would the types would need to be the same. They are not. So that is going to be zip with go, and this is gonna be on the struct type params of the struct type 1 and on the struct type params of struct type 2. Because those are not the same type, therefore the on doesn't work. Okay? Um, in the case of a struct type, this is a struct. Oh, it's struct base name. And there we go. Probably have that wrong some other places as well. Okay. Abort is a abort is fatal, so it should be but it's used first in the context where it is expected to be. Okay. So instead of doing this, I'm gonna do fatal error message. Where's the abort else? It is here. Fatal error message. Fatal error message. And instead of this being abort, it will be error message and will not contain the fatal there. Therefore, I keep fatal remains generic rather than being monomorphized. Expected partial type, interesting. Force reify type, where are you? That is pretty clearly taking a parameterized type and returning something else. Um, oh, error incompatible type. Huh, interesting. Error incompatible type is taking a partial type there. I think that's not really. Oh, I could do that. I could do that. I could replace. That would be better, actually. To partial type instead of this force reify type, which is going to be a to partial type. But instead here it's going to return a partial type. I don't like to partial type. Remove parameters. Remove parameters, or I want to clearly state that we're replacing parameters by unknown. Partial parameters. Yeah, I think remove parameters might be the best name so far. Remove parameters. And here, this is just nothing. I can replace all of those H pure by some just instead. Force reify type no longer exists. This is remove parameters. Likewise here, this is remove parameters. Remove parameters. No, this is very wrong here, obviously. And probably wrong in here as well. In fact, I could probably... Yeah, I can rewrite this as being I am using the lens struct type params, and I am modifying it by applying a function which is fmap refi type mappings. And I can do the same thing here, except you know that is fmap remove parameters. Okay. Two partial type no longer exists. This is remove parameters. So I have again here something in expected somewhere is wrong, and that's because I do the same mistake of using on here. That doesn't work. This is with this thing, and I do it on struct type params of struct1 and struct type params of struct2. Oops, I have a parenthesis that needs to be closed. There we go. Something else is wrong, and I think I have the same problem with abort. I'm going to need to do the same thing. This is becoming error message with this, and I'm going to do replace all of the abort with fail error message. Oops. Okay. I probably want, if I do it on 2 lines, I'm probably going to want to indent this for readability. And I want to do that, invalidate the other one. And the build type parameter map, there we go. So I'm just going to do that here, indent for readability as well. Okay, next, what do we have? Still something wrong with the type here. So this is a partial type on the left-hand side. And indeed, I have nothing or just in all of them. And on the right-hand side, I have a concrete type. Yep, that looks good so far. So it's probably something about this is go here. Do I need go? Does go serve any purpose if... Oh, yes, because I want the error message to be... Yeah. But even then, I think this is still... There's something that prevents it from... Oh, is it because this returns something that I need to ignore? Like, do I need to void this? This might be the issue. Okay, what if I add a type annotation here? This takes a partial type and a concrete type and returns a validate tm of, yeah. Oh, of course. A partial type cannot be a partial type cannot be nothing at the root. That's the thing. That's the problem. So what I need to do is I need this to be just this thing so that then everything else and struct base name. Okay. Error incorrect type parameter count. That's an error in diagnosis. That cannot take a name. That takes a base name. I'm starting to believe. Ah, yeah, that's the thing. There again, a partial type cannot be maybe at the root, which means I will need to change this function to be instead go of just, where go will be the case of this. Oops. Concretize type is go. So that's go. And that's go. And here again, I will want to replace this as. But I need to do it monadic, and the lens here is going to be a bit more complicated. It's fine. Okay. Wait. All of those are in do blocks and return something in pure. This thing, yeah, this thing is not. Oh, because it's using the maybe monad. That makes sense. Okay. So, what's the error there? Oops. Here, this function type info is missing some information. Okay. That's easy to fix. Validated the function type info requires 3 fields. Okay, it requires different parameters. Oh, this is a traverse 2. Okay, so what is wrong here? Oh, this is not... This doesn't need to be... Go gives me a maybe concrete type. And if, so I need to make that a concrete type, so I do, yeah, that makes sense to me. Let's write it explicitly, see what happens. Concretize function arg takes as an argument a validated function arg type of a partial functor and returns a validated function archetype of a concrete functor. In fact, it returns maybe of that. Hopefully the type annotation will help me pinpoint what's wrong here. Parse error is what is wrong for now. Because I have two arrows, yes. That's not going to work very well. Okay, so maybe this is more of a problem of expected maybe of a type node. That's correct. Well, no, actually, no. So I'm doing something weird with the maybes. I'm getting confused with the layers of maybes. So I have a function type info that contains... Oh, yes, of course. The fun return no longer is wrapped in a maybe. That's why. Okay. And struct base name is now the correct name here. Mappings doesn't exist. This is mappings. In fact, I can probably remove the... I think this is no longer required then. Yeah. Name, not in scope. It is identifier. This is probably an fmap2, and this is probably a reify type. I don't need this no longer a maybe, and this has the names. So lookup parameter and the type parameter. That must give me something as a type tree of f, which is what I return. So that should be fine. As long I know it's wrong. I know it's wrong. No, it's correct. Base name identifier here is now there. So this is correctly a base name identifier, which means we need to... Let's add a type to this. Let's see what happens. This should be a function to a base name and identifier associates a concrete type? No, a type tree of f, whatever that is. And I need a for all f in here. Aha, is it because the H pure is ambiguous? This expects a type tree of f, which is putting stuff in the functor, I suppose. Do I need to do H pure at f of int type? So it looks like this one being described like this makes the next one confused. And this returns a type tree of f. Okay. So this needs to be a type tree of f. A type tree of f is this, so it is indeed a HKT for some f. And I give it a type node for the same f, and H pure. Yeah. Oh. No, it is HKT of f of the thing. Yeah, so it should be fine. That should be correct. That should be correct. So what's wrong then? What happens if I comment this out? Is it a problem with the other functions? No, it's not. So it's not understanding that this H pure of int type should be a type tree of f. That is something that it is very confused by, okay? What happens if I H pure takes the applicative first? The applicative here first is whatever this f is. So that should be all of it. But now, what's the error? Because I've tried this, I think. Oh, God, that's annoying. Do I have to do that? That feels ugly. That works, I suppose. But I think I don't want to do that. It's way too ugly. So instead, I suppose it's ambiguous, yeah. Can I do a function raise that given some type node of f makes them into a type tree of f, and that is purely an H pure, and raise is basically H pure given the for all f. This is clearly this one, and that means with a bit of luck that if I do raise of int type, then it has this int type has to be a type node of f, so f becomes disambiguated, and the raise, so hopefully this one will work. It does. So now I just do this one raise thing, and it avoids having type annotations everywhere. There we go. Well, here it has to be, but I suppose here I can do the at f explicitly. Okay. I suppose then reify type has to be explicit with the type of f again. And that's going to be the same thing here. That's the problem of the functor being hard to determine just purely from the type. So I have to put a bunch of annotations everywhere so that the thing can figure it out. Don't understand. Let's see. Um, wait. So that is. Oh, yes, on nothing is something that puts in a monad, which we don't have here. So that's not what I should be doing. I need to do a from maybe. I'm going to do a flip from maybe of this. And what I'm going to do in this case is the report ice. There we go. Okay. So now that works. That's good. I'm going to leave some of the type annotations. I tend to remove them on the local functions if they are too verbose, but here they really help with understanding what's happening. So here, what's wrong? Remove parameters. Ah, from a parameterized type gives me a partial type. The problem is that's the error I have had before. Okay, so this needs to give me a maybe partial type. That's what it needs to give me. There's no other choice. That means that in the diagnosis where I have a partial type, I need to do a maybe here. Which is going to break a few other things, but that's fine. Okay. Error incompatible type, that is a partial type. Just. Aha, so this becomes. So this remove parameter t gives me a maybe partial type, so I need to make it an f map into the thing then now. Okay. That's an f map 2, and that's just a remove parameters. We keep having the same issues. Oh, this is a traverse too, I think. No, it's not. Okay, so the arguments are a list of identifier and wait, why are oh, because it's the function, it's not a struct. So for each of them, I will, if I do a traverse 2, then I get. No, I think this one is an f map 2. In the list of tuple name type, I want to transform all of them into the maybe partial type. So no, I think this was correct as an f map 2. What was wrong about it? I see. I see, I see. No, indeed, this remains a dollar. This is not an F map. Okay. Arising from a do statement. Oh, this is because this is a for all M. I need to be clear that this M is the same as this one. I think is the same, gonna be the same thing here. For all M. Which I could solve by removing the type annotations on Go, but since it has helped with resolving some of the ambiguities, I'm gonna leave the verbose things here. Could not deduce f functor type node. Okay. We're getting into the weeds now. How do I make something an f functor? So I'll need to use the f functor on type node. That makes sense. So I go back to validated and I have to make an instance f functor of type node where ffmap okay, given some function f is gonna be a case of, I wonder how much of the stuff I've done can be rewritten as a, oh, probably a lot of those functions can be rewritten as like ffmap or traverse or something like this. Maybe it's gonna be worth having a look. Like, maybe not. It's gonna be probably easier to keep it that way. Wait, from a use of abstract. Yeah, I need that. So if I find an int type, the result is an int type, nothing has changed. If I find a boolean type, the result is a boolean type, nothing has changed. Character type, unit type, void type. This remains an enum type. There's no types in there. Those are the two complicated recursive cases. Those are the two complicated recursive cases. And it's going to be info, and I'm going to apply a lens on the thing. The only thing that needs to change is the struct type params. I'm going to traverse them, and on each of them, I'm going to modify them by applying f. Because that's what... Yep, that's where it is. And for the function type info, it's going to be info and. What do we do for the type info? It's going to be the function archetypes again. But not just that. Okay, so here in this case, I'm not going to use a lens. We have a function type info. And what we do is we recreate a function type info with the fun params first, unchanged. Then here's where it's going to be complicated, and then here's what's going to be easy, because the return is just going to be f of the fun return, and no, it's not going to be f. It's going to be, I think, this f recur, ff apply. It's ff apply, yeah. ff apply f, and this is ff apply f. And here, this is gonna be an f map of ff apply f of the fun args. Okay, let's see if this works. Gonna be very broken, I think. Yep. Okay. The lens isn't in scope yet. The lens isn't in scope yet. No. Okay. So I'm gonna rewrite this as being instead struct type params of the info field are. I can't do that. Okay. So this is a struct type info, and I'm creating a struct type info where the struct base name is unchanged, and the other argument is an f map of ff apply of f is quite the mouthful on the struct type parameters. Okay. Let's see. Oh yeah, of course, this is a struct type of that. In the same way that this is a function type of that. Okay. So what's wrong here? The type variable a1 is ambiguous. So this does an HKTFA into an HKTGA, which is what we're trying to do. And those are the type trees. The type tree is the HKT. Okay, so that's the one. And this is where I want to do instead. Yeah, I want ff recur here instead. Okay. Getting closer, I think. have the ff function fg, that's what I have, and I have an hktf of a t of f, and I want an hktg of a t of g. That is correct. So it is ff Rika. And I just need, I think, to tell it what t is. And t in this case happens to be a type node. Okay. Aha, that's the function args. Of course, that's the function args. How do I do that? Then I probably just need to do a... I don't want to introduce a where clause in an f map, but that's fine. So it's gonna be ff map args, which is gonna be a case of by reference of t is gonna be an ff apply of f on t. Put back in a by reference. By value is going to be the same thing. Okay, and maybe here the type annotations can be removed. Of course, this is f map and args. No, this requires the same. At type node, I think. Oh wait, it's an ff Rika. I'm an idiot. I wonder if this can be done without the type annotations. Okay, so this compiled. What happens if I remove the annotation here? No, it gets confused. Okay, so we need to keep them. That's fine. I wonder if I can use this for... I wonder if there are places in my type conversions like this where I can use this. Because this is basically the same thing. I'm converting... Like, it is purely a thing of how do I convert... This could be an FF map. How do I convert a... Yeah, I think I can rewrite this as an FF map now. Let's make it compile, but I'm gonna put a to-do of... Oh, an FF Rika, actually. Yeah, this is an FF Rika. But I can probably do it for this one. For this one, even more so, I think. Because I'm converting, yeah. That's definitely something I can do. So I can probably avoid having those complicated case switches and everything. I can probably just reuse them. Arising from a use of show. That identifier is a base name identifier. That's weird that it's not actually working. Oh, is it the mappings? Oh, yes, of course, the mappings. So here I will need to know that show of type tree of f so that I can do a show on this. Yeah, that makes sense. Okay. Wait, what? Type name, base name. Defined but not used. I think all of those I can just do a catch-all. None of those are types, therefore I can just catch them all. Base name, base name. And use matches, that's the same thing. All of those are error, not a type. I am just gonna match all of them rather than being explicit. It's very unlikely for a role to change. And if it does, I'll just have to go over the places where it's used anyway. Yeah, I guess the upside of keeping the complete list would be that I would have, if I were to change role, I would see immediately where something has changed. But case name of. That's for a built-in type. Anything else would not work, I suppose. So anything else. If I encounter any name that is not one of the basic names. Int, character, boolean, unit, void, and placeholder. Oh, actually. Oh, that doesn't work. Ooh, interesting. No, I suppose validate built-in type. Placeholder is not a built-in type in the same way. So anything else is an internal compiler error, I suppose. Because I got a built-in name, a built-in type with a name that's not one of the ones I know. Nope. Okay. Next, what do we have? Remove parameters. Yes, I don't need to name the thing. And this is a new file. Yay! Okay. So now we are back to doing diagnosis. Let's see what we have in this one. Report doesn't exist. That's... Oh, I'm back in expert. Okay. Report into fatal. Oops. And I'm gonna check that all of the fatal ice are now probably changed back to report ice. Okay. What do we have here? Validate a const cast expression. Yes, that's what I'm doing right there. Unvalidated exp. Oh, is it where something where I've changed? Let's see. Have I changed validate const cast expression? It takes a typed const expression and a concrete type. So indeed, okay, so that looks good to me. Oh, ensure is going to be wrong. It's just going to be that. I get the maybe and I return a value. So it's not an F map. Expected type to const expression and concrete type. Yes, that's correct. Oh, yes, of course. It gives me a maybe value in the monad. Therefore, wait, what am I doing here? Yeah, this is wrong. This is wrong. Because I have maybe value. So I'm lifting this so I get a maybe. Yeah, I think this doesn't work that way. I should probably do it instead the way I've done everything else, which is attempted here, do the validated here, then do the validated exp as valid, like ensure of the attempted stuff. And then here I just do a validate. Yeah, there we go. That's gonna be easier. Yeah, and now that works. Oh, interesting. This contains the location information. So that means the const field access expression here takes a with location. So first I should be setting the current location. Const field access expression, where are you? Const field access expression, there you are. Oh wait, no, I don't need to do that. Because the validate const expression will do it for me, I think. Because the validate const expression takes a with location. Okay. I should probably stop at this point. Actual, so this gives me a maybe. Interesting. So validate binary expression with, which is used in all of those, is defined. Oh, it's the same thing. Okay. It's the same thing where I'm gonna have to do. I suppose I could do. If I do an ensure I get something in my monad. Therefore, now I can do a lift A2 of F in the monad, which means I get and I guess that's just to join then. Okay, validate function path expression. Ah, yes. It's not abbreviated. So this is expression. Validate bool negation. Oh, they're the const version, and I haven't done the function version of those. Function version of which is going to be basically the same thing, except this is validate function expression, I suppose. Well, no, I'm not going to be expecting a const boolean. That's not true. So I get the value there. I expect it to be... I expect type boolean type of the value, I guess. How does expect type work again? Expect type, it takes a concrete type, so I need to do the type info of the value. And I suppose I can do a case of the type to value of the value of if it's a Boolean literal expression B, this function can return pure of a typed Boolean type Boolean literal expression not B, and otherwise in any other case it just returns a typed Boolean type of a bool negation expression of the validated expression. So this is always pure typed Boolean type of, depending on the value, if I can replace it by directly the inline version, I do that. Like if I know the value is compile time, I can just replace it. If I don't, then it's just a Boolean negation expression. There we go. I'm gonna do this and Boolean into int negation, yada yada. If it's an int literal expression, then it's just minus I. Otherwise, it is, yeah, there we go. Okay. This could be either, so this is validated. Likewise here, this is the validated version. And I suppose this is the validated version here as well, and the validated version here as well. I suppose validate binary expression with is still broken. Oh no, validate addition function expression is just not in scope. Okay. Validate addition. Const expression, yeah, okay. Wait, what do I do for functions? Let's validate binary int function. Does it exist? Or did I just completely assume that it existed but did not actually do it? I might have done that. Okay, that explains a few things. Okay, so validate addition in the context of a function expression that's missing. Oh, I need to depend on type for this. I thought I did, but I did not. No, I do already. Huh, interesting. Expect type is right there. This might be a typo somewhere. Validate addition function expression. That's the one here. Validated expression, validated expression, validated expression. So now I need to check. I look at the type of the left-hand side. If it's int, yeah, because I will support at some point concatenation of things here. I'm expecting the type of int type from the type info of the right hand side. Like if the left hand side is an int, the right hand side must be an int. Expect const int. Okay, the expect is a very strong one. So I'm going to use that. So I'm going to do the same thing here, where let's do a case type value, typed value of the left hand side and typed value of the right hand side of we get a validated int literal expression I1 and a validated int literal expression I2, in which case we can, unless I do all of my constant inlining as part of the simplification phase, and I don't bother here, it's purely type checking. Maybe that's a lot easier. Maybe I can remove all of this complicated stuff and just move it all. Because for a constant, I already have to check anyway. Maybe I could think about doing that in the simplification phase, doing all of the constant unfolding at that point. Nah, it's better if I do it here, at least for constants, because that way I will not have to inline a bunch of complicated things and then simplify them. I think, no, I'm going to keep doing this. So here, if I have two known integers at compile time, then I can return. So it's going to be, as usual, pure of a typed int type of case of what this thing is, of if they are both integer values, I can return I1 plus I2. If I have literally any other shape, I cannot decide what this is at this juncture. It might be dynamic. So this will be a validated addition expression using the left-hand side and the right-hand side. Okay. Next, expect type not in scope. Huh. So validate assignment expression is something that will take a concrete type and return a validate t of m, and expect type. Oh, it's in expect and in types. Okay. Is exactly that, but this is in expect, not in types. So I need to add expect to my list of things I'm importing here. Hopefully this doesn't cause a loop. It doesn't. Great. So it's going to be validate function cast expression. That's the same ensure lift a2 nonsense that doesn't work. So this is going to be instead, if I want to keep this logic, join of lift a2 of ensure and end ensure. Validate function field access expression gives me a const expression. That's wrong. Validate function field access expression should be giving me a validated expression there. And this is going to be a validated field access expression here. Okay. Oh, except it's exp when it's the constructor. Validate function field access expression, where I just was, takes indeed a with location. Boolean negation function expression gives me a validated expression. That's a mistake on my part. Same thing for the int version here. Doesn't give me a const expression. Validate addition function expression, that's done. So I probably gonna have a validate binary expression with problem. So validate binary expression with. It is again one of those ensure that's wrong. So I'm gonna do a ensure here and a join at the result here. That's something that works. Next, this is expected to be something that given two typed value expressions gives me a typed aha. So this is missing the type. Oh, but the type for an assignment expression will always be unit. So I know that. I can go to assignment expression. And indeed, here I create the constructor, and this is going to be a typed unit type because all assignments are unit. Okay? except I need to also fix the validate assignment expression signature. Here, this doesn't give me a typed, that gives me a validated expression. There we go. So here I'm giving E1, E2 to validate the assignment expression, and those things, validate assignment expression again, are not resolved expression, they are with location, which is fine. Validate binary int function is something that doesn't exist. So I'm gonna have to take inspiration from the existing one. So validate binary int const expression. And there we go. That's the const version. We are gonna do the function version. So here I do something a bit different. Here, since it's an int, I can do an expect type int type of the type info of the left hand side. I can do the same thing for the right hand side. Then I can do a case of the type value of the left hand side, typed value, and the typed value of the right hand side. And if I get a validated int literal expression I1 and an validated int literal expression I2, I can compute the value at this point by using the provided function, which is f, so f I1 I2. Oops. And that gives me an int that I then need to transform by applying. So this is going to be typed in int type of whatever this ends up being. And in this case, this is an int literal expression, the validated kind of this int. And if I get literally anything else, then I cannot compute the value at compile time. This is literally a validated addition expression that takes the left hand side and the right hand side, and that's not in the monad, and it needs to be, and that's pure. There we go. Validate binary Boolean function expression. Let's copy this. Oh, in here I need to replace function, and this is a validated expression, and this is a validated expression. Copy this, actually. I'm gonna make it up. Int into Boolean. Here I don't need to put this in the monad. The Boolean operations do not fail. That's the same thing here, but however, this is going to be a pure typed thing here of the case. And in this case, it's going to be a Boolean literal expression of f of I1, I2. Otherwise, it's going to be a validated. Oh, I don't know. Oh, I suppose I'm going to need. Yeah, I'm making the same mistake here. I'm going to need the constructor. I'm going to need to know what the constructor is. I'm going to need to know what the constructor is, and the constructor is going to be for a typed validated expression. And a typed validated expression give me a validated expression. That's the constructor. That I'm going to call very imaginatively C. And in this case, this is C of this. And in this case, it is C of the left-hand side and the right-hand side. So now I can go back to validate binary bool function expression, because here I need to specify what the constructor is. For this, the constructor will be a validated of a bool and expression. Isn't that correct? Validated. Yeah, there we go. This one will be a validated bool or expression, and those will be a validated what's it called, subtraction expression. That's a validated multiplication expression. That's a validated exponentiation expression. That's a validated division expression. That's a validated modulo expression. And that's about it. And I think the last thing is going to be the validate binary compare function expression. And I don't know. No, there are things we need to do here still. Validate binary compare. Oh, that's a big one. It's going to be very different in this case, because in the case of function expression, I will probably... No, I can try to do it, but for only... That's a good question. Honestly, the fact that I've worked on several compilers before for fun, and I wanted to make a proper one. I've used for several advent of code a very like extreme, like 3 files big compiler from a pseudo language into brainfuck. That has been very fun, and honestly, my knowledge of compilers is not book learned. It's purely I've worked on projects like compilers for a while, and I just wanted to make a bigger one, and it's been a lot of fun. Binary compare function expressions. Here, I can keep... Having worked on compiler-like projects, I already had a good enough idea of the structure. I did a bit of research before launching the project to make sure I was doing things proper, since I want this to be as clean as possible. But yeah, I still haven't read the Dragon book. I need to read it at some point. Here I can just use that because I will not be doing struct comparison at compile time, because that's a nightmare. So I don't need a default case. I just need the constructor again. It's typed const typed validated expression. Into a typed validated expression into a validated expression. The thing is, I'm still taking a lot of shortcuts in this project, even though there are some actual, like I'm using some real inspired by real languages and inspired by real compilers. There's a bunch of places where like, okay, no, I can make it a bit easier. I need to read the Dragon book at some point. Like I feel like I must. So here, what are we gonna do? We are gonna check that the left hand side. Oh, the type of the left hand side, which is what we expect, matches the type of the right hand side. So we can't compare things that are not the same type, but they are not expected to be any of like special type. Then, then what we need to do is see if we can find a value at compile time. So this is going to be, again, I'm just going to copy it from the other one. Copy it from this. But there's going to be more cases here. If I find two Boolean literal expressions, then oh, in fact, this is always going to be, well, it's not always going to be. This is going to be, yes, I'm going to apply this function that compares the two of them and gives me a Boolean. So it's going to be that. And I just need to also apply this to int and character, as in the basic types that I have. So if I find a literal, then I can compare it using the provided function at compile time, which reduces, I do constant inlining that way. If I can't do it, then I just construct. Yeah, with the proper constructor. Okay, that should be fine. For the sake of being proper, then let's name those booleans with a b. Okay, so now that's the validated binary compare const expression. That's the binary compare function expression. So I can go back to validate binary compare function expression, and this requires also giving the constructor. And the constructor will be, in this case, and I don't remember, I'm just gonna do this and put it here. This is an equality expression. This is, oops, a validated difference. It's been here for this for way too long, but I would really like to see if I can get to a point where all of this gigantic refactor compiles. That would be very nice. Greater expression, validated lesser expression, validated greater equal expression, and validated lesser or equal expression. Okay. Let's make sure that this validated lesser validate lesser, I can't type. Where is it used? It's used there with E1, E2. I think that's correct. Okay, what's next? Oh, I was already on the line that's broken. Perfect. That's a binary expression with Oh, I have somewhere by mistake still something that says const expression. And that's probably in the thing I was just doing in the compare stuff. Oops. I need to be careful. Yes, indeed, I have here. This takes some validated expressions, not const expressions. Okay. Found whole path name. This has changed to path body, I think, or base. I never remember what I've chosen. Common base. Retrieve constant is not in scope. Is it because I have forgotten to bring context into scope here? Validate param counts require the base name, which I think this is, and I'm going to rename it base name to be more explicit about the fact that this is not a name but a base name. Here, this takes the base name as an argument. I should have got some snack. Huh. Why does a let variable... Oh, because it may have a type here, which I will need to take into account. So when I validate a let binding in a function, which is, where is it? Var path, there we go. Provided type. If there is a type that was provided, there might not be potential type. If there is a potential type, I will want to, given that provided type, I will want to assert type. Actually, it's not completely true. It's going to be a bit more complicated than that. First, I need to validated partial type is going to be validate partial type of the provided type, because it can contain placeholders. Like, it's valid to do something like let x, which is vec of underscore equals foo, or something like this. So this type must be interpreted as a partial type that may contain holes, basically. So we validate the partial type, and then it's not assert type. We need to check that the shape matches, and that's a different function that is validate type pattern. So here I need to validate the type pattern. Oh, wait. I'm doing something wrong. I'm confusing a let binding with... I'm doing something completely wrong here. Okay. So what am I doing wrong? I am looking at role, which is in resolved. Okay, no, that's correct. That's the maybe path info. So that's maybe the type that was provided. Yeah, okay, I can ignore this. When the value was introduced, I have put it in the scope. I don't need the var type here. Ignore what I've just done. I don't need to do any check here. This is purely, oh, I am making a reference to a local variable. I don't get the type from this. I get the type from this. To the point that I wonder if I could remove... I could perhaps remove the maybe path info from this. It's probably not required. Let's do that. Let's remove it here. Let's remove it here. And that means that when I'm resolving in resolution here, when I find a let variable, it's gonna give me an error quickly anyway. Okay. Path name doesn't exist. This is path base. That change on its own is already enough to just make everything. This is the base name, I think. Yep. Which needs to be included in this function as well. Okay. I have a const expression and I need to type const expression, or the other way around. I need a typed and I have only a const expression in the third argument of validate const expression. This int result that I give to validate cast expression. Okay, something that must give a typed thing, and indeed it doesn't. Although I suppose it's easier to do it once here. So this is going to be a typed int type. This is going to be typed with a character type. This is going to be typed with a Boolean type of this. And here, this is going to be a pure typed with an enum type with the name and the values of this thing, because enums are represented by int literals under the hood. That's the const version. The function version will be basically the same. But in this case, I do validated int literal expression into typed int type. Same thing for character. Same thing for Boolean. And for an enum. That's going to be the same thing here. That's typed with an enum type where we have the name and the values. Okay. Next, validate function path expression. And this requires to do something that is typed, and instead I have something that's not typed. So if I retrieve the constant, okay, so from const expression. Aha, yes, of course. Because I suppose retrieve constant gives me a typed const expression. Okay. So here I can't do the from const expression in this. I need to fmap to do it within the typed thing of this result. There we go. Next, validate var path. That's probably going to be a somewhat similar problem. It doesn't take the potential type. That was a mistake on my part. couldn't match. Type node concrete functor with identifier. Interesting. So I have a function path. That means I have found a value in an expression that points to a function. That means the only valid use for this in the current state of the language is basically creating a function pointer. That means that the parameters to the function must all be concrete types, because since I'm not in the case of a function call, I cannot determine the types of the type parameters of the function purely based on the arguments. I need to provide them all here. So all of those must be valid concrete types. This pretends that validate concrete type will give me an identifier. That feels wrong. Let's have a look at validate concrete type. It's not going to be in this thing, it's going to be in types probably. Yeah, that gives me validate concrete types, give me a, unless I have another one somewhere and I've made the mistake of naming the same function, validate concrete type. No, I haven't made this mistake. Okay. So I have the function type info. I have the path parameters, which must be types. The path parameters. Wait. It does take a path info, and I have a type parameter, which means I have. Come on. A bunch of path info the same. So validate concrete type on all of them should work. And then I try nested that. Oh, is it a problem with try? No, try nested is not defined here, so it should be fine. Okay, so what's the problem? Oh, here I am missing the base name. And since, as a result, the arguments were shifted, it was trying to interpret this as the wrong thing, and I think that's what was missing everything. Okay. This is a problem of, again, the function archetypes. God, those are annoying. The validated arguments are not just reify type on the thing. I'm gonna need to reify argument is gonna be a case of if it's by reference T, then I will reify by reference of reify type param mapping of T, and the same thing by value. Which means here, I could actually inline this, it doesn't matter anymore. This is actually reify arg. And I probably want, instead of doing this, unless, do I use the validated arguments for? Do I not use them for anything? Wait, why do I do this? Oh yeah, of course, I use it for the validated thing. So this is not correct. This is an fmap 2 of this on the fun args. Those are validated. Those are validated. Okay, next, what do we have? Ah, yes, here again, the mapping is made without the base type, the base name, which I need. So this will be made by zipping this first, which is base name here. So I have changed the way parameters are identified. Although, again, I don't think it's required. It's going to make the code a lot easier to read and to debug if there are errors. Why is this ambiguous? I suppose here it doesn't know. Okay, so I might need to... Let's introduce a function like this that will take the mapping, and I'm going to type it so it's clear this is a function that takes a hash map from base name and identifier and associates that a... What case am I in here? Function path expression, that's a concrete type. And it takes a validated function arg of... What will it be in this case? This will be a parameterized functor, I think, and will return a validated function arg of the concrete functor, so made into a concrete type. Now I can use this for verify arg with the param mapping. Okay. What are you unhappy about? Function arg type. Okay. Param mapping is called mapping now in this context. Still unhappy with this? Do I really need to add... Do I really need to add a... Like this is the concrete functor? That's annoying. Okay, but that seems to be working at least. Maybe what I need to do instead is introduce verify concrete type here, just as an alias, which will do this basically, but not take a function archetype, just take a parameterized type, return a concrete type. And this will be refi type at concrete functor. And here I can use reify concrete type without having to give the thing. And here, reify type, I can say concrete type, and there we go. Let me just check that quickly. Oh, it's just this is reify concrete type is this. There we go. In the sixth argument of validate cast expression, I think this is something where I use name in the wrong way. Because, yeah, no, none of those are name. That is completely wrong. Non-identify a name? What am I talking about there? It's completely wrong. That is completely wrong. That is completely wrong because what an enum info has is an enum name and an enum. Right, is that an enum info I'm actually doing? No, an enum type, a validated enum type. Is base name and list of identifier. Yeah. So this is base name and list of identifier. Very wrong here. And that means, indeed, I'm giving the enum stuff that's correct there. In the case of a constant name values, that is indeed enum type name values. What is result with? Yeah, okay. Okay, next, what do we have? Enum info with base name, okay. I don't think that's correct. Because again, the type here requires the base name, so enum type takes the base name. So enum type here, that's the base name. So this function takes the base name and the list of identifiers, and I'm giving it as a sixth argument to this thing, which requires indeed base name and identifier. Oh, I have name here, which is wrong. This is enum name. This is enum name. That's why. There we go. Ah, oh, come on. Where does this enum info come from? Why do I have that? Because in... Wait, no, the actual is not... Oh. No, it's just indeed a name. Oh, that's because air inum out of bounds is probably still taking a name. I was taking the full inum info, interestingly, that I don't have, but that I can recreate pretty easily because that is the enum info name values basically. Wait, no, I don't have the name. No, instead I'm gonna need to just give the base name here and change that to be the base name. There we go. Next, what do we have? Oh, import unused. Ooh, starting to get a lot of things are starting to compile. This is still called v, not int value. Needs to be typed, which I forgot to do here. This needs to be typed as well, and this is typed with the validated with the target type. Okay, next. Oh god, it's super late. Those are not resolved, they are validated as well. That's an int literal expression, not const expression. That's the validated one. Inner value, I don't think it's... no, it is okay. Oh, inner value is already... yeah, of course. I've made all of those things give me typed expression. I don't need to wrap that into a typed expression. Therefore, it is just that. This line can go away. Although I suppose I could have... actually, yeah. It's a lot easier to actually make all of those things give me not a typed thing, because the type is obvious from context. If it is valid, it is the type of the cast. So I don't need those things to give me typed expressions, which means here I can remove the typed target type, I can remove the typed in type, I can remove that. All the things I've been painstakingly adding, I don't need to actually add them. They're not actually useful. That's going to be the same thing here. I don't need to type that here because I will have the type anyway. So I can just remove all of that. That should be fine. Okay, let's go. Base name identifier, that's the usual thing, where here I'm going to need to zip here with a map base name first, given the way that the type parameters work. There's no base name in scope? Huh. Oh, struct base name is in scope. That's struct base name. And that's probably an fmap2 there. Oh, wait. So the struct values in this case struct values are a non-empty tuple of the type tree, okay? So if I want to reify that, that is indeed an fmap2 is the within the non-empty list within the tuple. So that should be correct. But the mapping might be wrong. Because I'm expecting it to be a type tree and it is a typed node. Why is that a typed node? Because those are partial types. Okay. Those are partial types. No, that's not true. They should be concrete types. Because I have validated this recursively, so I get a typed thing. So the type info there. Wait, is this the case where... Oh no, yeah, okay, I'm trying to do anything too fancy. So I look at the left-hand side of a field access expression. I see that indeed it is a struct. The type is a struct type info. I retrieve information about the struct from the types that we have already handled. Okay, no, I think that's correct. And the struct type params are indeed, yeah, the concrete ones. So that's... maybe it just means I need to do a add concrete functor there again, so that the thing gets not confused too much. Oh, this expected typed. And why is it not the case? So the struct values. Okay. Why does the expected thing is to be typed? Something is wrong here. So I know. Okay, I know that the thing on the left-hand side is a struct. I know what the type of that struct looks like. I can reify the type of the fields because I know what type arguments the struct was given. Yeah, that feels about right. Oh, I suppose, yes. What's wrong here is that this needs to be typed. And this needs to be typed with the type of the field, which is field type. And the field access expression seems to be given a lot of arguments I might not need. Field access expression, where are you? Field access expression. What's this typed expression there? Oh, it's the left-hand side, of course, yeah. No, of course. But that's not what I'm giving here. That's completely wrong. That's the left-hand side. That's the validated expression there. Okay, that makes a bit more sense. The things were a bit confused here. Expected role, actual, concrete type. Aha. Where have I used not a struct before? So far, I only use it for type info, type info, type info. So this seems to be perfectly fine to change not a struct from role to type. Which is, of course, by which I mean concrete type. Now we recompile half the world. This requires a base name. Do I have a base name in scope? I will have the function base name in scope. I don't remember how it's called, but I do have it. That's the function reference kind of thing. Okay. Wait, that doesn't work. That doesn't work. Unless the function type info contains the base name, which I don't think it does, it doesn't. I might not have a base name for this, because it could be just a variable name. So maybe instead I should do this here. Where here, if I find a real function, then I need to get because yeah, how can I get a base name in the case where I am pointing to a let variable? I cannot. That is a problem. Can I make a fake base name? I don't know the module name. I have removed it from my context. How can I point to something that's not... How can I point to something that's just an identifier in the scope and be like, actually, maybe that means... No, I need a base name. Okay. So that means I need to return something that is a base name that I can use for this purpose, basically, which will be returned from this function name. And for validate callable object, is it the second thing I've used? Yes, the second. If it is a actual function name, like I can get the function type info by doing oh, I have the function name. That's what it is. That's the function name. And if I have a let variable, I don't have a name, but I can use, I can get the current base name, the one of the current thing I'm doing, and append and modify it to add the variable name. It's kind of weird. It's kind of weird, but that's purely for debug reasons. Maybe that's fine to do. Okay, so here I have a function. I'm gonna need to create a fake name. This is gonna be obtained by getting the declaration name from the scope, which here invalidated is the current name or something like this. Current name. So use current name. And the base name is a module name plus an identifier. And I'm gonna modify name an identifier. What is identifier? Is it just some text? Yeah, this is ugly. That's not something that should exist. At fake name equal base name with the name module of the declaration name and the name identifier of the declaration name, to which I will append using the fact that identifier is a string. What if I make it a monoid as well? A semi-group and monoid. And I can therefore do that plus dot plus the identifier. That is horrible. Now I have effect name, so this function returns a name. So here I obtain a function name that I can give finally here as the argument. Okay. Now to recompile the entire world. Ooh. That's the furthest we've been in a while, I think. Okay, let's see. This requires a function name as well. In fact, that was the whole point of having the function name, I think. Oh, it's the other way around. This argument comes first. Aha, so for some reason, this validate function call argument function expects this. Okay, so where is validate? Function call argument. There we go. It takes on the left-hand side the arg name and the arg type. Okay. And returns on the right-hand side the arg expression. Oh, yeah, I probably have not reified those types at all. Because those are just the function arguments as they appear in the... and I will need to reify them. Oh no, they are already reified. That's the other way around. Okay. Oh, and here because I do a resolved, that's why. Those are in fact validated. That's why. Wait, then that's wrong. Oh, it's the archetype. No, this is correct. Okay. Next, in build type parameter map. Ah, the usual. So I'm expecting first a parameterized type, then a concrete type. Oh, so it's the return type that's the issue. Oh, because again, this ends up creating a... This ends up creating a thing that contains the base name now, and I think that's something that I just don't expect in this function. Map, it's used for validate param, which is here. And here, when I do a lookup, I need to do a lookup of the parent name and the base name. I don't have the base name in scope. So I'm gonna need to have the base name in scope. Oh, is that the function base name? Oh no. Well, it depends. What have I been reifying those types with? I need to think. I need to think. I need to think. So the function info. Oh god, that's broken. Okay. That's the one that comes from the function base name that I don't have when I have a variable that points to the thing. Wait. No, it's fine because when I have a variable, then it must be a concrete type, so all the types must be known. Therefore, the build type parameter map is not required. So maybe instead of doing all of this nonsense, I change the way the function is built and I use the assumption that the that it has already been checked. Okay, so I need to rewrite this entire function basically. Okay. 43 what? I'm curious. So instead of doing this validate function call, validate callable object here, I'm basically instead gonna do that at the top level and do different things in this function depending on which case I have. Which maybe will allow me to remove the horrible base name thing. Well, no, it won't, but that's fine. Okay, so here is what I do. So here is the three different cases. The let variable one is the most complicated one. Let's do that first. So here I'm gonna, in this case, I need to validate the number of arguments. That hasn't changed. But in this case, that is a trivial. It must be exactly 0. Because this is a variable, therefore it must be a concrete function type. There is no possibility of anything else. The number of arguments, that will be, however, something I can make into a function separately. Validate number of arguments. This will require the function name and do I really need to yeah, it's probably better to do that way. So I will need the expected args, actual args. So here I can remove this and I can put it in the case switch instead. I have a variable, let variable, I can do this. So I validate the parameter count and I introduce some space in the different cases to make it very clear what's happening. So I validate the parameter count. I validate number of arguments, which is oh, I've changed something and I've broken this, I think. Because I need to retrieve the oh no, I have the function type info right there. Okay, that's the function type info. That's okay. Let's go back here. Function type info perfect. And that's what's in the type. Right. It is. Okay, function type info. Okay. So I'm in the context where I have found the thing I'm trying to call as a function as a let variable rather than a function name. I have the full function type info, that's perfect. So I have already checked that there is 0 arguments, type arguments given to me. Then the expected number of actual arguments is this, and that's the function args right there. If it's different, that's going to throw an error as well. Then all of the logic of building a parameter map and everything is not required. I know that the types must be known by now. This is a concrete type. I don't need to do any of this. So I can already immediately do that. Well, I guess I need to validate the arguments though. So validate argument types, I suppose. Do I ever check the types actually? I don't seem to. That's an error. That's a mistake. Okay. Oh, it's starting to be difficult to make progress here because I'm breaking everything. So here I'm calling function call argument thing. I'm calling it on the fun args, which in this case will be a concrete type. And if I find instead a callable object, an actual function, retrieve function type, what will that get me? It's parameterized. Okay, that's the difference. Is in the other case, I need to reify the types. So in this case here, so I guess this validate function call argument kind of thing just validate the values and the types are then checked afterwards when I build the parameter map. So I can do something completely different in the case of... Okay, so I think let's do this where I introduce completely different functions because that's going to be a nightmare otherwise. This is validate function called let expression with the identifier. And there's no longer a thing here. And this is validate function call function name. Extremely verbose, but again, I would rather be verbose. And that's the end of this function here. Which means here I open the do block and I introduce validate function call let expression with the identifier, which is going to be this so far. And I can probably instead do this to remove a layer of a level of nesting, where in this case of the info, we give the info. And otherwise, we report an error, and then we continue at this level of nesting. I validate the parameter count, which must be 0 in the case of an expression. I validate the number of arguments, which is just checking their values, not their types. Maybe I don't do that at all in this case, and I use a different function because I can also check the types immediately. I have concrete types all around. So maybe I do that. Maybe instead of doing this, I do ensure nested of for a zip of the fun args and the function args. I will get a thing which has on the left hand side arg name, arg type, and then on the right hand side I'll have the provided argument. And for each of them, what I can do is a try nested of... I need to resolve validated arg is validate function expression of the provided argument. I must assert type of the arg type of the type info of the validated argument. Check that the type matches. And if yes, what do I want to return here? Do I need to... Oh, this is going to be more complicated than that, of course. Of course it's going to be more complicated than that. This is why I have this function right here. Where is it? Here. So I'm going to do that, I suppose. So in this case, I have the actual type. I can do this and then the assert type. Well, no, I don't have to do that. I can return. So this is going to be the actual type validated arg will be a case of that, where here I will return actual type at the beginning, appended before the validated argument. And in the case where it's by reference, in this case, I will have the actual type there again. And the big like appended here, and otherwise I have this. Perfect. So here now I have the actual type, the validated argument. I can do the assert type. And for the thing I want to create a function call, a variable call expression, which is just a list of type, a list of typed expression. So that means I need to return the validated argument, which is a typed expression. That gives me the validated args plural. I'm gonna nest that one more. Okay. Okay. And now that I have this, I should be able to go back to what I had here. The parameters map, all of this, none of this is required. And this is what I can return. Pure typed validated return type. Oh, I haven't validated the return type of a variable call expression with the identifier and the validated args. And I need to validate the return type. That's something I haven't done yet. Indeed, it's already there. Perfect. And the last thing I need to do is to validate the return type. Oh, but return type I already know because it is part of the function type info. Function type info. It is just the fun return since it's already concrete. So it's just that. I don't need to do anything else. Okay, that's the case of the function called let expression. And now we have the much more interesting and complicated case of validate function call function name. Which is going to be this completely different helper function, which is where we're going to do everything we were doing before, except, you know, this is probably going to go away as well. I don't remember what I was doing, but I think for this one, I will need to simply get the function type info. So I will need to retrieve the function type info, which is gonna be obtained. I have changed. Actually, I could probably do a git diff and jump to validate function call expression, unless we did it this evening. I don't remember. We did it this evening. Okay. Oh wait, no, maybe not. Okay, that's what I was looking for. That's just retrieve function type from the function name. Okay. So we retrieve the function type from the function name. Okay. From there, we can do everything we were doing before. I'm gonna add here for readability the same kind of we're validating the number of params. We're validating the arguments. We're returning the value. Here we're gonna do basically everything we were doing before. That's the main function. And at the end here, this is where we have to do all of this stuff. Register function for instantiation. And at the end, we will return the actual everything. Perfect. Now, what has changed here? So here we do the partial params, we do all the things we were doing before. I think the one thing that has changed is the build type parameter map here. It's the validate function call argument. I'm gonna see if I want to keep. Yeah, I can keep this one, I suppose. It's fine. It's fine. It's a bit of a duplication of the one I had before, but that's okay with me. Okay. And now, instead of trying to have a common core between the case of a let and the case of a function call, I'm deduplicating the stuff between the two of them. And now we've written this function. There's going to be a bunch of broken stuff. That's fine. Function and its scope, it needs to be a role that's the path base. Or I suppose I could just do also just role. And now that we've delegated everything to functions, this can just be that. Identifier. Not in scope. Because there's a typo here. There we go. Validate function expression. Of the provided argument. I guess I can reuse arg expression here. There we go. Here, yeah, the actual type is this thing. Assert type not in scope? Huh. Do I not have a dependency on I have a dependency on both types and expect? So what the hell? Types. Oh, is it expect type, not assert type? It might be expect type. And that would be an expect, then I suppose. Expect type, yeah. Not assert. Here, the function base name is something I have everywhere. That's the function name. I don't need to use another alias. Likewise. The function type info is this one. Well, except no. I don't want to use the same function type info. I want to create a new one. I want to create a new one, I think, because the one I need needs to be... It needs to be concrete. Yeah, it needs to be concrete, so it doesn't work. So I need to create a new function type info. Where here, since I know that now it is concrete, I know that the fun params are gonna be an empty list. The fun arguments are gonna be... I probably don't have them. Or do I have them as the validated function args? I think it might be that, yeah. That would be the fun args would be the validated function arguments. Function args. And the fun return would be the validated return type. I'm not sure this is going to be correct. Oh, yeah, it's called fun return. Function base name doesn't exist in scope, it's function name. Although function base name would be better, but oh well. Oh, are those... In this case, what is the archetype I have on the left-hand side? When I'm doing this, I'm doing the fun args, which is going for a function type info, so it is partial types, okay? And the function args are resolved expression, yeah, okay. Okay. Ah, it doesn't know that this is a resolved one. So it doesn't know that this sub-expression actually contains the location. So I'm gonna need to be explicit here. Validate function call argument takes a tuple of identifier and a validated a parameterized type and a arg expression which is going to be a resolved a with location resolved expression. Is that correct? Yep. And here there are some parentheses we can remove. What do we do with this? We return something in the validate t of m, and this is going to be returning a typed validated expression. And I need to add now a for all to this thing so that the m can be the same. Okay. I'm missing something here. Okay. Something is wrong in the result in the value of this. Instead of returning a typed validated expression, it contains something that's wrong. Okay. So here, this typed here is incorrect. It needs the identifier, the function info. It needs the function info, of course. It needs the function info, but in this case, the function info can be the same because I know it to be already concrete. So that's the function type info that I can just pass unchanged here. Okay. I have something similar here where apparently this function written something that is wrong. When it returns a typed validated return type of a function call expression. Oh, function call expression is an actual name, of course. Yes, that makes sense. And the function call expression here needs the fixed function type info, so I need to actually do that as well. So concrete function type info is going to be this thing. So that's the concrete function type info there, but it's also required here. Wait, no, not here. Here. Okay, let's see. I have this thing again. Where not a function can be something that either with a type or a role. So this would be error not a function type, error not a function role. I'm going to distinguish them. So I go back to diagnosis. And I have not a function role and not a function type. This one meaning I'm expecting a function, I found something that is not a function. And this being the same thing, but after resolving, basically. Okay. This is in the function called the let expression. What's wrong here? This is a case again where this thing doesn't know that this thing is a resolved, is a with location resolved expression. Guess it's rather here that I would need to put that. This arg expression is that. What do you mean? There we go. Okay. Okay, so it's the same thing again, where it's not realizing. So maybe I don't need to put a type annotation here. Maybe I just need to tell it, hey, actually this thing is... Wait, it should know that. Resolved? That shouldn't be required. Why is it confused? For the other one here, I suppose I could keep this and do the arg type here and return the actual type and return the actual type thing here, which would be... So that would be for some arbitrary type tree of f. And that returns that type tree of f as a tuple. Now I can use the same function in both cases. In this case here, I don't need the... I just can do a fmap second of this. And in this one, rather than doing this nonsense, I can do... A zip with M. No, that's the wrong one. Wait. That's the one I want to do, the validate function call arguments. That's basically what I want to do. So here this would be validate function call argument, which requires the arg name and arg type. It's not true, it's not a type tree. This is a validated function arg type. Okay. So here I can do that, and the other thing that I'm giving it is the resolved expression, which is the arg expression. Now I can remove this stuff. Okay. Actual type there. Oh, here, no, I'm going to do the intro nested, so that's fine. Oh, but I probably want to do the map second here. Okay, so why does this expect a list then? Oh, I guess this is an F map 2 then. There we go. Okay, build type parameter map. What is wrong here? Expected a parameterized type on the left, that's correct. Then a concrete type, that's correct. And return. Ah, this expects it to be the hash map. No, it doesn't expect it to be a hash map. That is correct. It should be. That is correct. But it won't. Hmm. Unions with in the prelude does take a foldable, which could be anything, including a list. It's fine. So somehow it expects this thing to give me a hash map instead of okay. So let's have a look. Build type parameter map. Where are you? Build type parameter map. Oh, you're a separate function. Okay. Which is in type, I think. There we go. Takes, okay, perfect. That's very clear. And so here I'm applying it build type parameter map. That's the one I'm trying to debug. So this is the fun args. Should a function arg inner type? Where is that coming from? Okay, that's correct. That's what I want. And that's the type info of the validated function args. Okay. So something is wrong about the result, I think. Because I zip with this, I get a list. Oh, wait. Yes, this gives me a list, so I get a list of list. So I need to make sure that I concat this. Is I think the problem. Okay. It still expects a list of hash map for some reason. Despite the fact that I'm using this build type parameter map. So something but the way I'm using the parameter maps is wrong. But I'm only using it here. That's interesting. So I am getting, in theory, a list of things. I concatenate it. I do an fmap3 pure. Oh no. I have run out. So let's start putting some types annotation. I'm expecting this, if everything has worked, to be a list of tuple of tuple. This will be a concrete type. And this will be a base name and identifier. God, 10 hours? Holy shit. I should really sleep. I need to be up in 3 hours? So that's the type that I expect this thing to be, and we'll see where it's wrong. So why does it expect a hash map there? I think that's not correct. So let's see then. This I expect to be, when it's done, a hash map. Oh, it's probably again the fact that I'm using it for validate param, and I'm not. Oh no, I'm doing the proper lookup in there. Okay. But still, I expect this to be the result of this should be a hash map from base name and identifier to list of concrete type. If that's correct, then aha. What's wrong? Because I do have concrete types there. So if I concat this thing, I get a list of those tuples. Oh, this is probably just an fmap2 then here. Why do you expect a hash map? What's wrong? What's the problem here? Okay, so if I concatenate this, I get a list of tuple. I do a fmap2 of pure. What's wrong here? What's wrong here? As if this pure was wrong. If I do this to make it clear that I'm trying to make a list, then what happens? Why does it expect a hash map? Do I have another use of unions with? Not in this. Wait. I can probably do this instead and force... Wait! Yeah, no, I'm an idiot. Indeed, unions with wants something that contains hash maps. I've been wrong the whole time. I have been wrong the whole time. So, with that understood, we can remove this type annotation here. And it's not that we need to concat the thing, that is not required. None of this is required. It's just that I need to do a map of from list of the parameter maps. There we go. Huh. Validate parameters maybe, apparently? That's weird. Okay, so no, this is wrong. So validate param using the parameters map, that should be fine. Let's give this thing a type again, just because this is getting way too complicated for me to be able to follow at this time of night. That's a hash map from base name and an identifier to concrete type. And it takes as well a tuple of a parameter name, which is an identifier, and a partial type, which is going to be, I suppose, a partial type. And it's going to return invalidate t of m. It's going to return the concrete type. For that particular, so yeah, concrete type. That's what I expect this to be. Let's see. Oh, come on. Why does it do that? I know that the reference here is the arg type is a validated function arg type. Okay, and the arg expression is... Oh no, I'm an idiot. Of course. Of course it is. That's the problem that's been plaguing me. Wait. Wait, that's weird. Yeah, I suppose this is not a sub-expression, that is just a... Okay. Wait, no. It's a reference. Oh yeah, I suppose. In the case of a reference, I need to check the reference actually rather than... Yeah, okay. So here this will be... This is not going to be a validate function expression. This is going to be... I'm going to have to check that this is actually a local variable. The base name is not in scope for this. That is going to be a problem. But in this case, this is a case where I have the base name. I know it. So I can go back to validate param to the call site. This will be the function name. Okay. Find first non-void. Is that not something that is part of this thing? Did I erase it by mistake? Oh, it's just something that is in the... Yeah, it's part of the struct expression. I'm gonna copy it here. Okay. Apparently I'm expecting... something else here for the validated type list. Oh, because I'm doing... Oh, because I need the key as well. So this needs to give me validate param, not a concrete type, but the tuple of base name identifier and the concrete type. And that's what I'm trying to do here, but this is not that. It's not param name. It is base name param name. Okay. Why do I have some weird additional functor there? Like at this point, we know for certain that this thing is a hash map from base name and identifier to a concrete type. That's what it is. And this is what validate param expects as its first argument. So what's the big deal? Include onions with. It does give me a hash map. Yeah, no, that looks good. So something is wrong there where I don't get a concrete type. Is it because of the validated function, no, the build type parameter map? We know that for a fact. It gives me here, this gives me a list of tuple of concrete type and the base name and identifier. Why are you unhappy about this? What is wrong? Fascinating. Aha. So the type is wrong there as well. That's probably not helping. So now I need to get... Where did I validate the partial types of the parameters? Did I actually do the path params at all? The partial params, there we go. And so here, this would be a zip of the fun params, which is the name of the type parameters, with the partial types. Okay? still this weird type error there. Now the validated function args. Where are you coming from again? Here. Those require. So here I need the identifier, the function args, which means here I'll need to do the second, I think. Validated function args. Yep, there we go. Okay, so no, this gives me. So here I'm gonna need to zip that with something else. So it needs to be with the arg names. Problems like at this point I'm just following the types. There's probably a way to clean this to be less ugly, because at this point it's just a bunch of I'm gluing this together, and this could probably be cleaner. Yeah, this is gonna be zip first of the fun args with this. It's still broken for some reason. Aha, and here I will want to do inner type thing, function arg inner type of this. Why is it still broken? That's fascinating. It's gonna be wrong as well. Yeah, it's completely wrong. That is completely wrong. Okay. So the validated function args are typed validated expression. Oh yeah, no, I need the types here. This is wrong. I need the types. Would that be actually if I remove this nonsense and I put the second back here? Oh wait, no, that's correct. I can just do the same thing here as here. That's what I need. There we go. Because a function type info contains yeah. So it's going to be this with this. And That is still broken. That is maddening. Oh, yes, and of course, I need to. Um, oh, probably. That's. Isn't that the same problem? Is that the function arg inner type that I need to. No. Oh, I want the function archetype there. Interesting. I want the function archetype. Yeah, of course. That makes sense. Okay, let's comment this out for now. Just want to make this work. The validated function arg will give me. That's the wrong one. No, it is build type parameter map. That's correct. That's the validate function call argument. It gives me a typed validated expression that I get there, that I use here for the type. Okay. What's broken now? That's still broken. I thought function name was a base name. What? What? Function name has been. Wait, has function name been a. No, no. It's been a base name the whole time. It's a role, and as such, it's a base name. Yeah. Okay. So function name is a base name. So here, when I create the name, what on earth are you? Oh, because I have already something. Okay. So let's rename it to base name to avoid that problem, like it was before. By changing the name all the way here. Okay. Oh, this is now an error in another function? Could this have been... No, this error is still there. What the hell? But now I have an error in validate param. Maybe that starts to be the problem. Aha, yes, indeed. This is supposed to be a list of concrete type here. This is supposed to be a list of concrete type here. My type annotation is wrong. Concretized type is probably a regular maybe. Yep. Okay, so for the error function incompatible types, no, I guess I can make them a this a non-empty concrete type. Well, no, it needs to be empty since I want to fold. No, okay, so that means the diagnosis for error function incompatible types. Error function incompatible types. This is a list of concrete type, and this is probably going to be a list of concrete type here as well. Where are we here? Okay, so now oh, it's just a problem of verify type being unclear. That is just very clearly a concrete functor, I believe, at this point. Okay. So I don't have the check for references, and I have something that's missing, and that's maybe a good point to stop after this. I can probably remove some of the annotations. There's one thing I'll try to see if I can fix. Because this whole thing is a nightmare. It's horribly complicated. It doesn't need to be that complicated. Okay, so yeah, it all perfect. So let's redo this and let's read now that we have something that compiles. In the case where I have a let expression, I can retrieve the variable type, which gives me the concrete type info. In which case, I create a fake name, a fake base name, because I don't have the base name of the function. I use that to validate the number of parameters, which must be 0. This is a concrete function. I validate the argument by doing a validate function call argument. And that gives me, if it succeeds, I try to check that the type matches the function type. So I'm calling a function int with an int, and that's all fine. And I return the validated argument. So here I have a full list of validated arguments. And I can return a typed expression with the function return type that I already know from the context, which is a variable call expression using the identifier, the function type info, that is this one that has not had a need to be reified, and the validated arguments, which is just what expressions I'm sending to the function. Okay. For a function call with a function name, I retrieve the function type, which is this thing, but it is parameterized by the type. So I validate the parameter count. I validate the partial type of the path parameters, okay? And I have this named partial params. So here I could replace this with named partial params. I had already done this. I collect a parameter map, which is building from the concrete type. So I validate the function call arguments, which is just checking value and reference stuff, okay? And that gives me the validated expression and the actual type that I choose to ignore. Can I choose to not ignore it instead? I can completely ignore it because I can always get it from the type info because that is a bunch of typed expressions. Okay, so now by extracting the inner type of the parameterized type, I build the parameter map. I do this thing where I create a type list by checking each parameter individually. Okay, that makes sense. And I can validate using this, the return type. And here, the only thing I'm missing is the argument to the type of the arguments to the function now that they've been reified. Now that they've been reified, would that just be rather than doing complicated things, is that just an fmap to a refi type at concrete functor using final mapping is going to be this thing. Isn't just that the final mapping on the original fun arguments? I think it might be. Ah, okay. No, it's not. So reify archetype is what I want to do. Reify archetype is just going to be given some mapping is going to be the case of by reference. God, every time I have to do this, this is going to be refi type at concrete functor of the mapping and t. This is going to be and by reference of this, and by value will be the by value of this. Those function archetypes. Those are the validated ones. Okay, and that's the end of function expressions. At this point, I might as well try to finish, see if there's anything left. Huh. It looks like that's this now. And I don't need to give... Ah, guys, and I'll be one of those again. Result constructor. Yeah, okay. Let's see. Okay. And the struct exp there is the same thing. Okay. So indeed, that's just taking for some kind of expression. And is it a concrete functor in both cases? It is a concrete functor in both cases. So I take the struct info and I return some kind of typed expression. Oh, except this is not correct. This is going to be an E here. And I'm going to need to do the typed thing afterwards, which I might already be doing. I am already doing. Okay. So that's already a bunch of errors fixed. Oh yeah, I'm missing a field here. I am missing the non-empty identifier type of E. So I'm gonna make this into new lines. Okay, and this is not, this is a typed E, in fact, here. So now at least calling this thing should give the right... What's wrong here? I don't see what's... Oh, of course, I still have the name of the arguments, despite the fact I am 0.3. That's why. I'm getting tired if I'm not spotting those immediately. Okay, so here this is the same logic as for the function, but I don't have the function arg type, which is going to be making things a lot easier. Is this the one that's wrong? Yeah, parameters map, that's the correct name. Result constructor, that's just a typo. Error, not a struct. Huh. The struct type params are just... Okay. Those struct type params are obtained from the struct type info, which is obtained from retrieve struct. Those are parameterized. Okay. Yeah, this is wrong. This is wrong, I think. Yeah, okay. My brain is no longer working. I'm gonna stop here, I think. It's a shame I didn't get to a point where I could try things, despite pushing pretty hard. I'm not super far, I think. I think there's just the same kind of errors we've had function calls to fix for structs and for type resolving, because that stuff is difficult. Okay. All of this is in the struct type stuff. So we'll do that next time. That's typed bool type of a literal Boolean literal const expression. I can fix that. That's an easy fix to do. Likewise, this is an int literal const expression. So okay, now there's still too much to do. I'm stopping here. God, 11 hours. That's absurd. I can't keep pushing like this. Anyway, thank you for tuning in. I should get some sleep and wake up in 2 hours. That's gonna hurt. And yeah, thank you for being with me for this absolute absurd journey. And see you next time.